Hello and welcome back to my channel. Today we are starting a complete new journey. This journey is about creating an AI engineering crash course. So today I decided to build one of the most complete crash courses that you can find on YouTube about AI engineering. So in this course, I'll be giving you all the tools, the programming languages, the frameworks, the concepts that you need to fully understand AI engineering. So we'll go from zero. Zero means you know nothing about AI engineering till building complete, complex, and deploy complex project with AI engineering tools. So let's get started. In this course, we'll be actually helping you go into your journey of learning AI engineering and using this LLM at your advantage, actually using it to build interesting tools. So this is the program of our course. We have 9 modules. The first module will be introductions. This slide is part of the introduction. The introduction will contain a difference between AI engineering, ML engineering, data science, and software engineering. So you know a bit what is what and how to classify these 4 fields. We'll give a big introduction about LLMs, like where we started and also where we are right now. We'll give an introduction about API and SDK as well, so you understand what is an API and what is an SDK, because we'll be using it a lot throughout this course. We'll also give an introduction to Python and JavaScript and give you the resources that you need to learn to complete this course. And lastly, from this introduction, we'll just give you some things that you need to consider before getting into the course or after getting into the course, because if you build an AI product, you need a front end to test it. So we'll be giving you all the tools that you need for that part of the course. So the second topic is about prompt engineering. So I decided to start with prompt engineering because it's a quite interesting and important topic. You can build one of the most sophisticated AI system out there, but with the wrong prompt, it will be worse than the person that built a simple system with the right prompt. So prompt engineering is really, really important when we talk about AI engineering. So I created the second part of this course. So I decided that the second part of this course will be about prompt engineering, where we'll be talking about why you need to consider prompt engineering, all the parameters that you actually need to consider while creating AI software, different prompt engineering technique like zero shot, few shot prompting, chain of thought, React prompting. So you have a palette of choice when it comes to prompting your systems. Later in this video, we'll talk about testing your AI, testing your prompts. But from this first part is actually zero code. You don't need to code here, you just need to understand how to write better prompts. So this will help you just in everyday life using AI and also coding and giving instruction to this AI in your code. So yeah. So the next module will be about API. We'll just go through all the APIs of all the best providers that we have out there. We'll give you a complete overview of OpenAI API, a complete overview of Anthropic, Google, Grok, XAI, DeepSeek, almost all the providers that you have out there. We'll also give you something really good, which is all of this platform together, OpenRouter and Replicate, to be able to host and query open source models. And lastly, we'll just introduce LLM frameworks like LangChain, Haystack, and Llama Index. And at the end, I'll just present one project and we'll do it together. Okay, so the next module of the course actually open source. We'll talk about open source. It's actually a really big part of LLMs. So we need to talk about Hugging Face, tools and libraries that you need to know to be able to take the full advantage of these technologies. We need to talk about open source models. We need to do a quick introduction to fine-tuning because most of the time using the open source model come with fine-tuning them. So we'll talk about fine-tuning here, but we'll give a better overview of fine-tuning later in the series video. And we'll give a brief overview about how to deploy open source LLMs and integrate it into your application. And here, the next part is actually about vector database and RAG. Building systems is quite interesting, but now we need to make it accurate. And RAG comes into play here. We'll just be explaining from the base what are embeddings, what are vector databases, and give you some providers and how to set it up. Explain what is a semantic search and what is querying a vector database. tell you a bit more about retrieval augmented generation, tell you more about chunking text and handling errors, present you some libraries that will help you do this RAG quickly and efficiently, and build a sample project at the end as well. The next part of the course will be about building AI agents. So here we'll give you a brief introduction about AI agents, build AI agents with OpenAI functions calling, show you how they can build that without any framework, and then give you an overview of how to do it with frameworks. So we'll give 4 different frameworks here. We'll talk about LangGraph, CrewAI, AutoGen, and OpenAI Swarm. So the OpenAI Swarm is still in development, so we just want a simple overview of the framework, but you'll have everything you need to build AI agents. And at the end, we'll have a project. So here is a free module I just decided to add to the course, which will be about integrating image generations into your app using LLMs or using image generation API like DALL-E or others like Stability. Stability is actually open source, so you can use it in your computer as well if you want to. So we'll just get into it here. And the last part before the project, we'll talk about security and safety and compliance, which is quite important when you talk about AI engineering. You need to consider security measure, safety measure, and be compliant in the region where you're operating. So this module will talk about that. And at the end, we have a really big project. We'll be building a complete AI-powered project, deploy the projects, and then give you the next steps so you can continue your journey. So if you're ready, we can get started. Hello everyone, welcome back to my channel. Today we'll continue our series of video about AI engineering. So in this video, we'll talk about AI engineering, ML engineering, data science, and software engineering, and what's the difference. This video is actually the second part of a really long course where we'll be going through everything you need to know to start your career in AI engineering. So let's get started. So let's start by some definition and core objectives. What is data science? What is machine learning engineering? And what is AI engineering? So this will give us an overview of these topics. Data science focuses on extracting actionable insight from structured or unstructured data using statistical analysis, visualization, or predictive modeling. And machine learning engineering includes a bit of data science, of course. It's a subset of AI that specializes in deploying and scaling ML models into production systems. But AI engineering, on the other hand, is the art of building intelligent systems that mimic human cognitions. You may see it directly. If I ask, where is ChatGPT in this topic? Yeah, maybe you got it. ChatGPT is in AI engineering. As you saw, it's building intelligent systems that mimic human cognition. But AI engineering includes all of these topics. As I said here, it combines machine learning, it combines data science. It's one part of software engineering as well. So yeah, it can help you to create intelligent system. You need many different fields. So now, what are the key differences between these different jobs or different fields? For data science, the primary focus, maybe for data science first, is data. So it's in the name, data science, data. Machine learning engineering is models and deployment of models. AI engineering is building intelligent systems, and software engineering is software. Now, the core tools that you use in those different technologies are, for data science, is Python, R, SQL, Tableau for data analytics. For ML engineering, you need DevOps tools like Kubernetes and Docker. Also needs machine learning knowledge like TensorFlow with PyTorch or PyTorch. And for AI engineering, to be honest with you, you need much more than Python LLMs because it's actually the merge of everything. So sometimes if you have to fine-tune a model yourself as an AI engineer, you need to understand the underlying architecture of the model. So you need to understand PyTorch or TensorFlow. But let's just simplify it and say you need Python and LLMs and maybe JavaScript or understanding software in general, as well as data science in general. For software engineering, it's quite simple. You need Java, Node.js, C++, Golang, all of these languages, Git, CI tools. to be able to build and deploy the software. And then when it comes to outputs, for data science, you have report and dashboards. For ML engineering, you have production-ready models. For AI engineering, you have autonomous intelligence system. So when you hear autonomous intelligence system, you may have an end product, but this end product include many of the things that we talk about here. The autonomous intelligence system can be Siri, but if you consider Siri, Siri is a mobile application. Siri has a model behind it, and Siri use voice communications and use surely a lot of data in the training step. So AI engineering is actually kind of the mix of all these fields. So that's the point I'm trying to make here. And for software engineering, of course, is having a functional software at the end. For the key skills here, for data science, you need statistics and visualizations and more, of course. For ML engineering, you need MLOps. It's like DevOps, but for machine learning, you need machine learning knowledge, distributed computing knowledge to be able to train and monitor your system, or maybe do inference on cluster, for example. For AI engineering, as I said before, you need a bit of the three fields as key skills. And as software engineer, you need system design, debugging, testing, deployment, and yeah. And here you will have maybe a bit more visualization of what all of this will give you as result. So applications in data science, we may have fraud detection or business intelligence. In ML engineering, you have recommendation engine or classification or sentiment analysis systems. In AI engineering, you have automated agents, automated AI agents, voice assistants, chatbots. And in software engineering, you have web apps, SaaS, enterprise software, and more. Now, when it comes to the role breakdown, as a data scientist, you may do data cleaning, data analysis, and building predictive models. And you use tools like Python, R, SQL, and statistical modeling. As an ML engineer, you need to optimize for model latency. You need to know how to deploy the model. You need to monitor model performance. You need to build a complete pipeline for model monitoring and model training and evaluation on production. So you need to build the model as well. So you need software engineering skills, DevOps skills, and some part of data skills and hyperparameter fine-tuning skills. As an AI engineer, you need to be able to design neural networks or understand neural networks, because sometimes you need to fine-tune models. You need to integrate AI into products, and you need to have knowledge about compliance, security, and ethical AI practice. And these skills come, and the associated skills are LLMs, natural language processing in general, software engineering, computer vision, reinforcement learning. This is part of ML as well. So, and software engineering, you need to be able to build scalable system, debug and maintain systems. So you need full stack development skills, version control, deployment skills, and maybe some agile technologies. And agile technologies come actually in ML, data, and AI as well. So this is some kind of role breakdown. You have some overlap in between. So it's not just strict as I mentioned it, but you have a better understanding and a better overview of these 4 different topics. So now, when it comes to salary breakdowns, data scientists in the US, I want to mention it, you have salaries between 120K to 150K, ML engineer 140 to 180K, AI engineer 150 to 200K, and software engineer from 90 to 160K. The key takeaway from this presentation is that AI engineering help you create intelligent systems, help you create, deploy, and maintain intelligent systems. And AI engineering is actually a merge of data, ML, and software. So in the next part of the video, we'll do a quick introduction of LLMs, and we'll understand a bit more where we started and how we end up to our actual architecture of LLM. So thank you for watching, and see you in the next one. Hello, welcome back to the AI Engineering Crash Course. Today we'll do an introduction to LLMs. This is the third part of the first module of the course, where we'll just be going through the history from the starting point till the LLM, so you understand where the LLM come from and the generations of model before LLM. So it's a high-level overview. We'll not be going through technical details or mathematics here. It's just a means for you to understand what the LLMs are and where they come from. So get started. As we said at the beginning of the course, everything started with data. And the vast amount of data that we generated online brought us to a point where we tried to find ways to use this data efficiently. So we were able to actually get this data and get some key information from the data. And from that data, we wanted to see into the future a bit. Okay, so we wanted to create some correlations between what happens before and what will happen next. And this drew us to an era where we had amazing technologies that only help to predict the future. So, say predicting the future is a bit old here, but the goal of the technology was to actually try to find correlations between data that we have right now and what could happen in the future. And this technology brought us to machine learning. And what exactly is machine learning? So machine learning is a subset of data science that study, or it's a subset of data science that actually aim at creating models that are able to predict values of new data based on past data. So let me just give you an example here. Let's say we have multiple points like this. Okay, we have a data like this, for example. The goal of machine learning is to say, hey, I'm seeing a kind of correlation here. Maybe this actually looks like this curve. And if we just in the future, maybe have a point like this here, we may guess and get its value. And this is in some kind of, something like this. I hope you understand mathematics, otherwise it's not fun. So we do this, we have this. And if the goal is to say, okay, we have this kind of correlation between the data. And if we get a point here, it's probably something related to something here. And we may get a value from it. So we have so many machine learning algorithms. We have random forest, which basically is a simple decision tree. So you have maybe a starting point here that will say, oh, this happened, then do this. But if it is this, do this, it's kind of simple. It's actually many useful classifications. We have random forests. We have many other machine learning algorithms that are quite interesting. And from this algorithm, you are actually able to either classify things or predict new value based on actual past values that you use to train the model. But the issue here is most of the time you need a strict way of organizing the data, a strict data feature extraction, which means extracting things that will influence the behavior of the model from the data. This is quite complex, especially for all the data we have online. So we try to create a new field that will be like a black box, like a magic spell. So we just give it the data. It makes sense out of this data. And then you just ask for new predictions. So you don't need to know, oh, do I need a decision tree? Oh, do I need a regression algorithm? Or do I need whatever? You just pour the data in and you get something out. And this field is actually called deep learning. So deep learning is a field where it's a subfield of machine learning, where I will just simplify things here, where we try to make things as simple as possible. So we have a set of data. We try to mimic how we think, how the human brain is created. And we give information in and we get information out. It's the same, maybe you see something and it trigger reaction, right? So a lot of neurons in your head made this reaction from the action, from the input that you got. So it's the same that we are trying to reproduce with deep learning. We have a set of neurons. It's still, rounded corners, rounded balls like this. We have hidden layers, some kind of layer. So let's say these are actually, human brains. And we have output layers, something like this maybe. And we try to connect them. It's not okay. So let me just change the color because now it's not readable. Something like this. And we do a lot of mathematics. Okay, some mathematics to be okay. So if we give this input, you need to calculate the amount of a lot of mathematics things that will give you the right output based on the input that we gave. And this right output may be the prediction that we are looking for. And most of the time, it works, right? Most of the time, these models are able to capture the correlation in the data that we give to the model. This is quite interesting. So we are now able to feed the data to a kind of model and get back some kind of prediction. So we are now able to predict the future, basically. But the problem is, from this model, we cannot keep a kind of sequence. So if you give some kind of data here, you get input and output. So you are not able to give a structured data to this model here. You're not able to maybe give a text. Let's say you want to translate something from English to French. How do you build this kind of model? Let's say you want to predict stock prices. It's kind of an historical data. You need the strict order of things, but this deep learning model cannot do that. So we come up with different architectures, and these architectures included recurrent neural networks, LSTMs, and then transformers. So this is actually here to help push limits of deep learning that we had, and this helped solve the problem. I think the latest one were transformers that Google published a few years ago. When Google published transformers, we didn't really have a really big breakthrough. After that, I think Google created Google Hello, a kind of chatbot, publish it online based on that, create some models, BERT, and some few models and publish it. But it wasn't that big. It wasn't that huge. It was a great technology, but it wasn't used efficiently. But the power that comes with transformers is actually what? With transformers, with deep learning generally, you have a hard time doing it on a large scale of computer on a really, really big amount of data. So you need, it's hard to scale basically, if you have to put the software terms here. But with transformers, this is actually possible. We can do it on a cluster of GPUs. We can feed it so many data. We can do parallel training. So the architecture is good enough for scalability. And then one company, I think created in 2016, started exploring how to reach AGI. That company is actually OpenAI. And they started by trying to feed the most data possible to a transformer model. They started by creating GPT, open source, GPT-2, open source. And then in 2020 or 2021, I don't remember quite well, they created a model called GPT-3 that has, I think, 360 billion parameters or 200 billion parameters. And we started seeing new features from this model. So remember from the beginning, I said, deep learning model are kind of a black box thing. You feed the data and the deep learning model figure out what to do with it, right? So right now, it figure out what to do with it, but kind of much more than what we expected. It was able to do things that we didn't even know a model can do. So we found a pattern here. Maybe if we scale this model more and more and more, they may do things that will be more and more and more complex. And from there, we had scaling transformers, we had LLMs, large language models. And these large language models basically are just a bunch of data. So if you get a large amount of data, let's say this is data, and you properly feed it to a transformer model, using a lot of GPU and burning a lot of money as well. I think basically now it's like 6 million from the DeepSeek standard. You are able to get an intelligent model at the end. And this intelligent model will be able to have skills that you didn't predict the model will have. So it will be able to converse, to translate text, to do mathematics, to understand physics, and many, many, many more things only based on training data. So most of the time you have a completion model at the end. So here you just have a model that can complete text. So you can say, hello, I am, and it will complete, just say, oh, I'm this guy from this country doing this, because the model saw that a lot of time and know how to work with this kind of data. So what it's doing under the hood is that it is trying to predict, this word based on what it got before, right? And surprisingly, this is working. So it's able to predict coherent text. But now, in order to have a much more specific use case being teach to the model, we need a second step, which is actually either reinforcement learning or fine-tuning. So we need to go from this completion model to a model that can do one thing specifically well. And we need to do some kind of supervised learning here, where we feed some real world examples to the model, like let's say a conversation or some text, some code or whatever. And the model will learn from this kind of data. And then we'll be able to do that specific things. The model actually from the base training has some kind of knowledge that will help do many, many things. But now if you specialize the models in one thing, the model will be good enough to perform that thing quite well. So from this large language model, GPT 3.5, we got ChatGPT, which is actually a derivative of the completion model specially made for text. We got coding models, we got many other models for many other specific things. And now we are here able to build incredible apps on top of these LLMs, thanks to this evolution from data, machine learning, deep learning, LNN, transformers, and then scalable AI today. So today you still have some kind of mixed architecture using transformers and mixing it with some other kind of technology or some other kind of routing mechanism. But under the hood, most of the time it's actually just scaling transformers. Hopefully we'll get a better architecture soon that will propel the model to next frontiers and maybe make them more intelligent. But for now, this is kind of the base introduction to LLMs that you may have, that may give you a high level overview of why and how we ended up with LLMs. So yeah, I hope you understood everything from this part. If you have any questions, leave them in a comment below. Thank you for watching, and see you in the next part that will be about API and SDKs. Hello everyone, welcome to the AI engineering crash course. Today we'll do the fourth part of the introduction, which is about API and SDK. So as you can see here, we have talked about AI and AI engineering, the difference between AI engineering, ML, data science, and software engineering. We did a simple introduction to LLMs, and we'll go from this simple introduction to API and SDK. Let's get started. So basically, in the last video, we went from big data, the need for correlation, machine learning algorithms, deep learning, transformers, with just a high level overview of all these things, to here where we have LLMs. But now let's imagine you're a company like OpenAI, build a really big model. It's doing incredible things, but you cannot build everything on top of it yourself. So you try to outsource it to other people. How do you do that? You create a way for these people to access what you did. So we need to find a canal or a way to actually provide your service or your model to other people to use it for their own use cases. And then here comes API and SDKs. So what's an API or an SDK? An API is actually an application programming interface. It's an interface that helps you access functionality from a system, but restricted. So it's like a proxy. So you have here your system. Okay, let's say this is your app, and you have a kind of proxy here that give you access to certain part of this infrastructure or this application. And you have here a system, like this system is the LLM, for example. Sorry for my handwriting. So your app will go through this API. This entry point is actually like the door. It will allow you to do some things on the model that's being created here. So you actually define at this specific place how everything is being handled. And this specific place is actually an API. So we need to understand a bit more what is an API today. So normally in programming languages, if you have ever built something with a programming language before, you have libraries. So for example, if you take Python, when you want to deal with networks and web applications and routing and everything, you can either do it yourself or you can do it with an application or a library. This library can be FastAPI or Django. Let's choose FastAPI. If you choose FastAPI, what you are doing is actually using pre-written functions to access a much more complex implementation of that logic, right? So these functions are actually like an interface for you to access that. This is actually an API. Same for when you try to logging into any other system. What's happening here is that this system will connect to some other kind of interface, and this interface will allow the system to perform some things. So let's take a really simple example here. So you go to ChatGPT and you go to the inspect, you go to network tab, and you try to type something like that, hello world. You will see that there are some things happening here. These things are actually calling an interface to ask for some specific informations. So this app that you're trying to interact with right now is asking to some kind of system, can you autocomplete this for me? This guy said, hello world. What else can come after hello world? And then the system will just say, okay, this is your response. So you, as the front end or as this app, you don't need to understand or know what's happening under the hood of this system. You just need an entry point and an output format, okay? And this is your communication scheme. And same for all the systems that have been built using LLMs, you need to access some kind of API. And as we already presented them, I'll just show you here what those API are for Anthropic and OpenAI. So here, if you go to the OpenAI documentation, you will see here OpenAI developer platform. So if you go to the quick start page, you'll see here that you have they're explaining how to access your model. You need OpenAI key, of course. So what you need to do is to go to your account, go here, and then your profile, and then API keys. So when you click on API key, you will generate a new API key. Create a new API key, and you give a name, and you select a project, and you create a new API key. And then this API key will actually be like your pass. So here, this guy will say, oh, do you have an API key? Is it valid? Okay, I can give you access to all this system. But if you don't have an API key, let's say you are someone in red here, you come here without an API key, it will say, no, I cannot give you access to my LLM. You need some kind of key to access this party. I don't know how it calls. This is the role of an API, to actually be the proxy between everyone accessing a system and the system itself. And in our case here, the system is the LLM. It can be OpenAI LLMs, Anthropic LLMs, or whatever else. And as you can see here, when you get your API key, you can go back to the documentation again and go to the quick start. When you get the key, you need to click here. You have a kind of standard way of accessing this API. This is a normal HTTP request. So normally, whatever you do in the browser, it's actually sending some kind of HTTP request. So if you copy this link here and go into Postman, so it's simple, just type Postman on Google, you create an account, and you're able to access it. I'm already logged in, so normally you create an account and you have access to Postman. Otherwise, you can download the app as well on your local computer, and you have access to Postman as full. But if you have any question, let me know in the comment. I will help you. I will do a simple tutorial presenting Postman if you don't know how to use it. But here in Postman, if you paste the URL here, and you need to come to the authorization here, they mention in the API that you need the header authorization. So you need to come here, authorization, URL token, and paste your API key. And then content type application JSON, normally it's by default. So we have here content type application JSON. And you are now able to access the system. So you have the keys, you have access to the party. So you can just come here, copy this, and now you can ask whatever you want to the model. So if you ask here, tell me more about yourself, and we send this, it takes some time, it verifies your key, make sure everything's good, and you get a response from the AI. So this is the base way to access this API. As you can see in the name, we have API already. I am an AI language developed by OpenAI. This is the response that you get from the model. This is the format that you agree on with the provider of the API. You actually need to have 3 different components to access this specific API. You need a key, you need some kind of headers. This is simple things. You need some kind of input, and this input will be how the system agree that you will communicate with them using that specific format, and you get some kind of output. And this output is actually what they prepare for you, and you get the output and you work with it. This is like the application programming interface. So this is the interface between you, your app actually, and the system, which is LLM in our case. So it can be anything. GitHub has a public API. SpaceX has a public API. You have a lot of applications that have APIs out there. Google Drive, Google have an API for you to manipulate your files. So a lot of systems out there have APIs, and these APIs are all the way for you to access their system, but in a protected way. So they can manage what you're doing, where you're doing it, and how you're doing it. So that's the reason why you actually most of the time need a key to access these systems. Now, you can see that doing this is kind of tedious, okay? If you're building an app, sending HTTP requests for everything that you need to do is hard. It's just repetitive. You need to build everything yourself. You need to understand how their system work inherently. You need to understand, okay, I need to send this format, and I'm getting this format. And they have so many different formats here. So if you check for after authentication, you will see you need temperature. So you need to understand a bit more, getting into a bit more what they are offering in the API. You don't have to do that, right? We need a simple way. We have a simple way to actually access these systems. This is what we call an SDK. An SDK is actually a software development kit, which is provided most of the time by this is the API reference. This is the API reference just in case you need to, do it manually using API, role developer, the header, you need to set them yourself, the key and everything. But they provide also an SDK. So the SDK is a simplified way of for you to access these systems. So if you come here again and you come to the JavaScript, you will see that you install this and you just directly use the system without having to care about which URL it's using under the hood, which headers it is adding, and where to put the authorization key. You just have like a simple interface that will help you access these systems. So this is what you call an SDK. So normally when you develop an API, you have a layer on top of it that will help facilitate access to your API, which is an SDK in our case. And in right now, almost all the providers have some kind of SDK or some adaptation to this SDK. The OpenAI SDK is the most popular one because they have you have a specific trick to actually support many other provider using the OpenAI SDK, using the base URL. And then Anthropic also have an API reference, and they also have the SDK. So if you click here, you can get a key, of course. But in Python, you need to install a package called Anthropic, right? And this Anthropic package will give you access to this thing. You just need to say, oh, client.message, just create a new message. You pass the model, the max token, the temperature. We'll go through these parameters a bit later. And then this is the input data, and you directly get the output. But if you need to have the API reference to actually send this request yourself, this is the URL, this is the header, This is the header. You know, you need to actually set this yourself and actually manipulate the API yourself. So if we have to resume, API is actually application programming interface. It helps you access other systems, but in a secure way and in a more restricted way. So whatever you do on Anthropic API, they will know it's you because you have a key. That's logic. So they have like a protection layer on top of your system that give you access to specific part of the system. And then to simplify things more, this provider create SDKs. And this SDK gives you much more simplicity over HTTP requests, header setting, and many other things that you can do with your system. So I think we went through everything we needed to say about API and SDK. Thank you for watching. In the next part of the tutorial, we'll talk about Python and JavaScript in general, and then the programming language we'll be using throughout the whole course. Yeah, thank you for watching and see you in the next part of this crash course. Hello everyone, welcome back to the AI Engineering Crash Course. Today we'll talk about Python, JavaScript, and UI. So in this video, I'll just be giving you some advice, giving you some tips, giving you some libraries, giving you some tools to help you learn and understand JavaScript and Python so that you can go and start confidently this complete tutorial. I'll also be giving you some UI tips just in case you want to extend the project a bit more. And yeah, so this is the last part of the introduction where we went through AI engineering, ML, data science, and software engineering. We went through some kind of history of LLM. We talked about API and SDK, and now we're talking about programming languages and UI. So it's just a global introduction to the whole course. And then after that, we'll talk about prompt engineering. So we'll go through prompt engineering challenges, why you need to understand prompt engineering. We'll talk about parameters that the model gets and why it matters. And then we'll talk about zero shot, few shot prompting, all the prompting technique that you may need to know as a programmer or as an AI engineer. So get started. So from the last video, we went through all this, explaining machine learning, deep learning, LLM, SDK, and APIs. And as you may have seen, most of the code that you have here are either JavaScript or Python, right? So we need to choose. It doesn't mean you cannot build LLM with other programming languages, as I mentioned it, as I showed it using our Postman interface. This is just an HTTP request, and this HTTP request can be reproduced by almost any programming language out there. So you can create your AI tools with Go, Java, PHP, or whatever you want. But you just need to, you will just lack the SDK and a lot of libraries. So it will be a bit harder, but you can do it. So this is the reason why we have to choose between Python and TypeScript in JavaScript in general. But for the sake of simplicity, we'll go with Python. We'll be working with Python throughout this whole course. But as you will see, these libraries are basically the same. So if you learn either Python or TypeScript or JavaScript in general, you will not be missing something. You will have the same API, you will have the same SDK, despite the fact that the Python environment is a bit more developed for machine learning, AI engineering, and everything. You will basically have the same thing. The advantage with JavaScript, on the other hand, is that you can build full stack applications, really reactive applications directly with AI using incredible libraries that I'll be showing throughout this video as well. So, yeah. Now, how do you learn JavaScript or Python? I will put in the description of this video some really great course that will help you get started with JavaScript and Python. But if you know JavaScript and Python already, it's good. So you don't need to learn again. You can just go to the next part of this video, which is prompting, and start learning from there. Also, concerning the installations that you need to work, you just have to go to Google and type Python. Oh, sorry. Search for the logo of time. So you come to the python.org. Pretty simple. You have a download. You click on these. You will download Python and you will install it. As simple as that for your operating system. So you have Mac OS, Linux. It's actually on almost all the operating system unless you want to program on your phone, but you can install Python almost everywhere. So as you may see, Python is pretty simple. The language is kind of written to be as easy to read as English. So you just define a function, while this happens, print this, it's actually an easy language to learn. Same for JavaScript. So you can choose either of them, but with this tutorial, we'll be going with Python. Now, what about UI libraries? We will be using Streamlit because we went with Python. But if you want to know about more about other libraries that are out there that you can use to build AI application, you have React, which now needs some kind of framework behind it. React is a really good front-end framework that can help you build front-end pretty quickly. You also have Next.js. I think it's a go-to solution most of the time because they have the AI SDK, they have simple integration, they have direct backend, and it's the easiest way to get started with front-end. So you need to go to the Next.js page and start learning. They have great tutorials. You can see a lot of content also out there on Next.js. And if you want to know a bit more about Streamlit, it's a simple solution to help you quickly prototype applications so we can use it in our process just to create some quick UI to test our application and test what we are doing. So as you can see here, we have this simple line that will create this simple app for us. Same as for everything, you just come to the web page here. You have the line to install Streamlit here. Click on it, and you will be installing it later, and you install it. And normally when you say Streamlit hello, you'll see something. For the UI, we don't really have a UI. Otherwise, we'll be using either V0 or bold.new, but we don't really have a UI for the moment. We'll be doing everything with Streamlit, so everything is good there. In terms of tool that you need to install, I think I gave everything. Python, you need to install Python. And then I will show you how to install Streamlit, how to install all the packages that you need to work with Python. And then lastly, at the end of the video, or with the project that we're doing, we'll integrate Fast API. So just need to type Fast API. As the name suggested, it's a quick way to make APIs. And we talked about API before, so you need to understand, you must already understand what an API is. So this will help you yourself create your own API pretty quickly. We'll also be showing the whole process of installing it, configuring it, and working with this. So yeah, I think we went through everything we need for this tutorial. In the next part, we'll talk about prompting challenges, and prompting in general, prompting techniques and everything. So this is the end of the first module. See you in the next module. And don't forget to subscribe. Forget to say that. And comment if you have any question or any issue. Thank you for watching, and see you in the next one. Peace. Hello and welcome back to this AI engineering crash course. In this second module, we'll talk about prompt engineering in general. And in this video specifically, we'll give you a broad introduction of prompt engineering. So let's first start by going through what we did before. So in the first module, we had a brief introduction about the engineering field and what's the difference between AI and AI engineering. We also gave some difference between AI engineering, ML engineering, data science, and software engineering. We gave a brief introduction about LLMs and where we came from to have LLMs today. We talked about API and SDKs. We also introduced Python and JavaScript and some UI libraries. So in this new module here, this prompt engineering modules, we'll be talking about prompt in general. We'll also be talking about a few terms that you may hear, that you may encounter while working with LLMs, which are token, temperature, pricing, and max tokens. And then we'll do a long video giving you some of the prompt engineering techniques that you may need to know while working with LLMs as a software engineer or just as an end user. So let's get started. So let's first start by defining what prompt engineering is. So, from the video about LLMs, we had a really long introductions to this new architecture. So it went from machine learning to deep learning to RNN to transformers to large language models. At the same time, we started with computer and we were able to actually give instruction to these computers using extremely low level languages. We used assembly, and then we made it simpler, like with C, C++, and then Python, and then JavaScript. And today, we can actually instruct a computer to do something with natural language. But the problem is, we first started with a strict language because it gives some kind of base for everyone to write a clear instruction that the computer can understand. So if we say two same things at two different people in natural language, they may hear two different things. So if even between us humans, it is hard to communicate using natural language, how hard will it be for a computer? So having a clear set of rules and a specific ways to communicate with these models are quite important. Otherwise, it will be pretty hard to get the expected output. We will have a lot of unexpected results. In the word prompt engineering, we have prompt. A prompt is actually an instruction in plain language that we give to an LLM. It can be write a specific text for me. It can be solve a specific problem for me. It can be go online and do these specific things. And prompt engineering is a field that give you the tools and process to write better prompts. So let me give you some overview of challenges. If you take two different apps, let's say you have ChatGPT 1 and ChatGPT 2. If you write two different prompts from these two applications, you will have two different apps, completely different, based on the prompt. So if the first ChatGPT you say, be free, speak about everything, normally without any barrier. And the second one, you say, only talk about books and talk like Harry Potter, we'll have two different outcomes, right? So you need to know how to write the best prompt to actually get the best output, the expected output from your model. So this comes with a lot of challenges. How to write in plain language instructions that a large language model can understand. And also how to format it, how to get the best out of it, because we have a lot of ways to say the same thing in natural language. So how can we make sure that we have the best way of communicating our intention to this model, knowing that the language is not actually strict? So the field of prompt engineering is actually helping to structure that and give you the tools that you need to actually write better prompts for your AI application, and for your day-to-day use of AI. So, yes. So when we first had LLMs, people started noticing that we can just get answer from plain English, right? And then we had few people giving some different complex prompt and getting different results. And we started having a research on how to improve the accuracy of models only based on different prompt techniques. So we got zero-shot prompting, few-shot prompting, chain of thought, React prompting. So all of these techniques are actually documented research that you can look online and see how it improved the accuracy of the models. But what I can say in general is that maybe in the future we may not need that level of preciseness in writing prompts, because we'll have far more better models. But even in that case, you need to be able to communicate what you want to the model. So if you're not able to do that, you will not be able to get the expected outcome. Second point that I wanted to talk about in this video is actually security. So if you have a really weak prompt, everyone can jailbreak your prompt. Jailbreaking a prompt means hacking the prompt to make the AI system do what it was not instructed to do. So if you just say to an AI system, you are a coder, just give code, and someone come in your prompt and come in some message and change what the AI can do, it can actually direct your app to do something completely different. It's something that happened to, I think, Canadian Airlines, where they had a chatbot that were supposed to help people book flights, and unfortunately it made some mistakes. People were able to use it for other reasons. So the prompting of your model also involves the security of your model. So you need to make sure that your model is actually secure based on the prompt and based on the instructions. You need to make sure that your model do not hallucinate a lot. We can mitigate it with retrieval augmented generation that we'll talk about later. But from the prompt, you can actually reduce the level of hallucination of the model as well. So I think we had a brief introduction to prompt engineering. In the next part of this module, we'll talk about tokens, temperature, pricing, and max token. And I will give you some brief real world example on how to improve your prompt in the OpenAI playground and how to play with the parameters. So thank you for watching and see you in the next one. Peace. Hello, welcome back to this year engineering crash course. Today we'll be starting the second course of the second module, where we're talking about tokens, temperature, pricing, and max token or max content length. So we'll be defining this word and kind of explaining what they are and how they matter when you consider LLMs. So let's get started. So in the past videos, we did an introduction. We did a simple introduction to prompt engineering. Now we're talking about tokens. And in the next video, we're talking about prompt engineering techniques. So basically, what is a token? A token is a unit of word, a kind of word length, not really word length, but a chunk of text that being used to train models. So we consider while training a model, not a set of words, but a set of tokens. So if we take a text like this, you may see that this is a token, this is a token, this is a token. So usually it's a word. But for specific things like maybe abbreviations or words that may have that you may need to truncate to be able to understand or to be able to extend them based on some specific configuration, you may have to have one word being two tokens actually. So let's just say token is the word in the world of AI. So it's a word in the context of AI. And each different model have a different way of having these tokens. It's actually based on the way you train the model. So if you have the tokenizer that you use define how the token that you pass to the model will be calculated. So you can have two models, but have two different calculations of the number of tokens that this model take. So let me just give you, I think maybe you know this already. This is the ChatGPT tokenizer. So you just have to type OpenAI tokenizer online and you'll see the first link is the tokenizer. Here you will be able to just type any text and get the number of tokens that the text have. So you can see, for example, here that I think it's deleted. So let me just paste this again. That we have here, okay? You can see that OpenAI is actually two tokens. Normally, you will say it's a word, but in this context, it's actually two tokens. But the rest of the words that we have here are basically just words. And you can see that this dot at the end is a token because it's important for the global context of the paragraph. And if you take the word text here with the point, it doesn't make sense, right? You need to have the point alone to be able to fully understand the structure of the sentence. So the tokenization of this text is actually breaking it into tokens. And these tokens are just units that you pass. I think it's defined somewhere here. Sequence of character found in a set of text. Yeah, so you can say it that way, but usually it matched to the amount of words with some kind of adjustment, maybe the punctuations and some words that are divided into multiple tokens. So it's a bit more than the number of words that you have in the text. I think DeepSeek, if I'm not wrong, DeepSeek API has a really good way of stating that somewhere. Let me see. I think it's called token and token usage. You will see that for them, one English character is 0.3 token in their training set. But if you consider here, one character or one word is actually like, you can say a token is like more than 3 characters actually. And you can see here that one English character is actually 0.3 token in your training set. Yes, and if you need to calculate the tokens for DeepSeek, you need to download a separate module and use it offline. So As you can see here, a token is just a way to represent the text into chunk that you will pass to the model. It is not exactly words, but it is a representation of the text in a word way for us. So when we have a sentence, we have a set of words. But when the AI sees the sentence, it sees a set of tokens. And these tokens are defined when you're training the model. So now, what is the max token of the context length? Usually when training the model, the architecture, the transform architecture require a specific fixed input length. So this will be like 128K for most of the model out there. And the issue is when you double it, you may triple or quadruple the price of the model, or just lose the quality of the output. So we need a maximum amount of tokens that you can pass to the model to keep the cost low and also ensure the quality of the output. So that's the reason why you have max token. And for many of these models, it's around 128,000 tokens. So basically more than a book. Not more than a book, like more than a small book, actually. But I think Google just had created a model last year that takes 2 million tokens as input. But the issue with that is also some small misunderstanding of sentence in the middle of the tokens. I think it's called loss in middle, if I'm not wrong. So having a really long context length is good, but it may cause some problems. And the context length is linked to the model training set, and also to cost optimizations and also performance related topics. So now, what is the temperature? So if we come to the playground here, you will see that our model is a probabilistic model. It's actually predicting the next token in a sentence with some kind of probability. And you can put some randomness to this probability, right? And this randomness is represented by the temperature parameter that we have here. So if you say something nice to the subscribers, I don't know, something like this. I don't know if it would say something interesting. It will say hello, wonderful, something kind of, creative. So if I ask the same thing again, no, let me just delete this because, okay. So if I ask this again, you will see the text is actually different. So every time we have some kind of randomness in the probabilistic creation of the next token, that makes sure that every time you ask for something, it gets something completely different. So if we reduce this to 0, the temperature to 0, and we ask the same thing here, it says this, right? Keep this in mind, keep shining bright. If we delete this and we ask it again, keep shining bright, you will see that we kind of have somewhere the same structure of sentence that we had before. We delete this and ask it again. You'll see that we get something pretty similar to what we got before, keep shining bright. So it's actually getting around the same sentence over and over again, the same sentences. And yeah, so that's the reason why temperature is important. But now choosing the temperature depends on the use case that you have. If you have a coding use case, you need a really, really low temperature because it's a strict programming language. You don't need a lot of changing in text. You need a strict code output. Same for mathematics and engineering. But if you need creative coding, the temperature needs to be at maximum, at 2 maybe, because you need the model to create new things that each time you ask for a new poem, right? I think DeepSeek has a really good way of placing that. I think you can see it in the API somewhere here, temperature parameter for coding 0, for data cleaning 1, for general conversation 1.3, for translation 1.3, for creative writing 1.5. So you can maybe use it as a set when setting up temperatures, but in general, yeah, you can set it up in the playground here. Same for max token. So I talk about max token as the limit that the model gives you, but you yourself in your app, you can actually define a max token. And this is one of the parameters of the model, right? So you can just say, okay, I want maximum this amount of token for the AI to say, okay, I will limit the response output to this amount of text. I will not go further than that. It can help you reduce costs for use cases where you don't want the model to start saying long text when it doesn't need to. So what about pricing? We talked about tokens. The model is usually priced on a token base. So it means if you have a long context, which means a lot of tokens, you will probably pay more. it depends on the model that you're using. For DeepSeek, you may have a really long input length, but the price is so low that you will not have the price, you will not see the price coming. But same if you go to the latest model of ChatGPT, you may have to pay a bit more. But now when you go to an open source model, you're not really paying for the input token, but the resource that is hosting your model. So now you are not counting the price based on token length, but now based on the infrastructure that's running your model. So that's a consideration you need to have, especially when it comes to hosting the model yourself. We will be talking about that later in the video. But in general, pricing calculation is based on token length when you use external API providers. Yeah. So I think that's all for this video. We went through the specific terms that you may need to understand while just playing around with LLMs or just trying to understand the concepts. So in the next video, we will talk about prompt engineering techniques that you may use while coding or while using AI app in general. And if you are new to the channel, don't forget to subscribe. If you have any questions, leave them in the comment below. Thank you for watching and see you in the next one. Peace. Hello and welcome to this here engineering crash course. Today we'll go through the third part of the second module about prompt engineering. And today we'll talk about prompting techniques. In the last few videos, we talk about AI and engineering in general, programming languages, and many more. And in this module, we talked about challenges of prompt engineering. We gave some and defined some terms like token, temperature, pricing, context length. And in this video, we'll go through different prompt engineering techniques. So let's get started. So in terms of prompt engineering or prompting techniques, we have a lot of different techniques. The first and simplest technique is actually just telling straight to the model what to do. It's basically generally associated with zero-shot prompting. It means you just say to the model, please do this. So we can go here, for example, and say, your useful assistant is actually just a zero-shot prompting technique. So you can just say, be cool. This is a prompt, right? And then you can add a user saying, hello. Based on that prompt, it will answer. The prompt is actually correct, right? Now, if you want the model to be more accurate, you need to be more specific in your zero-shot prompting, of course. And for that, you have different ways of organizing the prompt to make it more interesting. First, you need to play a role. So you need to do something like role. You are something. You are an AI, let's say YouTuber with 10 subscribers. And, you explain what you kind of extremely describe the role of the AI in this case. So the AI will take that in mind and try to act as this person. And then now you can say, give the context. The context is like, okay, you know this, you should know this, you should get this, these kind of things. You should be able to advise people on YouTube. And then now from this role and this context, the AI have like a persona. From this persona will represent what the AI will try and mimic in the response. You can actually set the tone as well. If you want to, like the tone, speak like Elon Musk if you want to, or speak like a professional person, speak like this kind of person, and then you can give the task, okay? I'm just giving these parts just for reference. You don't need to write them. You may want to, but you don't need to. And then the task will be help users with their YouTube channel. So when you give this to the model will try to be as close as possible to the persona that you created, and will try to act as much as possible to the person described in your prompt. So this will give a bit more correctness to your model, to your output, because it will try to act as the person that you created, like the YouTuber with a million subscribers. If you just say, help me with my YouTube video, you are more likely to get a generic response than help me with my YouTube video. You need to know this and you need to speak like an advisor with this kind of tone and this and this and this. You get more accurate response with this normal zero-shot prompting. So now with this, you are still out there describing a persona, but the model does not know how you want the output to be. It knows how you want him to act. But if you want to show to the model this is the kind of output I want to have, you need to go next level to the next level and actually implement future prompting. And future prompting is actually pretty simple. So what you do is you give to the model few examples of what you're expecting. So it can be if you want the model to be able to generate YouTube script, you will say input video about AI and output the, the format that you want exactly. Okay, you do the same maybe 2-3 times like this. Oh, okay. And then now you can put the input here, video about data science, and then you put output empty. The AI will try to guess from what you gave as input and as examples what the output may look like. Right? So from this kind of task, giving an input and output to the model, define a bit more the structure that you want, the format that you want, the way you want it to be, more than the persona, more than the description that you gave. So if you give some kind of JSON output here, the model is more likely to give you a structural output in JSON as well. That's the reason why future prompting is actually pretty powerful. You give to the model the exact format and exact tone and structure of the output that you need, and the model learn from it to be able to generate something that's pretty close to what you gave. Yes, but apart from that, we have different other techniques here. So before going to React prompting, I first want to explain chain of thought. And to explain chain of thought, I need to go and show you the deep thinking of DeepSeek, because it's actually used some kind of chain of thought. So let me just firstly quickly explain this to you. This looks like future prompting, right? You give a question, answer, question, and you expect a different answer. But now, in the example that you give to the model, as I mentioned, the example give the model the direction how it's supposed to give you an output. And in our case here, we describe in a kind of structural way, in a kind of chain, how the model should think before answering. So here you say, Roger started with 5 balls, 2 can and 3 tennis ball, each is 6 tennis ball, and then you do 5 plus 6 is equal to 11. And the model will understand your the structure you want him to answer with, and then will mimic it. And by mimicking that, it is more likely to come up with real and accurate answers. So that's the reason why chain of thought is actually quite interesting. So if you look at DeepSeek, if you go to DeepSeek and you try to search for something, let's say, how are you today? You will overthink this question surely. And you activate deep think as specially. So it will be, this is just a generation from the model. So the way you have this is you train the model by giving it the think part and the response part. The model learn how to think and respond at the same time. And this is kind of a chain of thought that we talked about. So this structure here is from the training set given to the model. So the model knows now that when I get a question, I need to have a thinking step before having the response step. And this thinking step is augmenting the accuracy of the model in some sense. So as you can see here, I don't know why he's overthinking the message, but in general, at the end he said, yeah, looks okay. How can I assist you and everything? Yeah. And then the last technique we'll be seeing in this video is actually React prompting. So here, for example, you have a simple prompt with thought, act, observation, thought, act, observations. And this will give the model, as in chain of thought, a process of solving problems, right? And when the model will get a new input, he will go through the same steps, follow the same process to solve the problem. here the process is an organized thought with one act, some kind of action that the model will do, observation from both of the thought and the act, same, and at the end you get an output from the model. So this makes the model also more accurate, same as the chain of thought. So you have much more prompting techniques, and I will put this link in the description. You can learn a bit more about all these prompting techniques there. A bit more about RAG. We'll come through it later. And yeah, so from there, I think just with few short prompting, with chain of thought, and with React prompting, you can actually write extremely good prompts. And what I explained during the zero shot prompting phase, you have, I think, the knowledge to actually create really great prompts. But what I have to say as well is you need to balance the length of the prompt with the price, right? It's like a threshold that you need to find, because writing really long prompts costs a lot of money because you're sending the prompt every time. We have prompt caching now, but in some cases you need to send the prompt every time. And if you have to send a prompt that costs $1 every time, your app will cost a lot to the users at the end. So you need to be specific in your description, but you need to take into account the price of having a really long input token as well. So if you have any question, you can put them in the comment section below. Yeah, thank you for watching. And in the next part, we'll be exploring now each of these providers' API. We'll go through OpenAI API, Anthropic, Google, DeepSeek, XAI, Drug, all of the providers' API, and go in depth in everything you need to know. So we'll take, for example, OpenAI API, go through all the functions that they provide in their SDK, and I will show you how to use them in real-world application. And then afterward, we'll go through all other providers, and then have a quick overview of LLM frameworks like LangChain, Haystack, and Llama Index, and then we'll create a project at the end in the next module. So if you're excited as me to reach that module, don't forget to subscribe, and yeah, see you in the next one. Peace. Hello everyone, welcome back to this crash course. Today we'll introduce the third module of our complete crash course, and we'll be talking about providers. This is where you actually learn how to use LLMs, APIs into your application, either via direct SDKs or with frameworks. So let me first give you an overview of what we did already. In the first module, we introduced AI in AI engineering. We went through what's the difference between API and SDK. We actually gave a global introduction of everything we'll be having in this course, as well as the tool that you will need to understand every concept that we'll be explaining. So in the second part, we talk about prompt engineering. We gave some prompt engineering techniques, what you need to learn prompt engineering, some few words that you may have or encounter while working with LLMs. And then we gave few prompt engineering techniques that you as a developer need to know to be able to instruct the model properly. In this part of the course, we'll talk about APIs themselves. So this is where we actually start coding and going through how to use the LLM to build products. In this module, we'll talk about OpenAI, Anthropic, Google, Drug, XAI, DeepSeek. Actually, all of these big providers will teach you how to use them in your own project, and we'll go through different other way of achieving the same result using frameworks like LangChain, Haystack, and Llama Index. We'll also have a brief introduction about Together, OpenRouter, and Replicate that we'll be coming back to in the open source module. And then at the end, we'll have a practical project. So let's start with the OpenAI overview. So as you can see here, we have an empty folder or an empty project open in VS Code. So what we need to do is create a folder for OpenAI where we'll be putting all the code related to OpenAI. And here we open a new terminal. We go to the OpenAI folder. The first thing that we need to do is to actually create a virtual environment. And this virtual environment will keep all the dependency of our project so we don't have to merge them with our global dependency. So let's create that by doing Python and vm called vm. Okay. So when that will be done, you'll see a folder called vm in there. And then we need to activate this VMF. We do source VMF bin activate. Okay, so you will see that we have a VMF in front of our terminal now. Every time when you see this, it means you're working in a virtual environment. So now we need to create a folder, a file here called requirement. This file will contain all our dependencies. So we'll first start by adding the OpenAI API dependency with the current version, the latest one. You need to specify the version because otherwise they can change the API and you will break your whole application. So we need to use this version for now. So if they change things in the future, you need to change the version here and adapt your code to the new version. Same for the python.env. So we save this and we just come here, we do a pip install requirements. Yes, I think it's called requirements.txt. Could not open no such file directory requirements. Is it in the right? Oh, okay, it's not in the right folder. Sorry. So we need to put it in OpenAI. Move. Okay. And then now, okay. And then now we install all the dependencies that we need to have in our projects. So now we need to create a file called .env and also a .git now. So this is just for local. You will have it online directly, so you don't need to create it. So we just git now, and here I'll put my env file and my VM folders, so I can push it later on. Okay, so here we'll create a file called main.py, and in this main.py will be actually coding everything we need to code related to OpenAI. Afterward, we'll actually structure a bit more what we're doing and provide a Streamlit UI for the end project or for the global project for OpenAI specifically. So here, after creating this, what we need to do is to import some dependencies. So we first import OpenAI dependency. Okay, same for the .env, we load the .env, and then we import OS. So what we do here is that we load all the environment variables. Okay, so to do that, we need a function called load.env. Okay, and then we create a client for our AI to connect to OpenAI. We just do OpenAI and we pass an API key. And to get this API key, we need to get it from the environments. And to do that, we do os.environment and we pass the name of our API key. So let's say we came to this env and we create a variable called API key. We'll be storing our API. So how do we get your API key from OpenAI? Quite simple. You go to OpenAI API, it will get you here. And then you go to, normally I'm logged in, so you will have to log in, of course. And you go to dashboard, you go to API keys, and you create a new API key. So you need to keep this secret because otherwise people will use your money to actually create their own AI. So just click crash course, create the secret key, come to the .env. Here and paste our API key and save the file. So now we can reference it here as, I think it's called OpenAI API key. Okay. So now we have a client. So what can we do with this? We can actually start calling specific functions and doing specific things. And the first thing we'll be doing, so I think I need to comment here, load API key from .env and then initialize client. Okay, so now what we need to do is to go through the API, OpenAI API, and I will be showing you different use cases that you have and how you can work with them. So the first thing that we have is just simple chat completion. Okay, it means you have a chat message, let's say chat box. So let me just draw that in Escalate Grow. You have a conversation, right? Conversation. Let me just delete. I need this and I need this in black without the round corner. Okay, like this. Okay. The thing that happens is that you have a chat between you and the AI. The AI will say something and you will say something, right? Like this. So you have a field of conversations. So what's happening is that when you will be talking to the AI do not have a context, at least the API, it does not have a context of everything that's before what you're asking now. So you need to keep it somewhere and send the global list of message to the AI. So the AI will have a context of the whole conversation to be able to answer. So if you say here that my name is Jack, and you say, nice to meet you, Jack, and then you ask, what's my name? The AI needs to know that you said before your name is Jack. And to do that, you need to keep the whole flow of your whole conversation. And how do we do that? We create an object called messages here of just misuse this with TypeScript. Okay, which is an empty array. So the first thing that you need to put here is something called role and this content. So this role is system. Okay. And in this system, you put your prompt. Okay. So let's say you're building an app that will, let's say, help you with mathematics. So you need to specify here that you are an helpful math teacher. You can solve, all the prompt engineering related things. If you need more context, I have a video on the channel. You can watch the video on how to create proper prompts. So we just quickly go through it here. I don't have to do this. And then this will be the first message that you give to your system. You don't need to print this because it is the instruction of your whole app. So to put this in perspective, this simple prompt here, what you wrote here, can create two different apps. So you can create a mailing AI that maybe help people write better mails, or a math tutor, or an English tutor, or a coding assistant, only based on the prompt. So this is where you define what your app will be doing. And this is that the part that will differentiate your app from other apps. So writing a better prompt here is crucial. You really, really need to understand how to write better prompts to have better applications at the end. Okay, so with that said, you need to be having this flow of conversation that I showed before. I mean, the AI and you have to differentiate that using this role here. You have the system role, you have the assistant role, which is the AI response, and you have the user role, which is your response from you as the person. So you can do this and have here user may say something like, I need help with 1 + 1. I don't know. Something like this. And then the response that you'll be getting is actually what the AI will be giving you as solution to that. So let's do that. Let's quickly do that. You come here, you do response is equal to client, the chat, the compilations. And this part here is quite important. It's these two segments here, because a lot of the SDK are just changes here in parameters. So if you know the suffix, I will say the suffix here, it looks like an API suffix, and the parameter that each of these function takes, you can build anything on top of OpenAI. So let's just do that, create. And here we need to pass some parameters. The first is the model. As model, we can choose GPT-4o. Okay, you can choose 4o minim or whatever model you want, GPT 3.5. You're free here to choose a model that suits your needs. And then we have now messages, and messages are actually the flow of messages that you're passing to the AI. You can just put it to be messages. Okay. So with that said, this will actually, you have some other parameters like streaming, if you want the response to be coming one by one, or you want to have everything one time. But other than that, we can directly get the response here, and we need to console log. We need to print response. Okay, so if you come in your terminal here, you clear everything and you do Python main.py. Oh, I need a comma here, of course. You'll see that it's taking some time to go through the API asking to OpenAI, and you will get a response here. This response is a specific object, and if you check here, you have choices. Oh, wait a minute. Yeah, you can see here that we have message as a property of choices, which is the first element of the array. So if we do response dot choices of 0, dot message, you will get the whole response from the AI. I think it's kind of formatted right now. So let's play this again and open this like this. You see that you get this task completion message with content. So you can just do that content to get the content directly if you want to. And you are getting, certainly the equation is something like this. So this is the first use case. Let's say we completely switch use cases. We want an AI that gives you advice on mental health. Let's suppose we can build something like that. You are an empathetic, how do we call it? Empathetic. I think it's just, that's not the right way of writing this. Empathetic. See, and you help people with, I think they will block this, but let's see, mental health. I need more, I don't know, more joy. So let's try it out. You will see that we have a different app just based on this one. So let's try it out. Okay. So you can see here, I'm really glad to reach you, wanting more joy in your life. This is a different use case. So we went from a math tutor to an empathetic C only based on the prompt. That's the power of LLMs. So, and the power of prompting. So now you see the importance of having a good prompt into your application. So now that we have this base and we know that, okay, we can do many things just based on the prompt, we can also, I think when you use ChatGPT, you have, the text coming one by one. To do that, you need this parameter called stream is equal to true, and the response is quite different in that case. So you don't get response this way. You get response as chunks, and you need to loop over the chunk. So how you do that? You do here, you call this response, okay? For chunk in response. You can actually stream this directly to the front end so they can, show it progressively. This will make your app faster. From response. Now you need to say if the chunk that I have right now, the choices of 0, the delta, that content is not none, so it exists, you add it to a kind of text. So this is not useful. Normally you need to stream it somewhere, but I'm just trying to show you how to do that. So you do, let's say, full message. Okay, and then you just do full message. Yep, that's the right way. Plus equal to what we just said here, chunk delta. So we add each chunk into the full message. Yes, and then that's all. We just print full message here. Okay, so let's try it out again. Okay, you see that you get a response here directly from the streaming the response from the AI. Quite interesting. So now I need to show you how to do much more complex things. So we went through a simple text generation or simple text completion. And by the way, when you get this response in a normal chat, you need to add them to this array. So normally you do something like messages that happened, full message, but in these formats like this, role, assistant, and then content, full message. So you keep track of everything that's going through the conversation. Yeah, with that said, we have everything containing base completion. Now we can go to the next part, which is structure output. So now let's say you want to build something pretty strict in terms of output. It means maybe some app that will extract key information from a document, or some app that will extract key information from a simple text. So let's say you give a text and you want the AI to be giving you the introduction, the body, the conclusion. But in this case, if you get a text like this, you cannot really, go through it and parse it. So you need a structured output to get it. It's the same as using it to predict something, okay, or using it for stock exchange. So if let's say you want to use this for trading, if you want to use this for trading, you need to give maybe some stocks and get back some predictions. And these predictions need to be not text if you need to act on it. So you need a structural way of getting this result. And structural output is a way to do that. But for that, you need another module called Pydantic. So that's the reason why we go in our requirement and we put the Pydantic file and then clear this and we do a pip install requirements. It will install everything, including Pydantic, if it is not already installed. So you can see here, already installed here. Okay. And then in your code here, you need to specify the format of your output. And to do that, you need to create a class, some kind of class. So you come here, you import from Pydantic, import base model. Okay, this base model, you will create a class that inherits this base model called class, let's say, stock prediction. And you pass the base model, okay? And here we're just giving the keys that you need. Let's say you need a stock name or code, I don't know, which is a string. Then you need action, which is also a string. Let's say you do something like this, okay? And you say you are an experienced trader. Give me trading advice on stock to buy and actions to take on these stocks. Okay. Okay, let's give this to the user input here. Okay. And then you need to pass a new thing here. I think it's still in beta if I'm not wrong. So you need to do beta chat completion. And here, instead of create, you need a parse. Okay. And with the model, you actually need the 4.0 or one of the latest version of 4.0. So if you use one of the earlier version, you will not be able to get this this functionality. So like just trimming, yeah. And then we put some parameter here called response format, which will be our stock prediction. Okay, so let's see. We run the same as usual, Python main.py, and we are getting some error saying stock prediction base model big B as imported. And now client.beta pass got unexpected. Okay, we cannot stream this, so let's just comment this. But in this case, we need to we cannot do this, so we directly need to get I think here response the choice of 0.message, and you will see the format. Let's see the format first. Taking some time. Okay, you'll see that we have a structure thing here. It will say Tesla, consider buying any dip around this potential, market. You can give it a bit more instruction like code to say buy and value to say this amount, and it will be more strict about what it will be giving you as output. So now you can parse this and say, okay, the stock name is Tesla and the action is buying it, right? So this structure output may help you call the LLM as an API to do some specific things. It can be parsing text, it can be extracting key information from data. It can be much more complex things. You can actually do this, use this to do really, really complex app and use the LLM as an API. Okay. So with that said, we need to go to the next part. After the structure output, we need to talk about the vision model. the vision model of OpenAI. This will help you pass images to your model, and these images can range from just simple text on text-based image, or with complex images with complex things on it, and the AI will use this as context to your conversation. Okay, so let's say you want a simple AI that will explain memes to you. Okay, to do that, you need to use a vision model. You pass the image of the meme, and the AI will be able to predict or give you an explanation of what it means. Okay, so let's try to create that. To do that, we have simple changes to do here. So let's hear the prompt again, pretty important. You are the meme lord. Okay, you can explain and understand every meme in the world. Usually pass it. We can also add that, I don't know, you pass your whole day on Reddit. Yeah, so we can just say, explain this meme to me. Okay, explain this meme to me. Okay, but here, instead of stopping here in the content, I think we need to change this way, like this. And we pass first a type, not like this type, and this type would be text. So we need to specify when we are passing text or image. So we pass text. It would be the man. Okay, the man will be text. What we ask for is explain this meme. Okay, and then we need another key called image URL. You can also pass base64 image if you have local images. So let's just say image URL. I'll just look online for some random meme. Okay, I don't know, let's just say something like this. We copy the URL, copy image address. We come back to VS Code and we paste it here, like this. Okay. But in that case, we need to put this image URL instead of text. Okay, and then we call our function. We remove this. We can just directly get the choices, and okay, getting some errors saying beta chat compilation pause. Okay, let me check that. Okay, that's right. So here, instead of this, we need URL like this, and then we have our image. Okay, so we try it out again. Okay, this meme construct how design and programmers stereotype React. Similar stole my idea. You saw the meme. So yeah, you can do something like that. So you can pass images and have specific use case where the AI will be going through the image and maybe doing some specific things, like maybe extracting information. It can be extracting text. So you can do that as well. So you pass an image of maybe a PDF or something and ask the AI to extract the text in there, and yeah, many more. So this is simple of a vision model from OpenAI. So now let's go to the next part, or maybe I'll just show you quickly how to do the same that we did here with local images. And for that, we need to encode this image in base64. So let's say you have an image here. I don't know. We'll not really have it. You have to use real image. So let's say you have an image in base64. You need a function to decode this image. You can get this simple function here from the official documentation. So what it does is you need to import base64, of course. Okay, so what it does is it opens an image that you pass by the image path, and then it read the image and encode it in base64. Okay, so what you give here, so it's like so here type image URL, and the URL will actually be something like this. So let's first get the base 64 im is equal to encode image, and we pass the path here. Okay, image, and then here instead of these, you pass the, it needs to start with base 64, and so you can just format it like this. And then here you pass the decoded the base 64 image. So now it will read this image locally. Let's say it's a PNG. And then pass it to the model to do specific things on it. So you can do the same via by getting the image directly from a request. So maybe someone upload an image on the platform. You pass it in base 64, you encode it in base 64, and you pass it to the model. Okay. So I think that's all for the vision part of this overview. So let's go to the function calling. So what is function calling? Let's say you want to build a system like Siri with this. For the moment, all we can do is just give text and get back text, right? So how do you do to fetch the weather? How do you do to play a song on Spotify? How do you do all of these things that, you know, Google Assistant and other can do? Create tasks, search for things online. The only way to do that is for the model to tell you explicitly, this user asked for this thing. Please, can you perform it on your own so you can implement the logic for these specific things in your applications? So this is the role. This is why we have function calling, and function calling is quite simple. What you need to do is just define some tools. Tools can be get the weather, send a mail, whatever. And to do that, you come here and you create maybe an object called tools. Okay, let's get the official documentation object. Okay, so let me explain this to you. The type is a function, and the function is called send email. Normally in the tool call, you will get this send email to know exactly what the AI asks you to do. And it will be send an email. You give the description so the AI knows, okay, when this happened, I need to call this function. It's send an email to the given recipient and subject and message, okay? And then the parameters is actually what the model will extract from the text and give it to you so you can pass it to your function. So we need the to, the subject, and the body, okay? So with that said, let's change our prompt again, one more time. You're an experienced assistant, you're a helpful assistant, okay? Assistant. And here we'll go back to our normal structure. We don't need this anymore. We just do write an email to Angela at ulife.ai and ask for a voice agent app. Okay. At ulife.ai and ask for a voice agent app. Okay. So now we need something else. We need to pass another parameter to our whole model to say, we actually need you to consider these tools. And the pretty simple things to do here is to pass the tool parameters. It's all tools, and you pass it is equal to tools. Okay. So now you have the choices, and then from the choices, you will see if the function is getting called or not. And this in the message. So if we run this again, oh yes, I think we need to do this and then this as well to avoid issues. Okay, now it takes some time, of course. In the meantime, you will see here that we have past chat completions, and you have a new field called function call, okay, and tool call. Now the tool call will say the to, this is the mail that you need to send to. The object is inquiry about voice AI agent app, and the body is hello, I hope this message finds you well, and everything. So this, you can actually parse this, like parsing it. It's just simple as saying, okay, if this dot tool call. I think it's called tool calls, right? Tool calls, yes, of 0. Dot, what's the name? Function? Yeah, I think it's dot function dot name, if I'm not wrong. No, dot name is equal to something. So let's just print this first so we can see if the function name is getting here. Taking some time. It's saying no attribute name. Okay, so we have, where is it again? To subject body, and it ends here from the pass argument. So the name directly comes from tool call here, and it's pass function, and we have function. Okay, that function. Okay, great. You'll see that send email, which is the name of your function here, is sent back by the AI. So you can just create a function called send email. So let's just say def send email. Okay, it takes some params, I don't know, just for clarity, just for, and it does something like print, hey. Okay. And what we have here is, we have this. So what we need to check is if this exists, okay? So if we get the send email at the end as feedback, so we do that function as well, and we check if we get send email. Now what we can do is call our send email function. There's some indentation here. With the parameters, and the parameters here are pretty simple. I think it's called pass argument. So same function.pass arguments. Parsed argument. Okay. So now we try it again. Yes, of course. You wait a minute. Normally this will simulate sending a function, and you'll see it said hey, right? And this hey, where does it come from? From our function, okay? So we can just be sending an email here, and now you can create complex systems where this AI interact with different other tools. Okay, with that said, let's go to our next part, or the next module, which is actually text-to-speech. The text-to-speech model is actually just made for you to be able to speak. So let's say you're creating a complete assistant, right? So here you need to have a voice reading out of what the AI is giving you back, and you need for that a text-to-speech model. They have a great model. I actually think Eleven Lab is better in that sense, but their model is good enough. You will get the voice that you get in ChatGPT. You have all these voices on the website. Let me show it to you. Okay, so let's go back. Done. And we come to platform again. We go to the text-to-speech. You'll see that you have a range of voices here. Hello, hash, coral, you can play and see how they sound. And as I mentioned, the fragment changing is actually this from audio.speech, and you need to know the parameter that you pass to the model. In our case here, the model name, of course, same as before, but now we have two new parameters, which is voice and the text that you're passing. So now you don't pass the text as before, you pass it directly as an input, and you will get back a response, which is an audio in streaming, so you can directly read it when it's coming, or you can save it in a file as the wrote here. So depend on you. So you can use this to actually read things out loud, make your system interactive so you can speak with users easily. Okay. And yeah, the next module here is a speech to text. So this is quite interesting as well, because it can allow you to talk and get the transcription or the translation. Both are great, okay? For the transcription, so first of all, this model is actually open source, so you can just type Whisper, I think it's called Whisper, okay, Whisper GitHub. You come here, you can actually just install it this way. I think this is Whisper 1, if I'm not wrong. Yes, you can just actually install it this way, OpenAI Whisper, and use it like this, you know, without having to pay OpenAI, of course. It's pretty lightweight. You can use it directly into your computer without having to buy a big GPU or something. And when you get it, or if you want to use it with your API, of course, you can do it that way. It's still quite simple. You get the audio, you pass, you know, this trunk again. It's now audio point transcription. You pass the model and the file name. But one interesting use case that they introduced is the possibility for you to give the input text in different languages and get the transcription in English, which is quite important because most of the time your model can perform extremely well in English, but extremely bad in other languages, okay? So you may want to get the output in English so you can feed it to the model and yeah, get better accuracy. So for that, you need the translation module. So here, same thing, exactly. So you just need to change the transcription by translation. And then you give the files, and then now you get the text always in English. If you speak in German, you get it in English. If you speak in other languages, you get it directly in English, okay? So with that said, let's just quickly go through many other API that they provide. The embedding API, we'll go through it later. And I will explain a bit more what embeddings are because this is quite important for retrieval augmented generation. But in general, they have different models here, the small and large. I think they have some legacy as well, legacy models. This just transform your text into vectors like this, so you can do some mathematics operations on it. Yeah, so same, pretty simple, clear and embedding create. As I mentioned, you just need to keep this in mind. This chunk is actually where the use case changes and the input as well. Okay, the text and the model, quite simple. Now, the moderation is something quite interesting as well. So if you create an app where you need to make sure that users not upload some kind of content or hateful speech or whatever, you need to use this here. You can directly do it with the API, like just writing a prompt, do it. But if you want a more moderated, a more specific model to do it from OpenAI, you can use these omni moderation layers, and then you pass the text. It will classify it into Google will. Anyway, you know, all these words that you see on the screen, hate, illicit, and whatever. Now we have some reasoning models as well. So this is a bit more expensive. It's still in beta. If I'm not wrong, the reasoning model are in beta. You can access them, of course, but you need to be in some tier to access this actually O3 mini or other O2 or O1 or O3 mini and others. So yeah, but the thing you need to consider here is that the latency is much. It will be slow, but the output quality will be far more better than a normal chat completion model. Okay, and as you see here, it's actually the same thing. The only thing changing is that you pass the OP3 model and you pass a reasoning effort. Okay. Oh, and by the way, this store just means you want to start it online, and which is quite interesting or important for model distillation and all that we'll see later. Okay. So with that said, we can also go through your image generation API. Where is it? Image generation here. So you can use OpenAI to actually generate images. Pretty simple, you know, image generate. You pass the prompt of what you want and you get an image back. But now we'll go through all of the image generation APIs a bit later. So we'll not be talking about it here. Same for audio generation. So you can actually pass some text and get some audio back. So the model, instead of answering directly with text, it answers directly with audio. Okay, so you can do it here as well. Same. All you need to change is actually give some different modalities here. It's actually the same, and you pass the modality to text and audio. Okay, so with that said, we have some interesting things here. So the predicted output, important when you want to keep your cost low, while doing some things like, you know, code generation or things like that, because you need to feed the text to the model and only just get the completion, which reduces the cost. You can read it more here in this part of the documentation. Now you have the fine-tuning API as well. Quite simple. You create this file with a strict structure like this: role system content this, and then you get the user assistant content this, which will act as a way to steer the tone or the way of behaving of your model. So if you have enough data like this, you can actually make the model be more specific to your use case, or more interesting, or more accurate to when solving problem in your use case. Now the distillation, by the way, just some quick info like this. OpenAI said DeepSeek used distillation in their process. That's the reason why their smaller model is better than O1, maybe. But the distillation means you use the data that a big model generated to train a smaller model, and that will make the smaller model much more performant. At least it can match the performance of the big model in the specific use case that you choose to fine tune your small model on. So that's the reason why in DeepSeek you have three models. You have the DeepSeek model, the L1, you have the V3 before, and now you have the distilled small models, which kind of have the same accuracy as some of the big models, because it uses the output from the big model. Okay, and to do this in OpenAI, you can directly do it here. You store the data in some specific with some specific data, metadata in the dashboard, and then you use it to fine tune the model afterward, and use the evaluation metric to evaluate it. So let's talk about evaluations now. Yes, so writing a prompt is interesting, but being able to make sure that your prompt will work in production is really hard. So that's the reason why you have evaluations. Evaluations are like testing in software, where you have to write a test to make sure your software will work properly. For evaluation, you need to have some prompt and some expected output and pass it to the model, and the model will actually compare the real output and the expected output to make sure that it match your expectations. So you have some kind of way to evaluate your prompts, and this API can help you do that. It's still better, of course, but you just go through the API, you click through it, you upload some files, you know, it's you can get it. I just want to mention it, but you can also do it with libraries, with Python libraries. Free to you. You can directly use it do it with the API, with the SDK as well. Free to you. You are free to choose which one suits best your use case. But yeah, you have an evaluation API. You have a batch API as well, when you want to pass multiple things to do at the model at the same time, and this will reduce your costs also. And then you have an explanation about the prompt generation process. Normally in your playground, if you go to playground here, you'll see that here you have some improve the prompt. So they're explaining how they're doing it here with the meta prompt here, saying, okay, this is a meta prompt, and then you will get an enhanced prompt at the end, for example. Okay, so you can go through it as well. Everything is in the documentation, but so far what we did were pretty simple, going through everything that OpenAI provide as API. So now let's get into creating our simple chatbot, which will generate UI using, it will generate startup ideas for us. We'll have a UI, we'll be able to chat with the model. It will help us generate ideas and brainstorm. Okay, so let's get started. So now that we have this here, okay, we have all these complex things, function calling and everything. What we need is, let's first just comment a lot, because I will have to push it online so you can have access to it. So just comment it, because we don't need all of these. Okay, same for this. You just need this. Okay, now we just let's just first do a simple chat, and this chat will be called by a Streamlit UI. And to do that, we need to first, as usual, add the Streamlit requirement file here, requirement part here, and do a install requirement.txt again. Okay. Oh, I need /r here. Okay, so now that this is done, we'll create a simple UI using Streamlit. So let's create a file here called chat.py. And Streamlit is actually just a simple library that will help you create simple testing UI with Python. So what we can do here is just first importing Streamlit, and we need to create a function here. Our function will be def call or just AI, and we pass the messages because we're getting the message directly from Streamlit because we need to display it. And we do what we did here. Quite simple, okay? And then we can give it back, okay? You can just return response or some specific things of response. So now let's design our UI. First, let's import our AI from main, import AI, okay? Now let's set a title to our page, okay, like this. Yes, we need to have a state where we'll be keeping all the messages. So we can do this like this. Yes. Then we need to display the messages. Okay, we can do it like this. We look over all the messages and we display them. Okay. Now we need a prompt where the user will enter the text, and this text will actually call a function. So we do our function, our AI function. We do this first. We type the message will be the input that we have at the bottom of the string, and then here we'll save this into our state, same that we did here in the main. You remember, we just pushed. Okay, I deleted the line. Sorry. So normally we were pushing things in this array. So we are doing the same here, pushing things here with the user content, and then we are displaying the user message like this. No, this is too much. Okay, and then now we're expecting the assistant message. Okay, so what we'll be doing is that we'll just create an empty placeholder message, and we need the AI response to be streamed. So we will be having, as usual, full response here as an empty string. I think we did that already, so shouldn't be surprising. Now we do a try and catch, okay? Because it can happen that the model just trash, so we just do try. And then we do except. Okay, and then we paste some, we show some error on the screen. Okay, so now here in this case, in this part here, we need to call our AI, and our AI will be response now is equal to AI, right? And AI gets what? Of course, the array of messages. So we can get it from Streamlit like this. Okay, and we need to display what we got, and we do the same loop that we did before, and we added, we did it already, so we don't need to go through it again. Same, and we add it to the we display the full message at the end, and normally this should be okay, right? We get the response, and we get a chunk in the response, and so now we do here, we do a pip install. We did that already, so we just do a Streamlit run chat .py. Okay. Yes, so I think this is in the wrong folder again. Yes, so we do this. You will see that it will open a browser. So let me show you the browser. Okay. So the browser is saying, hey, how can I help you today? So we'll say, what can you do? Tuple object has no attribute choice. Okay, so let's go in the code again to debug this. It's saying here that, where is it again? What are we returning? Are we returning the response? Yes, response, we return response as complete. Oh, okay. Yeah, sure. So instead of these, we have something else, which is it's another function. It's chat completion dot create. Okay. So then we launch our server again. Same. What can you do? Same again. Okay, let me check the code again to see what's happening. So maybe we can write some logs. Okay. Returning response should be fine here. Client chat completions. Let's create. We pass the model for. Oh, we pass the messages. Oh, yes, of course. Makes sense. We need to first activate the stream. Okay. So now when we get this, let's first print response to make sure we get the right response. We get the messages. What's in these messages? Oh, we need to do this like this. Okay. Yes, should be fine. We get your file system. And in this, we don't need this because we are pushing the message directly. So we don't even need these messages here. We are getting it directly from this here. So if we need this, what we need to do is actually get this world here as an array. Put it here in the, where is it again? In our message. Where is it? So here we have something like this. We just do this and we do this. Okay, and we just paste this like this. Okay, so with that said, let's try it again. I think I can watch this if I'm not wrong. I just need to do streamlit one. Okay, so let's run this again. Normally we have a, okay, so let me we have this. So if I say hi, I'll go back to the, we have a stream from OpenAI. Oh, great. How can I assist you today? So what can you do? And you will see that it's writing it directly. This is the streaming part of the thing. So if we remove this, we need to directly get the whole text and show it to the user, and the app is a bit slower. Yeah, so with that said, I think we just have some mismatch here from where we put the user message and where we put the response. Yeah, but in general, that seems good. We have everything. We just needed to update our state. So let's quickly do that. Okay. Like, okay, how can I help you today? I want to start a project. You'll see that great. Passion, expertise, exciting and rewarding venture. Okay. Help monitoring apps, it's giving you some ideas here. Personalized learning platform, AI-driven things. So what else can you do? Idea validation, business model development, market research, this is actually based on the prompt. So, and you can quickly deploy it and show it to people just as a demo. This is not a production ready app, of course. But in general, I think we went through everything. You can actually integrate tool calling, integrate voice, integrate text to speech and other things, but you have it from the API. You can play around with the version that we have right now, add more complex things on top of it. If you need more about Streamlit, you can go to Streamlit official website. You have you would get much more information from the app and how to use everything. Okay, you just go to the docs, and you have everything you need here. Okay, how to install it, how to use it, and many more. So if you need some other kind of fields, if you need to build complex app, you actually can do this with Streamlit. So yeah, I think we had a really long video, or long overview of an OpenAI API. Yeah, in the next part of this tutorial, we'll go through the same process. We'll do the same process for Anthropic, so you understand deeply the Anthropic API. you understand how to use the Anthropic API to build complex app. And then we'll do the same for Google, DeepSeek, XAI, and Rock. So if you don't want to miss that, don't forget to subscribe. If you like the video, please just drop a like. And if you have any question, drop a comment. Thank you for watching and see you in the next one. Peace. Hello everyone, welcome back to my channel. Today we'll start the second video of the third module of our AI engineering crash course. We'll be talking about Anthropic API. So we first gave a global introduction of the course in this first module. The second module were about prompt engineering. And then the first video of the third module were about OpenAI API, where we went through every aspect of OpenAI API. Now we'll do the same for Anthropic. We went through everything you need to know to start building with Anthropic. And next time, we'll do it for Google, Rock, XAI, and DeepSeek. So let's get started. So the first thing we need to do is to create an Anthropic folder here. We had OpenAI. I think I didn't write it at the right place, so let's do it here. Anthropic. Okay. So in there we need three files. First, the requirements. Requirements.txt. We need the .env, of course, for our env variable, same as OpenAI, and we need the main.py. Okay, so first let's just get in there and create some environment. We get into Anthropic. We do Python. We did this already before, so you just -m vm, and we call it vm, and then we source it, source vm /bin /activate. Okay, so now that we have this, we can put all our requirements here. So let me just add the list of dependencies that we have. We need the .env and we need the Anthropic API. This is the latest version of Anthropic. So to change the version, you need to make sure that the API match what we did in the video before changing this version here. So now we can just do a pip install requirements. So while this is installing, we need a key and we will call it Anthropic API key. I will show you how to get it in a second. And the simplest way to get it is to come to the Anthropic dashboard. You just go here to the Anthropic API. You can get it by typing Cloud API online. You click on Start Building and you will get here. And then here you click on Get a new API key, Create, you give it a name, and then you have an API key. You copy the API key, you paste it here. You paste it Yes, you paste it in your .env. So now we can start building. Okay, so pretty simple. We need something exactly like this because Anthropic API is really close to OpenAI API. So what we need to change is just here, Anthropic, and same, pretty much the same, Anthropic with the big A. We put it here. We don't need these two modules for the moment. And then here, as you saw it on the file, it's called Anthropic under .env. Okay. With this here, now we can start working on a client. Okay, but before that, we need I need to explain some few things to you. So let's just first start with chat completion. And for chat completion, we need something pretty similar to what we did with ChatGPT. So let me just comment it. You can see we need an array of messages with a system prompt. I will show you how to put the system prompt in Claude. With a model, with messages, it's pretty close. I think they got the inspiration from OpenAI because they are the first doing it. So you will see that the API are actually quite close. So let me give you a quick example here. We have messages from there. So I will show you where to put this. So this is how you do it in OpenAI. So I will just show you the difference. So here we call response is equal to client dot messages dot create, and then here we need some few parameters. The first parameter is the model. So we just put this. Then we need max token. Max token is the maximum amount of token that you get back from the model. And then we need messages. Okay. So this is different in Claude. This is how we do it in OpenAI, but with Claude, this instead of being here, it's actually down there, like this. System is equal to this, and you remove this part here. Okay, I think you need just a comma here. And then, as we already installed our packages, all we need to do is run this file. Let's print the response. And then we do Python man.py. Take some time. So we have some issues saying that not found model Claude 3.5 Sonnet. Okay, so we need a specific version of this model then. So let me just get it. Okay. So run it again. As you can see here, we get a response in some weird language, but yeah. So we get a response here. And same as with ChatGPT, we have only here the possibility, only this system prompt gives us the possibility to actually change the whole logic of our AI application. So let's say we want a, I don't know, a meme generator or some kind of joke generator. So we'll change it here. You are a joke generator, and you can generate funny jokes. Okay, I think it's funny here. And here you can just say, hey, tell me a joke about Europe. It will surely be a bad joke, but let's try it out. So here you can see that from this table here we have content, which is an array, so we can do that content, and then we have message somewhere here, right? Text, sorry. So we just do that content of 0 dot text. So save this, we run this again. Yep. Why are Europeans such amazing storytellers? Because they have got so many tales from the dark age. What do you call a French person holding a piece of cheese? A brilliant European. Okay. Don't know if that's funny, but at least you get it. You can change the system prompt here and get a completely different app, same as with ChatGPT. So now let me give you a new thing, which is system prompt caching, or just prompt caching in general. So here, let's say you have a really long app and the prompt is like burning $0.5 every single time. You have one way with Anthropic to actually avoid that. And that way is called function prompt caching, sorry. And the way you do it is quite simple. You just change the system prompt. Instead of having it as a string, you have it as an array of objects. So let me just give you an example. So put an object here called type text. So same here, like this. Okay, then you have the text itself, which is your system prompt, like joke, tell jokes. And then you have a third parameter. This third parameter is actually where you control the cache and the prompting. So you have this cache control, where you type, I think the only type existing right now is ephemeral, where you actually mention to the AI that it should keep this in the cache for a certain amount of time. I think it's 5 minutes for a moment. And then it will help you reduce your cost. And based on the finding from Anthropic, it can reduce your cost from $3 to $0.3, around nearly 90%. So it can be quite interesting if you have really long system prompt. Okay, so with that said, we can go back to our original one because I want to show you how to do the calls with PDFs. Okay, so we get this. From here, what we need to do is to create a file as usual. And this file will be passing it and changing it into base64. And to do that, we can have here an example straight from Anthropic with the URL of the PDF here. Okay, one of the Anthropic PDFs. And then you have the transformation into base64, but we need to first import the necessary packages here, and we are using HTTPX as well, so we import it as well here. Okay, so what's happening here is that we have this URL, we pass it in base64, we did the same with vision model from OpenAI, and then now we can pass it to the model. So what it does is that it just transforms this file into a string that you can pass through the network. Okay, so here in the messages, what you can do is to just add a field with the role user, with the type document. Where is it? Here. Okay, and then here you will have content document, type document, and then type base64, the type and the data, which is actually the base64 encoded version of the PDF. And this is quite interesting. This is for citation. So if we remove this, we will not get any citation. You will see that later. And then here is the next part where you get a question, you ask a question about your document. Okay, so we can even comment this because I need it at the moment. It's not mandatory to have the system prompt here. So if we run this again, you'll see that it's taking some time. And this time it's actually figuring out how to extract key information from the document and send it back to you. And you will see the response still coming. Okay, so you can see here that the document emphasizes Anthropic commitment to responsible AI. It's actually a model card, so it's actually about Claude 3, and the document had all the information about in a Claude. So now if we add this again, okay, you will see that this will change. You will get the same response, but you have in the metadata the citations. Instead of only text, you can see also citations. So but for that we need to change our code a bit to do something like this. We just print the response so you see the whole data structure. So we'll just get the response for the moment, but yeah, after the response I will run it again so you can see it with the metadata and the citations and see how it works. So let me this is actually interesting. Why? Because this is first part of the text, and it will be giving you chunk by chunk with the citations if it finds it. So this will surely have no citation, maybe, and then try it out again. You'll see from the response. So each chunk will tell you if there's a citation to it and give you the information about the citation, so you can add it directly right after your text. So maybe this part you will not have to put a citation incurred for it, but the other part that the model will give you, you'll just put a citation incurred for it directly coming from the model. With the text also, you can highlight it in your document if you want to. So okay, while waiting, let's see what we'll be doing next. The next topic we'll be talking about is actually, okay, maybe in the meantime, yes, we get the response here. Here, so you can see that we have much more here than what we got at the beginning, right? This was pretty simple, one single element, but with citation none, you can see it from here already. But if you come here, you'll see that some sections have no citation, which has no citation. Some sections have no citation, which is pretty normal. But now, if you go a bit down, you will see somewhere, just search for it, citation, none. But here we have a citation, and the cited text is right here. So you can take it and highlight it in the PDF, search and highlight in the PDF with the text alongside it. Okay, same when you don't get a citation, you get none, and when you get a citation, you get this. Okay, so yeah, so that's good about citations and text compilations and changing use cases. And as I mentioned, use cases all only here in the system prompt. So now I wanted to introduce some things to you, some things from Anthropic, especially concerning the prompting techniques that they have. So if you go to your documentation, so let me just go to the documentation and show it to you. I think here, developer docs, you will see that you can search here for prompt, and you will see different things here. The prompt generator. This prompt generator is actually Google Colab. You can see it somewhere here that you can run with a meta prompt as well, exactly as on ChatGPT. We did that already with the meta prompt. and the meta prompt will be generating prompt. But here it's actually based on the task. It's not improving the prompt, it's generating it. So you have something here with the task instruction here. I will tell you why you're using XML. It's actually mentioned in there. And you will replace this task with the task that you have. So that you will mention. And you will see down there, this is a really long meta prompt that we are replacing. What is it? We have a task here, we have an email responding to something. And then somewhere here, we're replacing the task, right? In the meta prompt. And then, yeah, we're getting a better prompt out of this. So this is, you can use this to generate better prompts for Anthropic especially. And you can see somewhere here that they are talking about using XML tags. So according to them, it helped the model give increase its accuracy when you use XML tags. So instead of just maybe doing like roll 2 dots and then you start writing, you can just wrap it into some XML like this, like instruction, example, formatting. Same for the chain of thought. We'll come to it later. And it will help the model actually give you better understand the structure of your prompt. Same for the response. You can ask the model to generate some part of the code in some XML. It can be maybe, text compilation, like in bold.new, for example, you have two different sections. You have the code section and the explanation section, and you can parse that and display it in 2 different windows, or actually write the code in a file and display the text in the chat box, right? So this is quite interesting. And yeah, apart from that, we also have the chain of thought here. And the chain of thought, as you mentioned somewhere here, you need to use some XML with thinking here. Okay, use XML like thinking and answer. I think we talk about chain of thought. If you didn't watch it, I'll put the link to the playlist in the description, and you will see it in the prompting guide. Yes, so basically you can implement it here. Same for the prompt improver. It's just a way to improve your prompts if you already have a prompt. And then we have some simple security things here based on your prompts, like avoiding being prompt injections and avoiding leaking your prompts. I think it should be somewhere here. Oh, and they have some example of multi-shot prompting as well. So the prompting guide from Anthropic is actually quite complete, I would say. So in the meantime, let me just look for it somewhere here. Should be. Let me search for it. Jailbreaking. Okay, here we go. You can mitigate jailbreaks and prompting injection. So this is some security content, and we'll talk about it in depth in the upcoming sections of the course. But in general, you can read this to have a bit more of a view and how to reduce your prompt being leaked. But here they are saying you need to do it when it's really, really necessary, right? Because what you're implementing here can increase the complexity of your prompts, or what you're doing. But in any case, the results are actually quite good here. Same for reducing hallucinations. You can just say to the model things like, I don't know. But in any case, you have the resources here. You have the prompting module to understand a bit more about prompting techniques. And then from that, we need to move to the next module of this course, the next part of this tutorial. Let me go back to my code. And this next part is actually function calling. So we saw with ChatGPT or OpenAI, we saw with the OpenAI API that if you need to do a complete system that call external resources, you need function calling, because what the model is giving to you is actually only compilations. If you ask for something, you get the text back. But if you want to know, how do I get the weather? How do I play a song on Spotify? How do I do specific things? You need function calling. And function calling is actually part of the Anthropic. It's supported by Anthropic actually. So I will show you how it works. And it's called tool use. So what we do is actually pretty close to what we had with ChatGPT. I think we can get the same example actually, if we still have it. I think we had a tool here, okay? Tools. And we add it at the top here like this, okay? We just, okay, uncomment this.
Yes, so what we need to change, we just need to change some few things. We can give a name to our function. So instead of having type and functions here, we delete this like this and straight through. Should be fine. Okay, we have a name, we have a description, we have the instead of parameter, we call it input schema. Okay, we have a type object, the properties, and the properties is actually what we are giving to the model. So here we have a tool, we have a type, string, we have a description, same. And if we have some required parameter, we can actually give them to an array here called required. It's actually pretty much the same thing. Yes, so with that, you will get the response with the tool calling actually. So let me just remove our message here and come back to a base message with the content being just hi or something like that. I think from ChatGPT we had a really interesting prompt. Let me just close this. Send a mail to contact@ulive.ai to ask for a voice AI assistant service. Okay, so this will actually trigger a text that will give us this send email and the parameter that are extracted from this text here. So let's try it out. I think we're prompting message to response. Great. And I forgot to add it to the, I need to add tools here. Okay, and then it got it. We don't have any document anymore. Yes, okay, so we can delete the document part. Yes, okay, so we try it out. So see here, I'll help you send an email, but if you see tool use block, you'll see that you have an input, the subject, the parameter that you needed, and you will find the name of the function that's supposed to be called here. And you can just pass it the same way we did with OpenAI. Let me show you if I still have it here. If response gets the function with name send email, we call the send email function with the parameters. So it's actually quite the same thing. It's pretty close. So when you know exactly how OpenAI, I forgot to mention that this is pretty important. When you know how the OpenAI API works, you can work with almost every provider except Google because they want to do the things their ways. But almost all these providers are pretty close, and a lot of them actually support the format of OpenAI. We'll talk about it when we talk about Grok, DeepSeek, and XAI. So far, this is how you do function calling in Anthropic. And so our next topic will be a bit more general things like embeddings, NPC, computer use, and more, which are API that you can use. But you can see here something about embeddings. Same, they have 3 models as OpenAI. Oh no, more models here, six models, I think 5 to 6 models that you can use for embedding with the embedding dimension here. Same process. Instead of just saying how is it called? Model.create something. I think they have a, let me see, a Voyage API here. Where is it? Where you need a Voyage API key. You get it, you install the package, you embed the model, and it will directly embed into your Voyage AI platform. So what you can do is just pass the model here. As you can see, you have a list of models here, Voyage 3, Voyage Lite, and it will give you back the embeddings, as you can see here, which is actually just an array representing the text. Okay, so same here for some add-ons. This is just manual add-on that you can use in same here for some NPC. So this is used to add tool support to Claude, so Claude can call these tools. So if you want to learn more about it, there's a complete website here. You can implement them with Python. You have pretty great tutorial about it online. But I think it's not part of this course. Same for computer use. I think we talk about prompt caching, PDF support. Mrs. Batches is actually pretty simple. I think we need to talk about moderation as well. So moderation here in OpenAI, we saw that you can do moderation with their model, a specific model that they built for it. But here you need a prompt, and the prompt is actually here. Where is it again? Here, okay? You can see here, prompt determine this, and respond with this. So you need to build it yourself. So there's no specific model that can do that. But in this case, we are lucky enough, you get a really small model and it can do this classification for you because it's a pretty basic task, right? So you don't need to spend a lot of money on a big model. You can do it on the lower cost model here. So if you want to do moderation with Anthropic, here you go. You have the link here. I just read a bit through it, copy the prompt, same. We can directly do it even now, copying this prompt, pasting it into our prompt part, and then running it with some examples. Okay, so with that said, I think we basically did everything we needed to do for Anthropic. And also, this is where you actually get real curl call when you have a new language instead of Python or JavaScript. And if you're working with JavaScript, you also get the documentation for JavaScript here. You can directly use this and format your call in your programming language with this call process here. So when you just get the URL, the API key, the version, the content type, you can directly set it up in any language using just HTTP packages, okay? And yeah, you have the API documentation here with an example and an explanation of why you need each parameter. Okay, so here, for example, you have messages, you have assistant and user, you have everything you need to build this fully functional system with Anthropic, any fully functional system with Anthropic. Yeah, so with that said, I think we went through everything we need to do for Anthropic. If you need more information, I'll put the link to the documentation in the comment below. In the next part, we'll talk about Google and then other providers and then frameworks. So if you don't want to miss that, don't forget to subscribe. Thank you for watching and see you in the next one.
Hello everyone, welcome back to the third module of our AI engineering crash course. In this video, we'll talk about Google API. So we'll go through everything Google has to offer, and including the new model, the OpenAI integration, and all of the possibilities that you have with your model. So right before, in the first two modules, we talk about AI and AI engineering in general in the introduction module, and then we went through prompt engineering. And for the third module, we talked about OpenAI, Anthropic, and now we're talking about Google. In the next videos, we'll talk about Grok, XAI, DeepSeek, open source frameworks, or open source model hosting platforms, as well as frameworks. So let's get started. As you can see here, we still have the Anthropic and OpenAI folder. So let's just close this terminal. We need to create a new folder for Google. So let's call it Gemini. Okay. So in this, we, as usual, need the requirements of txt, the .env, and the main.py. Okay, with that, we just need to come here in our .env, create a Google API key, which is an empty string for the moment. And then we open a new terminal. Okay, we go into Gemini. Then, as usual, we need to create a virtual env. So we do Python venv, then we do source venv/bin/activate to activate our virtual environment. We get it here now. And then we need to put all our requirements here. We basically have the same thing. Just take this, put it here, but we need to change this line here. And we need the new Google API. So let me grab it quickly. Yes, so we have it here. We just need this here. And then we install our packages. So Python, pip install requirements. Okay, so when it's downloading the requirements, we can come in the here. We need to put our API key here. Let me show you how to get your API key. So it's pretty simple. We come to AI Studio. You will find this Google Studio. And here you have this simple button here, get API key, and then create. It's actually in French, but the button will be the same, create an API key. So it takes some time to create the key. And then we click on copy, close this. Then we paste it here. Okay, this is our key. Now here, we need to do different things, okay? The first thing I need to show you here is how you can use Google without changing a lot in your code. So if you're working with OpenAI, we did a really long video about OpenAI. You will find the link in the playlist in the description. And you know and love the OpenAI API, you can use it completely from scratch by changing few lines to get everything that you have from Google from the OpenAI API. Same for other providers. So what we need to do is what you see here, this initialization, actually the same code. Everything we did here is actually possible with Google. Okay, so let me just show you this. By the way, to do that, I forgot we need the OpenAI requirements here as well, the version and the package. So we need to add it here and start the requirements again. We'll directly get it from cache, I think. Okay. So here, you will see that we need to change few things here. The first thing is this key. Instead of the OpenAI API key, we need the, I think I call it Google, right? Google API key. So we change it here first. And you need to pass more variables. There's a variable called base URL. And this base URL will be pointing to Google. So we just say this. This means every request going through the OpenAI API here will be heading to this endpoint here. And this endpoint is actually from Google. So they have this beta support for OpenAI for you to be able to switch from OpenAI to Google by changing only here, which means everything you did or you completed with OpenAI, you can do basically the same with Google. So let me show you how. Okay, let me give you a quick example. Let's grab an example from here. As you can see here, copy it from the OpenAI code and we paste it here. Okay. We have the model, but this model here need to change because Google do not have a GPT-4o. Google has Gemini. We can have the 1.5 or the 2.0. We can just put the 1.5 here. And yeah, with that said, we have the system and we can directly add the user per part here. Tell me more about you. Okay, so if we save this and we print the response, we clear this and we do Python man.py. Oh yeah, for comma. I hope I did. Okay, great. So we do it again. And you will magically see that we get directly a response. But if you read it, it will say here, I am a large language model trained by Google. And what's funny is that we're using the OpenAI API, right? So this is quite powerful. If you want to switch between different models, you just need to switch the base URL and you will see how this is extremely used in the industry in the next video. But for now, we have this. You can do function calling and many, many other things that you do with OpenAI directly with Google, and they are fully supported. Yes, so as you can see here, to get this, we need to just go to choices, the index 0, and then message, and then content. We get exactly our message. Yeah, and you can basically do a lot of things with it. Almost everything you do with OpenAI, simple text generation API, chat API, Yeah, but I will also show you a second way of doing things, which is actually working with the Gemini API directly. We have much more powerful feature that OpenAI does not support that we can do with the Gemini API. So let's delete everything here and create a new client. So we first remove this because I need this. We need to, from Google, Gen AI. And then for the client, we just need something like this. We load the env, and then here we do os.environment of Google API key. Okay. Now we can use this client to ask things to the model. But what is pretty weird is that for Google, for the Google-based API, you have something that's quite different from other providers. You will see that Anthropic is quite close to OpenAI, same for Grok, XAI, and DeepSeek. But the Google client is quite different. I think the reason is that Google released their model and their API between the same time. They couldn't follow the OpenAI specification or the OpenAI way of doing things at that moment. So they created something completely different. And now they're trying to get back to it by using the method that I showed earlier. But now your way to generate this is actually to just, let me just show you, use this, for example. We'll use the latest model, the Gemini 2.0 Flash. Seems to be less expensive. And we'll just say, tell me more about you. So here's the model as usual. And this content here, it is quite, I don't know how to say that. You will see that with other models, you need to pass an array of conversations somehow. But here you have the generate content. This generate content is not a chat model. It is a completion model. We'll go through the chat model a little bit later, but you directly pass the question or the user input here, and you'll get a response based on that. So let me just print the response. Clear. Taking some time, and you see we get something a bit different here. So we have candidates, we have content, and in content we have, if we get a video, if we get code execution, and we'll see that in the upcoming part of this video. But here you have text, and this text is actually a large language model trained by Google. Same thing, just that in this part of the code, we actually used the base Google API. Okay, so now we can do many other things with this. So here you saw a completion model. It's just completing text. And then now if you want to do a chat, you need to change the way you call the model. So here you will see, instead of client.model, you instead use client.chat, and instead of generate content, you will use create. So let me show you that. So what you need to do is create a chat model. When you have the Gen AI, you delete this like this, you paste this. Okay, chat is equal to client.chat.create. Just create a new chat, and you will see that the way Google did it is quite interesting, because they help you a lot with processing an array of conversations and things. But it's also drawback, because you will not support or you will not have the flexibility to deal with which content, which context you passed to the model. But let me show you how. You come here and you just ask something like this. So response is equal to chat.send message. Okay, so this is you sending some message to the model. It can be, hey, what's up? And then you get the response and you send another message. You will see that with Google, the structure is quite different. With others, you need to keep an array with user, role, assistant, and other. But here, you print the response. response.text, and you can directly ask something else like, okay, tell me more about you now. Like, tell me more. Let's say, how can I Google something like that? Of course, you shouldn't do this, but just for the sake of the tutorial, let's try it. And you will see now that, and if I say my channel is AutoGen, let's say add something else here. And what is my channel name? Okay. You will see that it's taking the context from up there. You'll understand that it's actually getting the conversation from the last message. So let's save this, try it again. Okay, you see here. So you are living on YouTube or another platform, or let's say YouTube, and then your channel name is AutoGen. You'll see that the first message has been sent to the model and kept by Google, okay, for this conversation. And when you send the second one, the context from the last conversation is actually automatically added to your conversation. So you have recurrent caching of the conversation. So you don't have to send array over and over again. I think that's quite interesting. Could have been great as a standard, but it's a bit less flexible for you as a developer. So now you can look through the chat history and print it or something like that. To do that, you need to come here and do for message in chat dot curated history. You can directly print maybe message dot parse text. Okay, it will print all the messages that we have in the conversation. So maybe I need to, yeah, should be fine. If we try this again, let's first, okay, if we try this again. Okay, you'll see that here. Maybe I need some printing or something. Okay, you'll see that it's saying hey there, and then hey there twice, and then your channel is, and your channel is, okay? So you can actually get access to your history as well, and print it if you want to. And if you see here, for example, it's saying, hey, what's my channel name? Which is my question here. You can actually get the role as well. It's pretty simple. It's just message.role, like this, message.role, okay? Yes, so this is the way you actually create a chat model with the Google API. Okay, so with that, you may be asking yourself, where do we actually provide the system prompt? Because so far we just made a conversation. We didn't direct the model to do something, okay? And to do that, we have a key parameter that we pass to the generate content. So let me show you. Let me go back to the other model. We can do it directly here as well, like this. Pass a comma here, and then we pass config. This config help a lot with many things, but let's start with types that generate content config. And then what we need to pass is here system instruction is equal to. Now we can directly pass the system instruction. It can be you funny, only make jokes. Okay, so now if you come back here, let's say we delete this part, we just need the first message, and then we run this again. Yes, of course, I forgot to import. So we need to do here from Google.Gemini import types. Okay, and try this. Okay, elephants look like a brand of vitamin C designed to help you procrastinate, take one. Anyway, some kind of job. And you can see that you can change it here directly with the system prompt. Okay, so with that said, let me quickly show you something as well. It is your capability to directly get this chat model and actually stream the response. To do that, instead of send message, you call a function called send message stream. And to handle it, you will get here some chunks, and you just need to do a for loop. Same for as with OpenAI, chunk in response. And then you will do some chunk the text here. Okay, and it will show you the chunk. So let me just quickly show you here. You see that it's giving it chunk by chunk, right? Okay, so I think we can also pass a temperature here if we want to. And for that, we need to come to the generative config here. And here, as I mentioned, I think from the introduction, I'll talk about the temperature and why it's important. So once again, the link to the playlist in the description. What you do here is just put temperature to control the randomness of the model. Okay, our temperature is equal to 0.9 maybe. And you can also pass a maxed output token. It's equal to this, for example. Okay. Oh, not taking into account this 0.1 and max output tokens is equal to this. Okay, so this will actually give you the same result, but it will be less random when you run it multiple times. It will be more deterministic, and here it will limit the return output to this size here. Okay, so I think we went through the basic of the completion model and the chat model. So now let me show you something pretty interesting from Google. So sometimes you may have use cases where the output needs to be accurate, and you may need to execute some code to actually calculate something. So for example, let's say you want exponential of 500, right? Python will do it quite well, but the AI itself may struggle to do that. Google have Google came up with some concept called code execution that lets you prompt the model to execute some code if you ask for some instruction that needs maybe veracity or that can be computed with the code. So let me show you how. It's just actually a tool that you add to your to this config here. You have type generate content config, and here we pass a parameter called tools. We'll use the same letter for function calling. So this is kind of function calling, type those tool, and we pass here code execution is equal to types dot tool code execution. Okay, so what will this do if you just say here what is exponential of, I don't know if that's too much, factorial, that's too much. Let's say this maybe. Okay, and then here we don't stream the response, we just get the response. We don't need to stream it. We get directly here response. Okay, and then let's run this and match this. Okay, I think we had some issue here. Okay, we have a trading comma somewhere. By the way, this is quite expensive because it needs to run sometimes multiple iteration to get the right answer. So use it only when you need it. Okay. Yeah, with that said, let me see. I think we had an issue somewhere. Okay, yes. I think here we need models generate content. And we pass the model. Okay. We pass the configurations. Okay. And then we call it chat.send. No, we don't need the chat.send anymore because we are not in the chat model. So we can directly get it here. So we can call this response. Oh, okay. Oh, yeah. Sorry. I don't know how it went there. It's pretty hard to debug. Okay. So it's saying client.generate content, missing one required parameter contents. Yes. We need content here. Okay. Almost forgot. So we just say you are market expert. We can, okay, and then we pass this here as contents. Then we wait. Okay, so you will see here that we have a code execution result. Okay, this code execution result gave us an output, and this output is pretty long. So it used code to actually calculate that. And what's quite interesting is that if we come here, you will see that it used Python. Okay, and you have the code that has been called here. Import math, factorial this, go to this, and print factorial this. So you can actually print what you get from the code execution part, and which is quite interesting if you want to do things that requires your model to make accurate calculations or execute code on the fly. You can use a code execution tool from Google. Yes, so now we talked about chats. We need to talk about document support. We saw that only OpenAI do not support document support. Anthropic supports document. And Google also supports documents, and that's quite simple. I just say PDF file is equal to, let me check some PDF online. I think we can use the Anthropic PDF link. Where is it again? Assets, this, Cloud 3. Okay, great. We just paste it here. Okay. And then what we need to do is either we get the content with HTTPX. So for that we say doc is equal to HTTPX, and we need to import that. That get PDF file that content, and we import HTTPX. Yes. Okay, and now we need to come here in the content part. Instead of passing this, we pass an array, and then here you will have this type like this, where this is actually our doc that we have here. Okay, this is the type application PDF, and we need the last part, which is actually a question, and the question will be, let's say, which model has the highest win rate? Use case here. Okay, so we can delete this config here. We don't need it. We just need this. Okay, I think we're printing the response. Fine. So let's run it. Okay, you'll see that here we have document Claude 3.5 Sonnet. You'll see that this is actually coming from, you don't see any Claude here. So it's actually coming from the Claude document here, the Anthropic document here. So the model is actually able to get the PDF directly and extract key information from this PDF. Okay, and what you have with Google that you don't have with other providers is the context window. You can pass documents that are extremely large. This document is actually pretty simple. You can pass like 90 pages documents because they have 1 million max context windows length. So you can pretty much work with really large documents and yeah, directly get them into your model and maybe chat with the document directly. With that said, we need to talk about some generic things. But before that, we need to talk about function calling. The way Google do function calling is quite different as well. And I would say it's original and good. Same for the chat, history. So the way you do that is that you define the function. Okay, let's say def play Spotify song title. You need to pass types here. So string, and it returns string. I don't know. Okay. Then now we just print I am playing song title. Okay. And return this. So the way you do it is quite simple. You come here in your model, and this config is actually the key. So we can comment this and comment this part. We don't need it anymore. We'll need it later. We have the model, of course. And for that, instead of this, what we need is something like this, okay? And here we have a key called tools, where we can pass an array of functions. Here we'll call play Spotify, okay? And then we have another parameter called automatic function calling that we can disable or enable. The name is quite explicit. Yeah, and then tool config, okay? Here, where we have the tool config, okay? Function calling config mode any. So this actually forces the model to call functions instead of chatting, okay? So if you ask now in the content, play, I don't know, play Kendrick, not like us. Okay, we have, yes, oh, forgot. Okay, modulating record to good and expected content, where is it? It's content. Automatic function calling disabled is set to true, but automatic function maximum mode is set to be a positive number 10. If you want to enable, okay. But anyway, you'll see here that we have a name, place 45, and a function, place 45, where is it? With the song Not Like Us. So it will call that function with the song Not Like Us. And if you see what we did with OpenAI, we had to clearly define the function and the arguments, but here we just directly pass a function, and Google will extract the key information that you can pass to the function and execute. So that's quite interesting compared to how other models actually do function calling. What is also interesting is that you're not limited to only doing this kind of function calling. You can call other functions from Google, like the Google search tool. And that's pretty interesting if you want to get a reference from what you're doing. So, and for that, we need the tools again, but but not this kind of tool. So we need to go back to the way we did tools before here. Okay, so it's this generate content and tools here, tools, and then here we call it Google search. It's type.google search retrieval. Okay, so you come here, you run it. String. Okay, I think I made some mistake here. We don't need it anymore. So let's delete this, and then should be fine. I think we don't have content. Yeah, we need contents. how compare OpenAI and Google and Gemini. Okay. Okay. So you can see here that we have some kind of HTML and some kind of web page from the suggestion from Google. But the result is actually quite far. But you will see that a huge part of this actually comes from Google, and you will have the reference for it. Let me show you here. You see it? This here, rounding metadata. You have the vertex, this link here. You have many links actually as reference for your search, which is something that's quite interesting when you want to get information directly from Google to use in your app. Okay. So I think with that we went through everything we can do with Google. We have other things that we can actually do, but you can directly see it in the documentation. So maybe I'll put the link in the description. But in general, the essential topic we discussed already. Yeah. So I think so far we went through everything: function calling, Google search, context window, prompting, chat text compilation. Yeah, I think it was everything. So yeah, so I think we will close the tutorial here, and yeah, I will see you in the next part where we'll talk about Grok, XAI, and DeepSeek. Thank you for watching, and see you in the next one. Ciao. Hello everyone, welcome back to my channel. Today we'll continue our AI engineering crash course, and we'll talk about a lot of providers. We'll talk about Grok, XAI, DeepSeek, Together, OpenRouter, and one outlier, which is a replicate. And we'll be just giving you an overview of them, how to use these providers, because they have one thing in common: they are extremely easy to integrate when you know OpenAI API. So let's get started. So we went to the introduction and prompt engineering already, and in this third module we talked about OpenAI first, which is really crucial for this video, so you need to watch that first. I'll put the link in the description below. We went through the Anthropic API, the Google API, and then we'll do the rest of the providers in this video. So let's first start by presenting these providers. We see here XAI. What is XAI? XAI is a company created by Elon Musk, extremely linked to Twitter, and releasing models. I think last year, their more than 300 billions model were actually open sourced, so you can use it for free. And I think it's extremely trained on Twitter data, so it can be biased a bit, but the model is good enough to be used in production for specific use cases. So with the tool I'll be presenting later, you will see how to host this kind of model yourself, and also how to use them in your application. Same for DeepSeek. I think DeepSeek, you heard about DeepSeek recently. They built a model called L1 that allegedly beats O1, or actually is on par with O1 on many benchmarks. It's actually from China, and it's also open source. For the moment, it is the best open source model, so you can also host it and use it yourself. And Grok is actually a hosting infrastructure, and it helps you run open source model, but extremely fast. So I will be giving you some overview at the end of these platforms with your website. But what they're doing is actually helping you run this model at a really low latency. So you can use them for apps that needs real-time data, maybe for voice AI applications where you need the text generated by the AI quickly. So Grok will be a good provider for that. So here we have Together, OpenRouter, and Replicate. So this actually hosting platform. So when you have this Grok, when you have DeepSeek, XAI, and other Llama, Mistral, and all these open source model, you can host on Grok or Together, or OpenRouter, or Replicate. So they make it extremely easy to choose and host model. You just click through 5 clicks and you have a model hosted on a shared environment, and you have the access through an API. And the way to access all these models on all these platforms except Replicate is quite simple. You just change one line in your code. And this one line is here, the base URL. I think we introduced it in the Google video. Google also supports that to change the OpenAI API to match a specific API from a specific provider. All you need to change is your environment variables that you will get from all these platforms. You will get one API key from XAI or DeepSeek or Grok or OpenRouter, and you will actually put it here. Same for Together, and then you will just change the base URL with one of these, depending on the provider you're trying to use. So if you want to use directly the API from their platform, you can. If you want to host one of these model yourself, you can use OpenRouter or Together or Replicate, and have and they will give you an API like this, where you can actually, that will help you access the model. Okay, so with that said, let me show you quickly the website of this provider. So you can see here Together.ai. So if you come to their main website, this is the documentation. They can help you host a lot of models. So if you come to the main website here, you'll see that it's actually a hosting platform for inference to fine-tune and run your model. So you can actually fine-tune on Together.ai and also host models there. So it's pretty simple. You create an account, you choose model, click on host. You choose if you want a specific environment for yourself or just want to host it generally, and you get access to the API using the method I showed you, which is also here in the documentation. So you import OpenAI, you pass the API key from Together, you pass the base URL, and you use it exactly as you will do with OpenAI. Same for OpenRouter. So if you come here, same base URL, OpenRouter key, and yeah, you have everything you need. So we can also access the OpenRouter platform here, and you will see unified LLM for interface for LLM. And you need also to consider the price, because each of these provider have a specific pricing. I think you can see the pricing here. You'll see it somewhere here. Specific for models, Llama. This is the pricing for 8B until 405. Same for DeepSeek models that you can host here as well. Seem more expensive here than on your platform. Here, same. Okay. Now XAI is actually, as you can see, company from Google, from Twitter, and from Elon Musk, and you can do many things with it, including image generation. But they also have open source models. DeepSeek, and I think you know DeepSeek already, the Chinese platform. That's actually here, DeepSeek V3, and you can see the L1 somewhere here. Supposedly beating O1 Mini in different benchmark. And the good thing here is it has reasoning capabilities, but it's really slow. So if you want the model to think and give you a response, you will have to trade the latency for that, to trade the time that the user will wait for a response in your system. And Grok here, you can see how fast Grok is here based on benchmark. You can see Together and other hosting providers. You can also check them out, but they are actually pretty fast. So they have a really simple example here where you will see, let me show you, you'll see how fast this is. This is extremely fast, 750 tokens per second. As you can see here, almost 750 tokens per second. So it's good for use cases where you have you need to have things pretty quickly. Okay. Now for Replicate, you have a specific API here. With your SDK, you use the model that you want. I think you have a list of models that you can use here. It can be visual model. It can be so you just come to one of these models. You can fine-tune directly the model on the platform and also host it. So you have the pricing here as well. So yeah, to see the infrastructure you'll be renting to do your fine-tuning or your inference. So as you can see here, you have their SDK, and you will need to go to your documentation to see how to use your platform efficiently. Okay. Yes, so with that said, I think we went through everything. All of these providers, except Replicate, have one thing in common. You can switch between different providers only with one link and one API key. So yeah, I think that's all for this video. Thank you for watching and see you in the next one. Everyone, welcome back to our AI engineering crash course. In this video, we'll talk about LLM frameworks. Just as a recap, we talk about AI engineering in the first module. We talk about prompt in the second module, and this is the third module where we talk about APIs in general. We went through the OpenAI API, the Anthropic API, Google, Drag, XAI, DeepSeek, and some hosting providers like Together, OpenRouter, and Replicate. In this video, we'll talk about frameworks like LangChain, Haystack, and LlamaIndex. So I will be giving you an overview of these frameworks with some small sample code so you see how you work with them. But most of these frameworks are made for retrieval augmented generation, which is our next module. So what will happen is that I will be giving you a real project using one or two of these frameworks in this section or in this module, where I will first explain some high-level concept to you before going through a real project. Otherwise, if we do it here, you will have a lot of knowledge that you will not, there's a lot of concept that we will not grab directly that we will first need to explain here before we start working with retrieval augmented generation. So let's get started. As you see here, we have a simple static row with each of these provider, each of this framework. So we can go through everything they're offering and how you can take advantage of this framework. So let's first start by LangChain. LangChain is actually an ecosystem of tools that you can merge together to create an application. It's one of the first LLM framework, and it was built to abstract the LLM logic from the application, so you can easily switch between providers, easily adapt to many different APIs without having to rely on each API specification. Today, a lot of these API providers actually support OpenAI. It wasn't the case before. But even with that, as you saw it last time, function calling can be different from provider to providers. Same for how you actually do some few things. And if you really want to support all of these providers and be flexible enough in your code, LangChain, Haystack, and LlamaIndex can be really helpful. Same for having an ecosystem of complete tools, so you don't have to code everything from scratch. For example, PDF loaders, vector store connectors, and many other things that we'll see in the next part of this video. So let's first start by giving you some overview of all of the LangChain ecosystem. The first thing is prompts. LangChain gives you an easy way to work with prompts. It can be with templates, templating engine for your prompt, so you can directly write a prompt with some variables that you can use later. And it also offers you a prompt hub, so you can pull prompts from people from the community. If you don't know how to write good prompt, you can actually just search there. If you find a good prompt matching your use case, you can directly use it. So let me just give you LangChain Herb. If you go in LangChain Herb here, you will see that you have a lot of prompts. So maybe you can just pick one. Rack prompt, Agent, React. I think we talk about React in the prompting part. Yes, so you can just choose here from the hub the prompt that suits your case, and directly integrate it into your code. Otherwise, we have the vector store. That is a concept that we'll talk about in the rack module. So subscribe to see that video coming next time. You have the document loader, the text splitter, also concept that we'll be explaining in the RAG module, but in general, they actually use to work with documents and to be able to feed a context to your model that's actually based on some document or some web page or some other tools. The output parser, we have the models as well. The models is quite interesting because LangChain actually abstract the model logic from the implementation, as I mentioned before. As you can see here, we have different models, right? So you'll see that only the model name, the provider, and maybe some API keys will change when we'll switch models. So if we switch to OpenAI, if we switch to Anthropic, we switch to Together, you'll see that you can easily change your application logic without having to completely change everything. You can easily change your API provider without having to change your complete application logic, which is pretty interesting. So let's say you're working with OpenAI and suddenly DeepSeek's cut costs by 10% or 50%. You want to switch there. Instead of re-implementing everything you did in your code with maybe the new DeepSeek API, the good thing or the best thing now would be to just change. If you used LangChain before, would be to just change the provider, the model, and the API keys, and you're good to go. So in the last video, I showed you many providers, and most of these providers are actually supporting OpenAI API. It wasn't the case before. And even with that, you will see that just a fraction of what this model can do is actually supported with the OpenAI API base URL trick. So you still need to have an abstraction to be able to work with different models easily. And you can see down there that LangChain support a lot of models. So you can choose the one that suits you, local LLM, it's different providers from different, you can choose and integrate it into your app. And as I mentioned before, it will actually be the same thing. So I think CrewAI is one of the providers that we didn't talk about in this video. And you will see that the module that you're using, these human messages, this chat and everything in abstraction will actually be purely abstracted from the library itself. I think AI21 Lab is one of the providers as well. We have a video about where AI21 Lab and OpenAI when they were the three provider on the market. It's on the channel. You can check it out. And as you can see, you will see that you have this implementation here, and you can have nearly the same logic with the chat prompting with the chain, where you put the LLM here and you can change the LLM to any other provider. The same logic and the same code will work. So that's one of the powerful features of LangChain. And now the tool ecosystem. This is one of the most important thing working with LangChain. It is a tool ecosystem. So if you type LangChain tools, you will see that I think it's this one. No, not this one. This one. Okay, you will see that you have a panoply of tools here. Okay, if you want to code this yourself, you will pass a lot of time coding a Bing integration, Brave integration, Google integration, and GitLab integration, GitHub integration. So you will see on this page that you have so many integrations that it makes it Google integration, Google Drive, that it makes it extremely easy for you to work with all of these tools. So if you're building an app that's supposed to connect to one of these providers, LangChain is the right framework. Same for other providers that we'll be talking about here. So using a framework instead of building everything from scratch, using maybe OpenAI API will be better. So you don't have to recreate the wheel. You can just use the modules, give the folder maybe, and load everything from Google Drive. Building this is quite complex if you want to do it yourself. So using a framework is the right way here. Okay, so with that said, I can show you some sample code. We'll just build a sample LangChain application later, but let's just go through the overview of all of this framework, and then we'll go through the code later. Here we'll see Haystack. Haystack is actually framework from DeepSeek, not DeepSeek, but DeepSeek. So let me show you how it's written. DeepSeek like this, not DeepSeek. Okay, DeepSeek like this. Okay. Yes. So they created it around the same time as LangChain, and the specificity or the speciality of this framework is that everything is built as a pipeline. It makes it pretty easy for you to chain multiple process that look like a pipeline that will fit into a pipeline. Especially document processing or document integration with tools and things like that. So you can see, for example, here in this image that you have generators, which are actually, just LLM providers, embedders to actually I will think we'll talk about it later, to compute embedding and save it. Retrievers, retrieve, these are vector stores, document, and then ranker, router, preprocessor, and a lot of these things that you can just compose and create a pipeline out of it. And the pipeline will be something like this. You get a query, you embed the query, talk about it later again. You retrieve the query later on, you create your prompt, and you generate a response using one of these tools. So Haystack is actually quite interesting when you want to do retrieval augmented generation as well. But it's not limited to that. You can actually build AI agents with it, and many other things. Now, Llama Index. Llama Index was first called GPT Index, and it was a module built on top of LangChain to specially work with documents. I think they extended it, they changed some modules. Now they are being a bit more independent from LangChain, but at the core of it, it was mainly built to work with documents. And that's the reason why I mentioned we cannot really use this frameworks without talking about retrieval augmented generation. But in general, it's kind of the same thing. If you go to Llama Hub, you will see that. Let me go to Llama Index Hub. You'll see that we have kind of the same thing, right? We have kind of the same tool that you have with LangChain. So if you search for data loaders, you'll see that you have here web page loader, Reddit reader. I don't know if you have Drive here. Google Drive reader, Google Calendar reader. So we nearly have the same loaders, right? It's actually the same ecosystem as LangChain, nearly the same, just that it's purely built for data. So it's mainly interesting to work with Llama Index when you want to work on top of data. Yes, so that's the reason why you can see here that you have this vector database, vector database, and integration with tools. And Llama Index actually orchestrating working with all of these tools, the database, and the providers as well. Basically, all of these tools actually help you build AI application easily. LangChain is helping you with the ecosystem and compose them to build complex application. It can be AI agents. LangChain actually have an AI agent framework. We'll see that in the upcoming modules of this video called LangGraph. Haystack is actually interesting as well to build application using the pipeline architecture. And then Llama Index is quite interesting when you want to work on top of data or documents. Okay, so let's go through some sample code. I'll just show you some sample code of LangChain, Haystack, and Llama Index, and we'll go through it together. Okay, so here we have our framework folder. Okay, it's empty for the moment. So let's create a new terminal. Okay, it's already there. Let me go to the framework. First thing first, we create a virtual env. Then resource vm /bin /activate. So that's done. Now we need to come here and create a .env. So that's the first thing. Why? Because we'll be working with providers, and the best way to keep our API keys secure is to create a .env. So let's do .env here. I'll be pasting some keys here. I'll actually show how to do this in last tutorial, so you can watch it again if you want to see how to create an API key and other. So what we'll be doing here is that we'll be giving the document loading functionality to OpenAI. If you see it from the Gemini point of view here, we did document loading, PDF loading. For Anthropic, same. We were able to load PDFs directly, but unfortunately, we don't have the same functionality. We don't have it here anymore. But unfortunately, we don't have the same functionality with OpenAI. So we'll try to give that functionality to our OpenAI API today. So let's create a file. The first example will be with LangChain test. And don't name your file LangChain, otherwise we'll have a problem with importing your modules. Okay. With this, what we need to do is first install all the required modules to work with LangChain, right? And these required modules are quite simple. Let me just put a requirement.txt here, requirements. .txt. In this requirements file, we'll put LangChain community, LangChain core, LangChain OpenAI, basically LangChain modules, and we can actually install that just by keep installing LangChain and all the providers that are related to LangChain. But I think we have it here first. Okay, here, put it here. Python. We also need the dot here .env. Okay. Okay, so now we can install these modules and start using it. So here, pip install. Yeah, we need some PDF processing part as well. So let's put this here for reading our PDF and transforming it into documents. Install requirements. Okay, installing everything. And then what we need to do is to import first all the modules that we'll need. And for that, we need to import the OpenAI chat. Let me see here. First, install OpenAI, import it. We need a prompt template. I think we talk about prompting and the prompt template that LangChain comes with it. You will see how to use it here. And then we need to install the PDF loader here. And as usual, we need to load our .env, our environments, to load the OpenAI key into our environment. What LangChain is doing actually is that it's getting the key directly from the environment, so you don't have to pass it directly. But if you can actually pass it if you want to, but it will read a variable called OpenAI API, OpenAI API key, the way we have it in our .env already, so it's fine. So with that, what we need is to create a PDF here, and this PDF will be what we will be working with. Okay, so let's paste the PDF here. Okay, this PDF is actually just some it's how's it called, RFS from request for startup from your YC, and we'll be just building something that will read through it and just summarize it quickly. And you can build some things to suggest startup ideas directly based on this RFS as well. You are free to exploit it as you want. But in this video, we'll just be summarizing the content. Okay, so with that document, what we need is to load the content, and to load the content we use this by PDF loader. It's pretty simple. You will see that we have here by PDF loader, we pass the name of the file and we load the file. This PDF will be loaded into different documents. So if we print this, print documents, okay, and we go in our, let's clear this, and we do pip of Python LangChain test. Taking some time, and you will see that we have many documents here, okay, with the metadata like total pages, the actual page, the page label. So maybe if you extract something from a specific page, this is actually made for RAG, and we'll talk about it later again. But if you extract something from a specific page, you can actually highlight it and give it as a source. But here you will see that it read the PDF and cut it into chunks, or into documents, not chunk, into documents. And you will see the page actually request for startup. At YC, we often discuss ideas that we'd like to see more people working on. So with that said, we can delete this. And our next thing will be to merge all of this document. For the moment, we do not do vector storing, semantic search, and things related to RAG. I will just be feeding the whole document to the AI. In the RAG part, we'll be optimizing this to make sure that we only feed the part that we need to the AI. But okay, for the moment, we'll just go through the documents and merge them. Okay, we're going to the next line after each document. And then with that, we need a prompt template. This prompt template is actually a custom prompt template where we have two input variables. We have here the PDF content and the query. Okay, so you can create a prompt template like this and use it in multiple apps if you want to. You just have to pass these two variables, the prompts, the PDF content and the query every time you call the prompt template. And then we create our LLM instance. Okay, so here we pass the model name. It can be GPT-4o as well. I'm just trying to be cheap. We pass the temperature, and then we have our chain. So what we do here is that we compile our prompt like this. We pass a query variable and a PDF content. So the query variable, we need to create it. It will be this one, saying summarize the key insight from this report. It will just go through the PDF that we loaded here. That will be passing with this variable down here, and send it to the LLM to summarize. So how do we do to send it to the LLM? We do LLM.invoke and we pass the prompt, which will have this variable replaced already and this variable replaced as well. So, okay. And after, we just print the response. So if I clear this and I run it again, taking some time, and you will see the response from the AI here. The report outlined a list of startups in the AI and software engineering space, including secure AI app store, data center, compliance, and audit. So this is a good summary of the document, but this is quite bad in terms of implementation. Why? Because you are feeding a 5-page document to the AI, which is pretty expensive. In the RAG part, I will show you how to cut this document and just feed the specific part that the AI needs to know to answer the question. Okay, so LangChain test is done. Let's do the same with Haystack. Haystack test .py. Okay, but to work with Haystack, we need to install Haystack modules and modules from Py. And for that, we need Haystack AI. So let's add it to our requirement and install again. You will install the missing modules. Let's just install everything with Llama index and everything, so we don't have to do it every single time. Okay. Okay, I think everything is installed. So with Haystack, we have kind of the same process. Okay. We first, of course, import the modules. Let's just import everything directly here. This will help to read the file. This is actually an internal package, an internal object of Haystack to actually help you build pipelines. And these pipelines are based of components, and these components will just be what you will be putting into your pipeline. It can be retrieval, it can be a tool, it can be a provider, but in general, you need this component into your pipeline. Okay, so now that we have this, as usual, we need to load our env variable to be able to use it later. Okay, great. So now, same, we need a prompt template, but this prompt template will just be simply a template like this. And for a Haystack compared to LangChain here you have one single bracket. Here you need double bracket. And what's interesting here is that it works like a template engine, which means you can do for loops in there if you have an array, for example. Okay, so with that said, let's create our pipeline. We have this. Okay, and then we add some components to our pipeline. So we first add the prompt. So our pipeline starts with the prompt. I think we need to do this. Then we have the AI that will get the result from the prompt. The complete prompt will get the AI, will be fed to the AI, and the AI will generate something that the answer builder will take. You just added component here. Now you need to create the logic, and the logic will be connections, which we'll do here. And then we connect this like this. Yeah. So it's just saying that our prompt builder here is connected to LLM, and our LLM replies will be fed to the answer builder replies. So this will look like a pipeline. You can actually grow it like this to see how it looks like. So let's do that, and we need to just Python hashtag. It will, if everything's right, it will create a file here, and this file will be this. Okay, so I'm just zoom through it. You see that we have the prompt builder that takes PDF content, question, and some other variables. This prompt is a string at the end that's passed to the LLM here, and this LLM get the system prompt, streaming, callback, and other, and send replies to the reply builder, and the reply builder will just generate the result with it, and the metadata if needed, the meta as well. So, yeah, so we get it here. So what we need now, we have our pipeline already built and visualized here. We just need to call it, okay? And to call our pipeline, we need to feed the information that we have, which is actually the PDF. And to do that, you need to call the PDF module and convert it into documents, okay? We read it and we convert it into documents, and we do the same that we did with LangChain. We transform that and save it into a single variable. Normally, this document, you save it in the vector store, but in our case, we're merging them and putting it into a document. Now, we have the query, which is our question here, same as LangChain. And then we just run our pipeline, okay? Running the pipeline is as simple as doing this. From builder, question, you pass a question, PDF content, you pass a PDF question. These are actually what you get here. This and this is actually the parameter of your prompt builder, right? That's the reason why you're passing it here. And each of the pipeline component, if it needs a specific input, you need to pass it as a parameter here. Okay. So great. Now we can print the result. Okay. Just okay, and then run it again. Taking some time. So in the meantime, I can create directly Llama index. Apply. You can see that it worked properly, right? We have the report here. We built our pipeline and we feed and we run it here, okay? And it's working properly. So now for Llama index, it's nearly the same process, okay? First, we import the modules, okay? Same. We have this. This is quite specific. That's the reason why we have this PyMu PDF here. We install this. We use OpenAI path, as I mentioned, to read the file on the system. Chat message load.env to load the environment variables. So we load them here. Okay. Now we need to read the PDF, and same. You will see that they actually have the same high-level logic most of the time, but the architecture is quite different. So here we merge them. I actually explained that already. We create a prompt, same, but this prompt is actually just a normal Python template. And then here we create our LLM with the model and temperature. And as usual, the API key will be directly extracted from the environment variables, okay? And then here we create a message. This is actually quite close to OpenAI. So we imported the message module, the chat message module here, and we create the system and the user message here. And then all we need is just to run this by doing this and then printing the response, okay? And then let's run this Python llama index test. Taking some time. Okay, great. So we get the document outline, very startup AI and technology. You'll see that llama index is quite fast. It is purely optimized to work with documents. This is a really simple use case, but you can do complex things on top of document with llama index. Yeah. So I think that's it for this video and for this module. In the next part, we'll talk about retrieval augmented generation, where you will understand in depth how to work with documents and how to work with tools, and also how to use these frameworks to make this whole process pretty easy. So thank you for watching, and see you in the next video. Hello everyone, welcome to our AI engineering crash course. This is the first course of the third module of our complete tutorial. So in this first course, we'll talk about embeddings. In the past module, we talk about AI and AI engineering, we talk about prompting, and we give a complete overview of many providers, including frameworks also, and hosting platforms. In this module, we'll go through vector databases, retrieval augmented generation, and globally how to use external source of documents into your application. So in this first part, we'll talk about embeddings. And in the second part, we'll talk about vector database and semantic search. And then in the upcoming part, we'll talk about RAG, chunking text and error handling, libraries, which are actually frameworks that we'll be using, and we'll build a complete project together. Let's get started. So we first need to start by talking about embedding, okay? And to talk about embedding, we need to understand why it has been created at the beginning, okay? So let's first just say you have a simple problem, okay? You want to search for a specific thing in a really long document. Let's say what you're looking for is actually a new subscriber to the channel, okay? Let's say you have a text like this, and you would like to see if subscriber is in this text. How do? You do something like this, right? So like this. You try to match subscriber to every single word here. You try to match subscriber to A. You do like a word-to-word comparison. And when you reach this word here, you'll see that everything's matching, right? Every single character is matching the subscriber here. So you can say, oh, I found subscriber in your text, right? So what happens if this subscriber here is written that way? Like subscriber like this. It will actually fail, which will limit your capacity as maybe a search engine, maybe a local search engine or a global search engine, to give response that contain errors. So many algorithms has been created to actually solve this problem, which help calculate the level of similarity between the text that you're trying to compare to the actual text. So it will say, okay, you can use the Levenstein distance, for example, to say to quit from this to this, you need like to this subscriber to this subscriber, you need just to add one S, so they are pretty close. So maybe you wanted to say subscriber. So what if you say a new member of my YouTube channel now, of YouTube? Now it's completely different. It's kind of the same meaning. Subscriber is a member of your YouTube channel, but the search will fail. Why? Because member of the YouTube channel is not written the same way as subscriber. So this is a really big problem, and embeddings is coming to solve that, right? Embedding is a really generic concept that has been implemented in so many tools out there. For example, Google image search can be implemented using embedding, and I will explain how later. Same for Google itself. You can build a simple search engine for your local website or for your local database of documents using embeddings. Embeddings is a really powerful concept. So let me first start by explaining what embedding are supposed to be. So let's say you have a text. Let me just draw a quick line here. Okay. Let's say you have a text like this: Queen, King, Dog, Woman, and Man. Okay. How do you do to actually represent the semantic of this text? They have different way of being written, but if you want to get the meaning of the text, you need to actually transform them into a numerical representation, plot them in some kind of space, and make sure that the distance between different items that are close in terms of meaning is smaller than items that are far in terms of meaning. Okay, so let me just draw an example here. Let's say we have this, this space here, like 2D space, like this. Okay. If you have a point A here and a point B here, and maybe point C here. If you plot a lot of words in these different places, you will be able to know that this is pretty not that close to this word compared to this and this, right? Okay. So that's the same concept. If you put queen here, if you take this queen and you put it here, no, let's say dog here. Sorry. Dog here, king here, and queen here. You will see that dog is far in terms of meaning to king and queen. Okay, so the concept of embedding is to create a model that will be able to get some text and infer the semantic meaning from this text and be able to generate or create a vector of numbers in some kind of space that mimic this semantic, okay? Which means in this vector, you will have words that are related, that are pretty close. So you can actually do a simple distance in terms of member of YouTube to subscriber. This is actually sentence embedding. And see that, okay, member of YouTube in my space is kind of close to subscriber. So maybe the person is trying to search for subscriber. So that's the whole concept of embedding. Okay, and it's applied to many things. It can be applied to images. So if you extract some feature from an image and you are able to have them in a space where image with similar features are close enough, you can do a Google search by image. Because when someone will give an image, you extract the features from that image in some kind of numerical representation, and you'll see that, oh, this image that the person gave is quite close to this other image, so I can show it out. Okay, the whole concept of embedding is to actually just have in some kind of space multiple words, so the dimension is really high. It's not just a 2D space. Multiple words, 1, 2, 3, 4, 5, 6. These are actually words. And to make sure that these words, let me put some red, these words are close enough in terms of semantic. So when you calculate the distance between them, it's small. The distance between this and this, this and this, it's actually small. So you can infer that they are semantically close. Okay. Yes. And in terms of semantic models, you have a lot of providers that build really good models. OpenAI has an embedding model, Google, Anthropic, and you can have Hugging Face embedding as well, if I'm not wrong. You have many embeddings models out there. You can just go on Hugging Face, find some embedding in there and use it in your app. And right away, even without any LLM, you can actually make some really good app like semantic search on text, for example, or just semantic search on images. So you just need to find an image embedding that's trained with a lot of images, okay? And that's accurate enough to have the right feature for different range of images. So that's it. Embeddings just means having text represented as a vector. And this vector is in a space where words with related meaning are close. So the distance between these words are pretty small. Okay, so with that said, this is the theory part of this. Now, the practical part of it is how do we use it with our retrieval augmented generation? As I mentioned in the last module, we went through, we built a simple app that get a PDF and try to answer some question based on that PDF. And what we were doing is feeding the whole content of the text to the AI. So what if when the user asks for something pretty specific, we are able to go through that exact part of the PDF, extract exactly that part, and give it to the AI so the AI can use it as context. That's pretty interesting, right? Instead of feeding a lot of token and burning money, you can just feed a small part of your PDF to the AI, and the AI will be able to answer the question correctly only based on the information you feed it, you give to it. Okay, so that's interest. That's what we will be doing in the next part, which is about providers like vector data, vector store, and semantic search. And I will show you how to use these concepts clearly into your app using LangChain. So thank you for watching, and see you in the next one. Hello, welcome back to our AI engineering crash course. This is the second video of the fourth module where we'll be talking about vector databases and semantic search. In the first part of this module, we talk about embedding. We explain a bit what embedding is and how you can use them and why they actually exist. In this part of the video, I will give you some embedding providers, some vector store providers, and show you how to do semantic search and how to query data from a vector store. Okay, so let's get started. From this last part, we stopped here, right? The good thing is that you don't have to deal with the model. You don't have to train a model. You don't have to implement the whole logic. It's actually pretty hard to do everything. So what you need to do is just use vector store, use embedding models, and compute the embedding and save them in a vector store that you'll be using later for your AI application. Okay. And as in the last module, we presented multiple providers. You can see that these providers actually support a lot of vector store. Okay, if I do LangChain vector store, it choose this one. Okay, you will see that here we have a really long list of vector stores. Okay, all vector stores, you have all of these vector store. So these are like databases for your embeddings. So it means when you calculate the embedding using models that actually exist, like OpenAI embeddings model or Anthropic model or Google model, you save them in this database, and the whole process is simplified by LangChain. If you want to do it yourself, you can actually code that. It's not really an issue. But if you want to go fast, you can use the LangChain or the Haystack or the Llama Index ecosystem to go fast when it comes to embedding your document and working with document in general. So let's say you choose CrewAI. CrewAI is actually just, you can choose it online like this. It's just a startup. Here, open source AI application databases. So as I mentioned, it's saving your data and retrieving it based on your query. Okay. Same for many of these providers. You have Typecone as well. You have, I think you have somewhere here, Wave8 as well. In Fires as well. But we'll be using the in-memory vector store. It's actually the same thing. Nothing will change when you switch from in-memory vector store to Chroma or other provider. So we'll be using this only for example purposes. Okay. So if you want to see the complete list of provider, this link is the best way. It's the best results. You can do the same with Llama Index vector store, vector databases. So, and here normally I think you need to go to the hub. Okay, Llama Index hub, and you look for vector store. You will see all the providers here. AWDTB, Redis vector store, even MongoDB. You can save your embeddings into MongoDB, same as Postgres. If I'm not wrong, you can do the same with Postgres already. Postgres support vector store already. And you can also use one of these new providers like Wave8 or Pinecone. I think we should have Pinecone here. Pinecone or Elasticsearch Store. So you're free to choose here. And as I mentioned, these are actually abstraction layers. So you can switch from one provider to another pretty quickly by installing it and just calling it. Okay. Same here. So if you want to use ClickHouse instead, you'll just see that you install the ClickHouse module, and then you initiate your embedding model and you pass it to your vector store model. When the vector store is ready, it's just chained with other tools, so it's fine. You can change this click out to some other provider later. It's fine. You will not have to change your whole application logic. So with that said, we have all of these providers. We'll just be using the in-memory vector store. And let's just go through a sample example where we'll actually put the document that we had in the last module in some vector store and query it. Okay, let's get started. Okay, you can see that we stopped here last time. Let's go in the LangChain version. You'll see that we have documents here, right? But we are doing nothing with it. We are just concatenating it and then adding it to the prompt and then sending it to the AI. And if you see, we had some place here, the whole document, which is really long, right? We don't want to do that. So what do we need to do? We can create a folder here called rag, and we'll just create a LangChain memory.py. And in this file, we'll actually put all the logic to save the documents that we have here, the startup document, into the vector store and retrieve it. Okay. So to do that, we need to, of course, as usual, import our modules, right? So we do this, we import all our modules. Here you have the document, the PDF loader. We talk about it. The new thing here is the in-memory vector store. And this in-memory vector store can be replaced by, ChromaDB or whatever. It's just a database for your embeddings, a database for your numerical representation of the text that you'll be giving to the AI. OpenAI embedding is the embedding module from OpenAI that will be calculating this numerical representation of the text that will be feeding to the model. Okay. So now, as usual, the first thing is to load the M variables so that the AI can use it, right? And then we initialize our vector store. This is how we do that. Very simple. In memory vector store, we pass our provider here, the OpenAI provider, and then we have the vector store ready. Okay. Now we do the same code that we had here with LangChain, this exact code here to load the PDF. We do it here. We load our PDF. We need to change here to okay. It will go in the PDF. I think no, we can just directly run it this way. If I'm not wrong. Yeah, we'll see. We have all the documents here, right? All our documents. You can just first print it again. Print documents so you can see that it's actually split. So if you do Python rag and then LangChain, you have all our documents here. Okay, and maybe let me drag it like this. It's an array of documents. Document with values and yeah, and with metadata as well, like the source, the file, the total pages, the actual page, and other. So that's fine. Now, how do we do to, let me just drop this down, to save it? Pretty simple. You'll see how simple is it. So we just do this, vector store.add documents. So our documents that this PDF will be saved in our vector store as numbers. Okay. Okay. So with that said, when we'll do this document here, we can actually just do maybe I can, if we run this again, maybe we will not see the thing, but it will save this document in the memory. Okay. I don't know if we print the vector store, we'll get something out of it, but let's see. It's just an instance of the vector store. So now, how do we do to make some search on it? It's pretty simple as well. We just call the function similarity search. So everything is simplified with the framework. That's the reason why you need to avoid coding everything from scratch. You do something like this, vector store, similarity search, and then we print the result. Okay. It will actually go through the documents that we have. Oh, it's results that we have, and try to find the sections where we are talking about AI agents. and print it. Okay, so here you'll see that this is less than last time. I asked for 2 documents. I can ask for 1 only, and you'll see that it's even smaller than what we have right now. So this is smaller than this, right? So it went through the list of documents and extracted this document here with this content. What is it again? Page content. Language model can already code better than humans. Yeah. So you will see that in terms of sense, this everything is actually close, but this is close to we're talking about AI agents and things. And you can change and be like, okay, I don't know, infrastructure and I don't know, aviation. It will find the thing that is closer to this and send it back to you. So if you search it again, we'll get a different document. Idea appear when you're reading your book. App Store is an app store where you will be, okay, you see, you support the infrastructure needed for AI progress, hyperscale data center projects, and you'll see that we have some terms here that are close to the infrastructure term, right? Same. So what we can do now is instead of passing all these to the AI, all the whole PDF to the AI, we just pass this, okay? And the AI will extract the answer directly from this. If we ask, give me the ideas that are related to infrastructure, and we get the 2 or 3 first documents, the AI will summarize it and use it as context to actually answer your question, okay? So I think that's enough for this part of the video. And in the next part of the video, we'll actually talk about real retrieval augmented generation on real documents using LangChain. Okay, thank you for watching and see you in the next one. Hello everyone, welcome back to our AI engineering crash course. Today we'll talk about RAG, retrieval augmented generation. So before that, we went through all of the concept that you need to understand before building AI applications, like general concept about AI engineering, prompting, APIs with multiple providers, and also LLM frameworks. And in this module, we talk about embeddings, a vector store, semantic search and querying that we will be using in this video here. And in this video, we'll talk about retrieval augmented generation and chunking text. And in the next one, we will use the libraries that we introduced in the last module to implement retrieval augmented generation. So let's get started. From the last video, I mentioned that there were a lot of concepts here that we will need to come back to, okay? This is the time we need to come back to these concepts. So just let me introduce to you retrieval augmented generation and why it is an important concept with LLMs. Okay, so what happens is that we created LLMs, right? We created large language models in this, and this large language model can generate text extremely well, but it's not useful because it hallucinates. Okay, it means if you want to have real knowledge from the AI, you can get a lot of errors back and rely on these errors to take decisions, which would be not good for your company or for your use case, right? So they created something called retrieval augmented generation, which means you try to feed to the AI the context of what it should be considering while answering a specific question. It can be something like, okay, you have a document, an internal document about maybe some company policy document like this, and you want to add something specific to the AI, like, okay, how many sick leave do I have in this company, right? Without the context of this document, the AI will just answer randomly and give you a wrong number. But if you get a specific context, which means getting some chunk of this document, let's say something like this, this chunk talking about sick leaves, you'll be able to give that to the LLM, and then the LLM will use exactly this context to be able to answer back. And if the LLM finds nothing from this context, you will say, sorry, I don't have the answer. So it helps you reduce hallucination, and it created a really big new use case for AI, which is document question answering, working with knowledge base or company's knowledge base or company documents, which became really, really popular in 2024, last year. So in this video, I will just explain to you how we are able to go in a long document, get a single part of this document related to what you're asking for, feed it to the AI, and get a response that's actually accurate. Okay. So, and let's start with this thing here. So let's first say you are a company. Maybe you have a lot of documents. It can be videos, it can be on GitHub, on Drive, or whatever. And you want to be able to chat with these documents. The first thing you need to do is to connect all these documents to your app and load them in some kind of objects in your app. So that's possible with the set of tools that we have out there. You can actually connect to many data sources and pull data from these sources. When you have the data into your Python or TypeScript app, you can now transform this data and maybe separate them, which means, for example, you have here company policy, you have here contract, you have here maybe pay slips, and then you are able to chunk this single document into small pieces that may make sense to give to an AI. So in the company policy part, I think I mentioned it somewhere here, you need to chunk it as small part like this. First part, second part, and third part. And this part are actually made for to be small enough to be passed to an AI and to be large enough to have a meaning, right? So if you take two paragraphs of this text, for example, of your sick leave, it may be enough to be able to give a real answer about the question you're asking for. Same as taking 2 pages. But the problem here is you cannot go too far. You need to be specific in the number of pages. You need to be as short as possible in the number of characters you're taking, because the more context you give to the AI, the more extensive it became. And you also need to be as large as possible in the amount of value that you have in each single chunk, right? Okay, so you do this part here with chunking. And then what you do is you calculate the numerical representation of each of these single chunk of text that you created. We talk about embeddings, and what you may keep in mind is that in this document, chunks that have same meanings will have in the space where we can plot these vectors nearly the same location. So if you have vacancy policy and something closely related to it, they will nearly be at the same place. So you can give this data, this numerical representation, and the related document to a vector store. This vector store will keep them and internally have an algorithm that can calculate which document is close to what other document. And then you have the last part here called retrieve part. The retrieve part actually come when you start working with LLM and you want to retrieve a specific context for a specific question. And that comes to this part here. Okay. So let's start over again. You have a knowledge base, like a lot of documents. You get this document into your app using data connections. And then you chunk them into specific small set of text. Okay. This set of text are small enough to not be too much for or as a context to the AI, and big enough to have a certain meaning so you can extract information from it. What you do is that you compute the embeddings of this chunk of documents and you save them in a knowledge base as vector database, like a vector store. So now all of your documents with the related text is saved somewhere. Now when the user come in and say, okay, how many sick leave do I have in this company? The AI will get the query, okay? Create the embedding of this query, which means the numerical representation of this text. And as I mentioned before, texts that are close enough will have, texts that are close in meaning will have a small distance in the space, okay? In the space when we plot all these numbers in some kind of space. So when you compute the embeddings, the distance between the embedding of the query of the user and the text that you have, the documents that are closer to this embedding here are actually the one that may have the meaning or the information you're looking for, right? And you extract this data. You maybe choose 5 of them, top K similar document. So this is called similarity search. I think we talked about it in the last video, where you actually extract documents that are similar to the user query, and you give this document as a context to your large language model. And at the same time, you say to the large language model that if you don't find any information from my context, just say you don't know, okay? And you feed it the user query as well. So the LLM now knows, okay, this user is asking about sick leave, the amount of sick leave he can actually benefit from the company. And we have this set of K documents, 3, 5, 6, 10, depend on you and the budget that you have, that may mention it, okay? If the AI is actually able to find some information in the context that you gave, that you extracted here, which is actually some part of the documents of your internal company policy, for example, it will say, oh, okay, this is the answer. We have 21 or 10 sick leave days, okay? And it will give back the answer to the user. So that's basically retrieval augmented generation. So retrieval is for this part where we retrieve the data from a vector store. Augmented is to augment the context to our LLM, and generation is to generate a response and give it back to the user. Okay. So now, in the haystack example, in the framework videos in the last module, we went through all this. We had generators, embedders, retrievers, converters. I think you should be able to understand some part of this picture here, with the generator just being LLMs, the embedders just being the algorithm or the models that actually compute the numerical representation of this chunk of text. So we have OpenAI, Azure, Hugging Face, and many other providers, Google and Anthropic and others. Now we have retrievers. So these are actually vector store. Okay. So when we compute this with embedders, we feed them to the vector store. So it's just like a database. And this database contains two different information: the embeddings, which is the numerical representation of the text, and the text itself. And when you get a document or a query, you go there and you're like, oh, give me the closest document to this, or the closest text that resemble what the user is asking for. And when you get back this, you can directly feed it to an AI. Okay. So here, for example, we have a pipeline, an haystack pipeline, that actually does what we are explaining. We have some query here. We suppose that you already created a vector store with all your documents, okay? And then from the query, we create the embeddings using one of these embedding model. And the next step on the pipeline is actually just comparing these embeddings to what we have in our vector store. Query embedding, and we get back some documents. We create the prompt with these documents, and we feed it to the LLM. The LLM just generate a response, and we give back the response to the AI. Same for Llama Index here. So in general, when we talk about RAG, it means we have a set of documents that we created, that we integrate into our app. We chunk this document. We create embeddings based on this document. We save it in the vector store. Okay. And when someone asks something, we go in this vector store and retrieve all the documents that are really close to what the user is asking for. And we get this document, we give it to the LLM as context. And the LLM generates a response that may be more true than just straight LLM knowledge. Okay. And as you can see, many of these frameworks are actually built around the same concept. Llama Index is purely built on top of manipulations of documents. Haystack pipeline are really optimal when you work with documents. And as you see here in LangChain tools, you have vector stores. Now you should understand what vector store means. Text splitters to split text, this long document into small text. It already gives you this framework already gives you all the results or the tools that you need to do everything we explained here. So you don't have to think about, oh, how do I compute the numerical representation of a text? How do I transform this text? How do I chunk them? How do I store them? How do I calculate the distance? All of that is actually handled by this framework. So if you choose LangChain, Haystack, or Llama Index, you will be able to get the same result at the end, which means having connectors to pull data from different sources, so you don't have to worry about that. Having chunking or text splitter to split these documents into chunks. Having a vector store to be able to calculate embeddings and embed this and save it into the vector stores. Having where is it again? Sorry. Having here retriever from this vector store, having also an LLM modules where you can just feed this context to the LLM and get a response back. Okay. So with that said, I think the general concept around RAG is actually what I just explained here. In the next part of the video, I will give you a real overview of the whole process here. We'll not be talking about rankers or routings or much more complex topics. I will do a separate serial video about RAG and how you can get the most out of it with augmenting accuracy, making sure you always pick the right context or the right document in the database, and many other concepts that we'll not be talking about here. I will also put a video in the description from LangChain, giving you a deeper knowledge about RAG using LangChain. So yeah, thank you for watching, and see you in the next video. Hello everyone, welcome back to our AI engineering crash course. Today we'll implement retrieval augmented generation using different libraries that we saw so far in our course, which are LangChain, Llama Index, and Haystack. But before that, we had 2 modules about AI and AI engineering, 3 modules about AI engineering, the second about prompting, and the third about APIs. And this 4th module is about retrieval augmented generation and vector database. And today we'll just do the library part, LangChain, Llama Index, and Haystack. Concerning the project, we will be building the complete project on the channel, but not after this series here, because the project will take much more time and I want to split it in a different playlist. So if you would like to build alongside me the RAG project, the full project, and almost all the project of this crash course, don't forget to subscribe, and yeah, get started. So this is the process we'll be implementing today. I actually explained that in the last video about retrieval augmented generation. We'll be loading a PDF, splitting the PDF, and embedding it, creating embedding based on this PDF, and storing it. For the moment, in all of the implementation we are storing this in memory. So we don't have a normal vector store, but you can replace it with any vector store by just replacing the instance, and it will totally work. And in the second step, we'll just get a question, retrieve the related document, feed it to the prompt, and feed it to the LLM, and then get an answer out of the LLM. You will see how different frameworks like LangChain, Haystack, and Llama Index solve this RAG retrieval augmented generation problem. As you can see here, we still have our LangChain memory. We stopped with semantic search here, where we just did some embeddings and similarity search from the embedding that we had, the in-memory embeddings. So let's just come here, let's put this in this global framework, and we'll create a new file here in the RAG called LangChain. Okay, so in this file, we'll be implementing the LangChain retrieval augmented generation. The first thing we need to do, we already have all the packages that we need, and if we need more, we'll just install them. But the first thing that we need to do is to actually import the necessary packages. And the necessary packages are actually just here. Let me just put it here and I will explain it to you. We have them here, okay? So we have the document, just to represent a normal document. We have the PDF loader, we already used it. We have the in-memory vector store, which is the vector store of our whole RAG process, but just in memory. We have the OpenAI embeddings to compute the embeddings. We have the chat to just send the request to the LLM. We have the retrieval Q&A, which is actually the LangChain module to easily do retrieval augmented generation. We have the splitter here to split text, and then we have the env to load the keys. So first thing, of course, is to load the env variables here. So we have OpenAI in the OpenAI API key in the env variable, and our LangChain module can use it. And the second thing is to create our vector store. Our vector store actually needs an embedding algorithm. We can pass many different embedding algorithms. Okay, as I explained it before, the data that we get is computed an embedding is computed on that data and saved in the data store. So that's the reason why when you have a data store here, you need to pass a specific embedding instance. And this embedding instance in our case is OpenAI. It can be a specific package from Hugging Face or a specific provider like Anthropic or Google. You are free to choose here. We just choose OpenAI embedding here. Now we need to work on our document. Working on our document means loading it and splitting it. We already saw how to load a document. We use our module PDF loader. We pass the name of the file and we just call the load method. As you can see here, we have the loader. We call our instance of of loader and we pass the startup file and then we load. Here we have a list of documents. Now we need to split this document in chunks and we decide how large that chunk will be. We can use the recursive character text splitter from LangChain to do that. So what we do is we create a new instance of our splitter that will go through a given document and split it by chunk of 1,000. Why do we need an overlap? So if you get a text, maybe let me write some random, let me look for some random text here. Okay, let me explain this to you. Let's create a new file. Let's say we have a text like this, okay? This is actually quite long. Let's say we have this text, for example, okay? Let's just go here so we can have the paragraphs. Just some lorem ipsum. Let's say we want to split it by, I don't know, 100 characters. Let's say the splitter cut this part of the text like this. We are just counting 1,000 characters and cutting it, okay? If we cut it like this, we will have a lost context, which means this part here before the dot will be lost. What we need to do is to keep one part of this and one part of this in each of our embedding, which means this is the overlap to make sure that if you cut it at the wrong place like this, you still have enough information to augment and have the full picture of the complete text. So if you retrieve two different documents, the overlap will make sure that this kind of chunking here is prevented. Losing information in between chunking is prevented. So that's the reason why we have a chunk overlap here. So it will be splitting 1,000 and having an overlap and just keeping an extra just in case you cut it at the wrong place. Okay, and now we call the text splitter. Our text splitter will just split our documents, the documents that we get from this. Okay, pretty simple, pretty basic. As I mentioned, you don't have to do this yourself. The framework is doing everything for you. Now, what we need is just to save our chunks as on the image, okay? So this first part, it's quite simple, okay? I will show it to you on the text again. It's the first. So if you look at this again, we load the document, we split it, already done, we embed it, and we save it. So we did these 4 steps with these single lines of code. Okay. So now we need to create the second part, which is creating a model and querying this model. Okay. So now we need a new instance of our LLMs because we need LLM to do that. And for LangChain, it's pretty simple. We just create a new instance of our Q&A chain here with the retrieval Q&A, and we pass the LLM. We pass the retriever that we have already. Let me check. Oh, sorry, I forgot to create the retriever. So the retriever is just here. It's just a module that will get the vector store and use it as a retriever, which means now we can send a sentence and retrieve the closest top K element that are that match that sentence. So now we pass it here and we have this chain type to be stuff. So now next we have a query, right? Let's say our query is as here. Where is it? LangChain memory, where we wanted something about infrastructure and aviation. Okay, let's create this query like this. Okay, this is our query, and we just simply call Q&A chain.invoke and we pass a query, and then we just print the response. You will see here, where is it again? Okay, so we are asking just infrastructure and aviation. Normally we have some text about infrastructure, but not about aviation. Okay, and if we try this out, we do Python rag. Oh, we first go into Python frameworks. Oh, CD framework, sorry. We activate the source CDN /in /activate. Okay, that's done. Now we can do Python rag and then LangChain rag. So if you ask for this, you will see that the process is a bit longer here. It's getting some information from our vector store. It's actually first getting the document, splitting the document, saving it in the vector store. You need to do it this one time, right? This whole thing one time when you have the document. So you don't need to do it every time you run your code. And then this step is actually just getting the information from the vector store and then using it to add the context to the LLM, which is what the retriever is easily doing based on the query that you pass. And then you are able to get a response based on what you ask for. So you can see here that we don't have something specific about aviation, which makes complete sense, right? Now let's ask something that's actually part of our document, which is maybe this, okay? This query here. We have the document is actually RFS from YC talking about startup and LLMs. So we have something about infrastructure and LLMs. Let's ask this. Taking some time. And you can see the difference now. When you get real information, the AI is actually able to process and say, oh, I got something from the context. And this is what this is the answer you're looking for. Okay. Startup fund project related to infrastructure for LLMs in the context of compliance and all these tasks. So this is based on the data that has been extracted from our document. So you can see how easy it is to create a RAG with LangChain. Normally creating a production ready RAG is a bit more complex than this. And as I mentioned in the last video, I will do a complete separate playlist about that. And I will also put a playlist in the description so you can go through the LangChain official tutorial on how to create a complete RAG. You can have much more advanced topics there. With that said, let's go to the next part, which is doing the same thing with Haystack. Okay, so with Haystack, we somehow have the same process, but we have a more verbose code because we need to create a pipeline to do everything. We need two pipelines actually. As you can see on the image, we have the first pipeline to index the data and put it into a vector store. The second is just to query the data, and for that we need a lot of libraries. Okay, so the libraries here are just OS and path as usual. I don't think we need OS action. Okay, we need pipeline to create pipelines. We need answer builder to build answers. We already saw this in the past video. Prompt builder to build a prompt based on some templates. The OpenAI generator, the PyPDF document, the OpenAI document embedder, quite important, to embed this document and save them in the vector store. The document writer to write this document in the vector store. The in-memory embedding retriever to retrieve data from the in-memory vector store. The in-memory document store, the OpenAI chat generator, just to use the LLM. The OpenAI text embedder, this is to embed the query that you get from the user. So it's not a document, it's actually just some text. And you get this text, you pass it to your same model, and the retriever will go to the vector store and get the related documents. I think we imported this twice. The in-memory store already, the Py same document cleaner. Okay, this document cleaner is just some other process part of your pipeline to just make sure your document is clean, remove some extra things that may not be necessary. Same for splitting here. We already talked about that. It's just chunking the documents. Document writer, already imported. Chat from builder and then chat message. I will show you how to use this later. So now, first thing first, we need to load the env to have the variables as well. Okay. Okay. Then we need, as you can see here in our LangChain haystack. Is it the right one? Yeah, I think haystack text. We had somewhere here prompt. But this prompt is really basic. We do not have some kind of for loop in there and many other things. And also this is made for completions. So if you want to use a chat model, we need a chat template here that will say chat message and pass the prompts. Okay. So what we need to do here is to create a new template, a new prompt template
that's a bit more advanced than what we did before, and I will explain that to you here. Okay. So here you will see that we have a follow. Okay, it's like a template engine. We look over all the documents and we print the documented content. We did that somewhere here, if you remember. Where's it again? Hashtag. We had oh no, it wasn't there. Okay, so in the first tutorial about Haystack, we did that, looping through the documents and printing the document that we have. So here it's the same thing, but this is in our prompt. So Haystack will take care of getting this document object and looping and feeding the context with this list of documents. And same for the question that we'll need to fill up, so the query that the user will be asked, it will be sending us. With that, now we need to create our document store. And as usual, we are using an in-memory document store. You can replace it with any other document store available on their website, and it will work properly. Now we need first to index these documents. This is the first pipeline. As I mentioned in the breakdown of Haystack, everything in Haystack is actually a pipeline. So you need an indexing pipeline. And this indexing pipeline, we just create it by doing something like this, indexing pipeline. And then we add all the components to this pipeline. So we have the first component, which is converter. This converter will just take the document and convert it into text. The cleaner will clean the document. The splitter will split the document in sentences. The embedder will embed the documents, and the writer will write the document in the vector store. Pretty simple. This is clear and straightforward. Complete process to pre-process your data and save it in the vector store. Now we need to connect them. Okay, we need to say when you go from converter to cleaner, cleaner to splitter, and order. So we do it like this. So normally you can just say from converter to writer. If you want to, I'm just trying to say that you can go from the first component to the last one. You don't have to say first, second, third. It's free. It's up to you. So here we connect the converter to the cleaner to splitter, splitter to embedder, embedder to writer. So what we need now is just an index pipeline that run, and we pass the list of documents. But before that, let's create our second pipeline. Our second pipeline will be about retrieving the information and passing it to an AI, right? To the LLM to get the answer from it. So this is our sample pipeline. The sample pipeline is our RAG pipeline that will get the first embedding of the query, of the user query, okay? This first component will transform the user query into embedding. So let me show you that in the browser. So as you see it here, we have a question, and we need to transform this question into embedding and get the related documents to it. So that's what our first component is doing, getting this text, transforming into embedding, and the next will be retrieving the related documents to that text, okay? Okay, so the second will be to retrieve the related documents, as I mentioned, using our document store that we already have up there. So it will be saving in the same document store that we'll be using to retrieve the data. And then we need to add more components just to contact the LLM and get the answer. So when we get the documents here, we now create our prompt. I will show you that in the connection, that we go from the retriever to the prompt. And then this prompt is passed to the AI model here. And this AI model is actually used to generate the answer. So now the connections between our modules is here. That we say, okay, we get the text embedder, it will give us back embeddings, and the retriever query embedding is the part that will use the result from this. We'll use this embedding as result to go in the in-memory retriever and get the right documents. And the retriever will be, the answer from the retriever will be fed to the prompt builder, and the prompt extracted from the prompt builder will be passed as an LLM messages. Okay, will be passed as a parameter to this LLM messages. Same. We can simply grow our architecture so you can see. So if we run this, you just need here Python rag and then hashtag rag. It will create an image here if everything is right, and this image is this one. You'll see that this is a bit more complex. You have the text embedder, creating the embedding and passing it to the retriever, and the retriever will get some documents and passing it to the prompt builder, and the prompt builder will actually just get some prompt and pass it to here, our LLMs, as messages, I think maybe, yes. And then this LLM will get the replies, and it's the end of our pipeline. Okay.
So we can comment this. We don't need it anymore. So what we need now is to create the documents, pass the document to the indexing pipeline, and then get the query and pass the query to the RAG pipeline and try to get an answer. So first, we just create our PDF loader here. We convert this. We apply it to our file, our startup file, to get a list of documents. And then we call our indexing pipeline to index these documents, this document. So the result from this will be splitted text, as you can see here, embedded, and then write splitted text written into our vector database. Okay. So at the end of this, we have a vector store with all the embeddings and the related data. Now, the second step is to just get a question like this, okay, the query, and then ask to the RAG pipeline to generate an answer based on that. So this part here needs to be run one time. And this part is what you're doing when the user asks for a query every single time. But in our case, we're using an in-memory store. So if you run it separately, you can actually store it on the file system. But if you run it separately, you may lose the data. Okay. So here we have the query, and we run our RAG pipeline now and saying, okay, use this text, and for the text embedder, pass this question as the text. Okay, it will get this question, apply this first OpenAI text embedder to it, and then pass it to other layer of our pipeline. And then for the prompt builder, we need also to pass the question. Okay, because in our prompt template here, we have a question parameter. Great. And then we just call this and get the reply. So let's save this. And then try to call this again. Taking some time. Okay, so you can see the document highlights several key about infrastructure and LLMs, increase the amount of compute resource, need for innovative infrastructure solutions. So this is actually generated by AI based on the documents that we pass in our pipeline. And you can see that maybe this is a bit longer, but it is clearer and simpler to build, in my opinion. You have a more structured way of working, and you have a better understanding of what's happening in your application. Here, you have a lot of abstractions, which makes it a bit complex to know what is actually going on in between your processes. But with the pipeline structure here, you know exactly what's doing what and who is passing which information to which other layer. So you have a bit more control over every single part of your RAG pipeline. Okay. So with that said, let's go to the last one, which is Llama index. We need to pass a RAG here to make sure we avoid cyclic import. And you will see that with Llama index, it's kind of the same as with LangChain. It's easily, pretty abstracted. So we have and simplified as well. We have here, as usual, PDF loader, the path to just path to specific path, and splitter, vector store, the OpenAI embeddings, and then .env, and then we load .env as usual as the first step to get the environment variables. Now we put two settings. The settings will be the embeddings model and the chat model, the LLM. So the global app will use this in the process. Okay. So, and here we load our documents. Okay. We load our documents. Same. We actually talked about it here. Where is it again? LangChain. We did it here already in the last video. We load the document, and here we actually just faded the whole document to the app. But the difference here is now that we are saving the document in some vector store, retrieving the related chunk of this document to feed it to the new LLM. Okay. So now you will see how easy it is to parse this document, chunk them, and save them in a vector store. You create this node parser, and you pass your chunk size here. It can be 1,000, it can be whatever you want. And then this node is kind of simple. You just get the nodes from the document, and then you create a vector store and you pass this node to this vector store. Okay. Now this vector store here will save things in memory, but you can create a new instance of this vector store with separate vector store that can save things in a real database. Okay. And when you have this index, the simple thing that you need to do is to transform this index to actually be a an engine query, a query engine, so we can directly do what we did here, which is getting the embedding, retrieving, all the process from this indexing here is actually simplified here as index as query engine. Okay, and we get the top 5 documents. With that said, the only thing remaining here is just to get an answer from our LLM. So we get same thing, query engine the query, and we get response. So you will see that the step between saving the data in the vector store and querying it is pretty simple here and extremely abstracted. Okay, so we can try it. We can try it now. Rack, and then llama index with the rack. Okay. The report discussed the need for new startup in at-risk key areas like data center, compliance, and other. So if you ask the same question as we had here in hashtag about what insight, about LLM infrastructures, and also the size of the response, the quality of the response actually depend also on the quality of your prompt. So feel free to change this and modify this. But in general, this is how you do the simplest RAG possible with these 3 different frameworks. So you can see how many abstraction a framework has over on other framework, how easy it is to use one framework over another framework. So you'll see here the document discuss need to fast and most effective data center. It's actually what the document is talking about. So they are pretty right here, and you saw it on the top here that when you have nothing about so when the model do not have an answer about what you're asking for, the model can say, oh, I don't have any specific information about this, which prevent a lot of hallucinations, right? Yes. So concerning the project, as I mentioned in the beginning of the video, we'll do it separately on the channel. So we'll it's just the need for me to have enough time to build a really complete project and get into complex topics instead of simple projects, so you can actually learn something really meaningful. Okay, so in the next module, we'll talk about AI agents. I hope this RAG module were completed enough for you to understand and have a better overview of retrieval augmented generation. Thank you for watching, and see you in the next module about AI agents. Hello everyone, welcome back to the module 5 of our AI engineering crash course. In this module, we'll talk about AI agents. Before that, we went through a simple presentation of AI engineering, prompting, we went through different APIs and different LLM frameworks, we went through retrieval augmented generation, and here we are talking about AI agents. AI agents are really popular right now and seems to be the go-to way to build effective LLM applications. So in this module, we'll talk about AI agents in general, the introduction to the concept, and I will show you with different frameworks how to build AI agents. And at the end, I was planning to do a project, but we'll do the project on the channel later to have the time to build a complete and useful product at the end. So let's get started. When talking about AI agents, we have a lot of confusion about the definition of the term, what it actually means, what we can consider as agent or not. And I think this article is the best article we can have on the subject, the article from Anthropic. They're actually defining what an AI agent is. They are going through different type of AI agents and also how to build them. Okay, so different paradigm and different way to orchestrate agents. I did a first video about this. I will just be going through it briefly. I will put the link to the complete video in the description where I go through each concept and try to explain it. So as you can see here, the first thing we remark is that when you talk about AI agents, we have the term augmented LLM here. So LLM is actually just a model where you give an input and you get an output. But with the augmented LLM, you have many other components. So we have input, output, but you have 3 more components. The first component is a knowledge base, where the LLM can query and get knowledge from. We have the tool component that the LLM can call to perform specific actions, and we have the memory that the LLM can call also to remind itself from some steps, from previous steps. So this is quite important because all of the single agents that we have in a composition, in an orchestration of agents, need to have these components Okay, at least few, one, two, or three of these components. So now, according to Anthropic, we have two different type of AI agents. We have workflow agents and we have real AI agents. So workflow agents, as the name can definitely tell, means orchestration in general. So it just means you chain multiple LLM to do a specific task. So it can be something like this, just chaining them. It can be so the term here, the recurring term here is that you have a predictable set of step to take to perform the whole workflow. Okay, so in this case, you call the first LLM, you get the gate, you call the second LLM, or you exit, or you call the third LLM and you output. So this can be considered as an AI agent, but actually the workflow, a workflow type of AI agent. And as you can see here, it's just chaining different LLMs. Same for down here when you have a router calling. So you can predict what will happen. Okay, you can predict what the LLM will do based on the input. You can say, okay, the LLM gets the router and call one of these tools and get the output. So this is a finite amount of step that the LLM can take to actually perform the action that's given. Okay. Internally, these agents can be calling tools, getting knowledge from a knowledge base, or directly requesting some few things from the memory. But in general, these are some kind of orchestration you can build with LLM. Same for other things here. You can see different paradigm, parallelization, orchestrator workers. I think the most interesting is this one, evaluation optimizer. And I will show you that, I will show you how to build one of these, especially this one, with CrewAI, with LangGraph, and with AutoGen. Swarm AI is still in development, so we'll not be talking about it here. Same for AutoGen somehow, but yeah, we can still get it and provide some few concepts about the latest version of AutoGen. But what I can also add is that at the end here, you will see agents. And the agents here needs to be independent. So I think you will have the term somewhere here. The independency of the LLMs of the agents is a key concept, a key differentiator from the workflow. Okay, so here, for example, you give an input to the LLM, or you interact with the LLM to give inputs to the LLM, and the LLM interact with the environment. The environment can be tools, it can be interpreter, it can be a browser, it can be many other things, and is able to come back with a solution and give you the solution, or just give you an output, right? And here you cannot define clearly the LLM will do this and this and this. You just give an input to the LLM, you get an output. So why do we have to differentiate between those two? If you come to this scenario here, okay, you have a specific set of things that the AI should be doing, okay, to perform a specific task. Here, it looks like more of a workflow. So it means when the LLM gets better, your overall process will not get extremely good. It may get good at the same task, but it will not be exponential. But when you go here, where you give more independence to the LLM, when the LLM capabilities goes up, your whole application capability goes up as well, because the LLM is kind of free in this environment. So the accuracy in overall action, in overall tool calling, overall interaction with environment is going up because of the LLM capabilities. And also in this case, you can build much more complex things that are not binded to a specific path. Okay, and it gives more flexibility to the application you're building at the end. But I have to give you a caution here. Most of these agents, like pure agents app, are not probably ready for production yet, because you have a lot of uncertainty. You cannot really have a stable solution at the end, and many other things. But with a workflow, you are more likely to create something that can be production ready, because you're controlling the whole pipeline somehow. You're controlling the whole process. But here, you cannot really control and make sure that it will behave the way it should every single time. So I think with better LLMs, we'll get better agents at the end, and we'll have a great use case with independent agent doing great things. Something I need to add as well is actually a team of LLMs, or a team of agents, which is quite interesting. I don't think it's in this article. So what you can do also is to have a team of LLMs working together. So they are still free to choose tools, to take knowledge, to interact with the environment. But they can also communicate to perform specific tasks. I think it will be giving a lot of power to AI agents in the future, to make it possible for these agents to perform much more complex tasks. So it can be a team of AI agents making replacing it, maybe not a good term, but helping a complete marketing team to do customer research, or just to do outreach at scale and things like that. So this is also a concept that we need to consider when we talk about AI agents in general. Okay, so with that said, I gave some really brief introduction to AI agents. Let me give you some trends of frameworks that we'll be using and we'll be talking about in this video. So if you look at Google, let me check. If you look at Google Trends, you will see that we have LangGraph, AutoGen, and CrewAI popularity changing over time. AutoGen was the first framework, the most popular framework to build AI agents in terms of Star in GitHub and many other. But recently they had some controversy that made the framework less useful for production, because they changed the complete architecture from one version to another, from 0.2 to 0.4. The main person that initiated the project at Microsoft went away, created a new framework. So the framework is not quite stable right now. I think they released a kind of better version, like a stable version, back in January, but they're still down. So that's the reason why these other frameworks are getting ahead of AutoGen at the moment. And it seems like LangGraph is the go-to framework right now to build AI agents. And why? Because I will show you that in the code. With CrewAI, you can build things in a high level, but with LangGraph, you can go deeper and actually create this complex flow. And I will also show you the LangGraph article showing you how to build each of these workflows and AI agents using the frameworks. And it's pretty easy because, as you can see here, we have some kind of graph-based architecture. And LangGraph actually is made of graph. So you can build each of these workflows with LangGraph directly and easily without any complication. So I'll be showing that in the next video. So thank you for watching, and see you in the next part of the program. Hello everyone, welcome back to our AI engineering crash course. In this video, we'll talk about CrewAI as an AI agent framework. In the last video, we introduced agent frameworks in general, and we didn't talk about OpenAI functions because we did that in the third module already. Now, let's talk about CrewAI. To build AI agents, as I mentioned in the last video, you need frameworks to organize the whole process. If you try to do it with tools calling, as you saw it in the third module, it will be extremely hard to maintain. You'll have to call a lot of function manually, to have numerous functions to define the structure of your tool manually. It's just a mess. And frameworks help you do that easily. It gives you tools, it gives you an orchestration layer, it gives you anything you need to actually work with AI agents. And CrewAI is the simplest way to build AI agents, in my opinion. And that's the reason why we are starting with CrewAI. So as you saw it here, CrewAI is not especially the most popular framework. Right now it's matching with AutoGen already, but it's not the most popular, but the simplest way to build AI agents. So if you come here, you'll see the documentation here. And to use, I will go through the code with a sample example later, but I will just give you the whole global concept around CrewAI. The first thing is agent. And as I mentioned, as I presented already, agents has different access to tools, memory, and also this memory here, and knowledge base as well. Okay. So let me check here. I think you have knowledge source here. So you have these three items first. But what CrewAI gives you as a simplification of the whole process is three main things. The possibility to find a role for your agents, the goal for your agents, and the backstory. So this replaces the whole prompt of giving this handcrafted prompt to your agents. You just give the role, the goal, and the backstory, and the agent will have some kind of purpose. Okay. And you can provide LLMs, tools, and other things if you need to. And as you can see here, It's extremely simple to do that. I will show you that in the real code later. But you can just create an agent here, pass some, this is the configuration that will give you the third goal, role, and backstory. Here you will have the tools that you need to bind to the agent, and you can also pass many other things. And as you can see here, they're simplifying things as much as possible. So you can just configure your agents using YAML and just call them or specify them here, and then you have the complete thing about your agents being able to run directly. You can also do that manually somewhere here. Okay, you can do what you're doing here with YAML manually directly in the code. Yeah, kind of the same. It wouldn't really change a lot, but this is simplifying the process for you. So you have a one file where you define all your agents with their roles, goals, and backstory, and you can directly refer to them in your code. Okay. Okay, so now after agents, you have tasks. So you first create agents, and then you create tasks that to assign to these agents. And the way to create tasks in CrewAI is actually the same. You create an object task here. And in this task, you will pass here they are calling it research task. And you can define this research task also in the YAML file here. And you give a description, the expected output, and the agent that's supposed to take care of this task. You can also give an output file if you want this agent to write the response in a file. And as usual, you can do this with YAML file, and you can also do it with functions. So you can see here, you can pass the regular description here, the expected output, and the agent that will be performing the task. Okay. So you have the concept of tasks, of agents, and now crews. A crew is just a set of agents or a team of agents, as you can see it here. You can just set it here, whereas you define the agents, you define the task for these agents, and then you define a crew here. The crew will get all the agents. You will pass agents here. You'll pass a task to this crew. So it's like a group of people. So let's imagine it as a class, okay? And you pick 5 people and you give them a specific task or specific project to work on. So it's the same here. You create multiple agents and you give them tasks. And you define how they are supposed to work on this task. It can be sequential, so going from one task to another, or hierarchical. I don't know how to say that. Hierarchical, you can see it here. Sequential, hierarchical. Yeah. The crew will actually pick the task and work on it based on the process that you put in place. Okay. Now the flows is a way on top of CrewAI to define complex flows, if I can say it like that. That cannot be created with sample attributes. So you can create a class flow here that will define what's happened when a flow is executed. So you start by, okay, you start by doing this, and then it listens to when this finish, this will happen. When this finish, this will happen. So it's kind of a sequential thing, but you define the process using this flow method here. Now, what about the knowledge? Knowledge is pretty simple. Same, you just create a knowledge base and you pass it to your crew here as knowledge source. Okay. The LLM, same. You have a panoply of LLM that you can choose from for CrewAI, and you just define this LLM and pass it to your crew as well. Okay. And processes. Processes here, we talked about it already. And you have many other things like memory. Memory here, we talk about memory in agents. It's a way for you to say, okay, keep what's going on. Okay, keep it for a certain amount of time so you can come back to it, and you can save this permanently if you want to using vector stores or just simple local stores like like SQLite. And here you have much more things. You have tools, which are quite interesting. You can work with CrewAI tools or LangChain tools. And in the LangChain video, I show you a lot of tools that you can work with. So CrewAI support these tools. It can be a search tool, it can be code interpreter tool to actually interpret your code. It can be Office, Slack, Twilio. So you can connect many tools to your CrewAI agent as well. In the same way, same thing, pretty simple. You create an agent and you pass the tool to the agent like this, just as simple as this. And I will show that to you in a few seconds. Okay. So with that said, I think this variables is just to say, show me what you're doing. Okay. So give details, print details about your process.
Yeah, I hope this gave you a good overview of CrewAI. You can go through the documentation. It's pretty simple. You can pick it up pretty quickly, and then you're good to go. Okay, so now let's go into a concrete example working with CrewAI on the simple task of creating a YouTube script. So I still have my whole code base from a few videos ago here. Okay, so what we need is we had framework. Now we need agents. This is from framework Harak from the last module. So let's stop this and create a new terminal. We go into the agent folder. We need a .env as usual, but here we'll be installing the package progressively. So let's create a file called CrewAI test .py, and in this file we'll be putting everything we need to work with CrewAI. But first, let's install the necessary modules. To install CrewAI, you need to just install CrewAI. It's just a package, but you need to install tools as well to be able to use tools that comes with CrewAI. And you can do that with one single line of code like this: pip install crew and tool. But before that, we need to create our virtual env as usual. I completely forgot that. Okay, pip env venv venv. Okay. Oh, it's Python. So pip. So that's good. Then resource venv bin activate. Okay, so now we can install our package again. Okay, taking some time. So in the meantime, I can already show you how to build up with the CrewAI. So let me first just import some modules as usual. So we first import everything we need here. The only thing new here is CrewAI here. That will be coming from this package that's being installed here. And it will give you agent, task, crew, process. We talk about it. I presented them. And also the SERP tool from the CrewAI tools. This will give you the possibility to search online, because we want to do some small research online to be able to write a proper YouTube script. And this, as usual, is just load the .env. And for the .env, we need, as we are using the search tool, we need two keys. We need the OpenAI key, and we also need the SERP tool key. Okay, and for that, you just need to go to the SERP API website and create an account there. Let me just show you, and you'll get an API key. So you just, when you create an account, you have free 2,500 requests, I think, and you just click on API key here. You click on copy, and you paste it in your file. Okay, so I will just be deleting this key afterward. So let me give it to you here. So I have both of my keys here, the SERP key and the OpenAI API key. Okay, so with that, now I can start working on my agent. So the first thing we need to define is our, our agents. As simple as that. We can directly start working with our agents. And to define our agents, we can just say, give them a name. Let's say, okay, our research agent will go online, because as you can see here, our research agents is actually have the backstory of summarizing what the research that he made online, and research any topic provided to concise. So we'll give a topic to this research agent, and you will go online, search for specific things about, and summarize it so that the next agent, which is actually the script writer agent, can take it and work with it. Okay, so you can directly pass a tool here, or you can pass it directly to the crew. So I think I show you in the documentation how to pass the tool to the agent, or also show you how to pass the tool to the crew directly. So here we have the script writer. Same thing, role, goal, backstory. You can write this better, right? You can write better backstories, better goals. It will help the model be better overall. And the LLM also, I just chose 3.5 because it's cheaper, and AI agents can be quite expensive. So yeah, with that, we need the evaluator. The evaluator will just say, okay, this is good or this is not good. Okay. Your skill critical reading and editing, whatever. Okay. Same. Now, when we have this, what do we need to do? We need to define our task. And to define our task, we can directly do it with just the list of tasks. We have the first task, which is researching, okay, which will be actually performed by the researcher. So let's say task. And here we have the research task, same description of the task, expected output, and the agent that will perform it. We have the script task. Okay, same thing, description, expected output, agent, and context research task, because we need the response from the research task to be able to perform this, and some sample output file to be able to write the result in a specific file. Okay, now we need the last thing, which is actually our crew, the definition of our crew. Our YouTube script crew here will take the research agent, the script writer agent, and then the research task and the script writing task, and then perform a sequential process on top of that. And then we have the tools here, the subtool, and we have the memory, and we have the variables to say, okay, print what you're doing as well. So if we save this, and we do Python crew.py, CrewAI test.py, we are not getting any response. So let me, oh yeah, that makes sense. Why? We need to run our agents by calling the kickoff, the agent.kickoff function. Okay. So simply we give the topic to our agents. So let's say here topic is equal to how to write better content online. And then we can do something like this, call our function like this, youtube.kickoff, and then you pass the input, which is our topic. And we can directly print the output. Okay. With that said, we can now execute this again, and you will see some actions in the terminal, some green text, hopefully. Okay, you can see now that the researcher is called with a specific goal, and now it's gathering you write engaging headline. So the researcher finished the work and gave us the bullet points that the next agent will take, which is actually the script writer. Okay, we have the script writer here. Yeah. Okay, so we have our YouTube script here. So as you see here, I didn't add the reviewer. So we can just add the reviewer here simply by adding the evaluator agent here. You pass it here. You add the evaluation task. If I still have it, I think. Let me check the evaluation task. So let me create it. I don't have the evaluation task already. So let me just create it here. Evaluation task. Evaluate this content. And we need here, we need the script task as context. And the person that will perform this is the evaluator agent. Okay, so now we can call this again and give this the evaluation task. Okay, so good. We can clear this. Run this again. The researcher, okay. The bullet points, okay. The script writer, okay.
we have the first graph, okay, the evaluator, okay, and then we have the second graph, okay. So this is some sample, as you can see here, some sample of how you can actually make different agents work or do something special. So in this case, we have a simple sequential process. One pass to the next one and pass to the next one and pass to the next one. And then second part of this tutorial where we'll talk about LangGraph, I'll actually first show you a different way of building all of these different workflows that we saw on Anthropic with LangGraph. And then I will show you how to build a special kind of workflow where you have a generator and an evaluator using LangGraph. Okay. Yes, so thank you for watching and see you in the next one. Hello everyone, welcome back to our AI engineering crash course. In this video, we'll talk about LangGraph, and I will be presenting you globally what LangGraph is, how you can build different workflows with LangGraph, and we'll do a specific practical use case. Okay. In the past videos, we talk about AI agents in general, CrewAI, and in the next video, we'll talk about AutoGen and with some sample introduction to Swarm. So let's get started. The best way to describe LangGraph, as you can see in the name, is to say it's an AI agent framework on top of LangChain. We talk about LangChain in the APIs part. I'll put the link to the word playlist in the description. And it's a specific way of building agents with LangGraph, with LangChain, okay? LangChain has a way of building AI agents before, and then here they changed the paradigm to actually use a graph-based methodology to work with AI agents. Okay, so as you can see here, they went through this really nice article that I presented a lot of time on this channel, this building effective AI agents from Anthropic, and they went and they extracted all these workflows and agents, and in this article, they're showing you how to build each of these items. So as you can see here, you have the code as well. How to build a simple LLM, augmented LLM. Simply here, you have the tool, you have, you bind the tool to the LLM, same, a tool, you bind the tool to the LLM, and you invoke the tool. It's actually this simple thing here, okay? And this LLM actually have memory already, but not the retrieval part for the moment. But you can build also complex workflow with it, like this prompt chaining here. So you have the first, and then you stop at the gate, and then you go to the next thing. So the way LangGraph do this is with a graph-based architecture. And this graph-based architecture means you have nodes, the starting nodes, the end nodes, and intermediate nodes. And you have connections or edges between these nodes. So you have a connection between in and the first item. And you also have conditional nodes like here. It allows you to encapsulate all of these different kind of workflows. So these nodes here has like a function that will define where it will go, either here or there. Okay, and just this is a direct connection between this and this. So when it will start, we'll directly go to this LLM call, and when we get to the second LLM call here, we'll directly go to the third LLM call. So in this specific case here, we have a really simple way of designing our AI agents. Maybe the implementation is a bit more complex than CrewAI, but the thinking is simple in terms of workflow or complex systems. I think LangGraph is better. Okay, if you want to build complex systems that involve many layers, many components, and you need to have a really complex workflow, LangGraph will help you do that in a better way, a much more maintainable way, in my opinion. A bit more code, but you have more control over what you're doing. Okay, so here you have some simple example for this flow. Here you have the this is for structure output. We did that in last videos from our AI engineering crash course. We have here just nodes. You define nodes, and you see that each time the nodes have something called state. This state keep what order are doing and give it back to the next one. So it's kind of oh, sorry, this is not I think we are using it back here instead. somewhere where we need it, but we don't need it here. So this is just the structure, the structure of our graph state. If it was output, if it was the structure output, we'll have base model here instead. So this is the structure of our graph state to say, okay, we'll be keeping this and this and this and this. And so and as you can see here, we are returning joke here with this message here, and you can get back state of joke and do something else with it in the checkpoint line, for example. Same for other different orchestration or different workflows. Yeah, same for the router. And you will see at the bottom here a sample example of an agent. No, this is Evaluation Optimizer. We'll be building this for our YouTube script. So you'll see that we don't have a sequential process as we did with CrewAI. We'll have a researcher here, and then a generator, an evaluator, and then we have a loop between the generator and the evaluator, okay, until we get the solution or the end result that we want, and then we can move out of the loop. Yeah, and I was trying to show you here the agent here and the way they build the agent here. So you have a set of tools, and you bind these tools to your LLM. And yeah, in general, you give freedom to the LLM to call each of these tools to perform a specific task that's given, okay? Yeah, so I think this is a good resource. I'll put it in the description for you to learn a bit more about how to implement each of these workflow or agents using LangGraph. So now let's choose one and work with it, okay? Yes, so as usual, we still have here an empty file that we need to create, LangChain, LangGraph test file. Okay, and we need to first install the necessary package, okay? The package that we will need for the use case. And these packages are simply LangChain. I think you can see it from the beginning of the, let me show you. If you go at the top, maybe you'll need to click on some blue things to see it. You'll see it here, install dependency. You copy this dependency and install them, and you have all the tools you need to work with LangGraph. Okay, click here, and yeah, and you paste it here. Paste. Okay, installing the packages, it's done. So now that we have that, we can start coding, okay? And as usual, we need this like this. We need this to be able to have structure output because we need that for our LLM. We have the graph state here, the start, the end, and the state graph. We have the model here, and we need to load our env as usual. So first, let's load our env, create our OpenAI chat instance, and as usual, this is the same way you will do it with LangGraph, with LangChain, sorry. So nothing new here. You can go back to the LangChain video to understand a bit more about LangChain. And now we need to start creating our agents, if I can call them that way, okay? The first agent we'll need to have is just a tool. It's the evaluator tool that we'll call the LLM and classify if what we did is good or not, okay? So we'll have here a grade. The grade can be approved or need improvement, and some feedback that will be feeding that will be given back to the generator or the writer. And we just bind this here, this structure output to our LLM, okay? And the LLM will be getting this as input and generating the output that actually match this description here, okay? So when we have our evaluator, we now can create some state for our LLM, for our agent. So we now have the state, we need the topic, the research, the script, the evaluation grade, the evaluation feedback as well. That will be keeping track. We will be keeping track of all of these throughout the code. So now we need to define our nodes. So let's say nodes. So the first node is the search. Then, as you can see, it's pretty simple. We have the search, we invoke the prompt, and simply return the result into the research part, and we return the state. We need the writer. The writer here kind of have the same thing, right? You are given a script, you have the result from the research, and if you have evaluation feedback, you consider them. And because we'll have a loop there. So if we don't have evaluation feedback, we just get both of these, okay? And then we call the prompt, same thing. We call the LLM and we get the content, okay? So now we need the evaluator, right? That will just be giving us the feedbacks. As you can see here, it's still pretty simple. Script evaluator will just call this script evaluator here to give us a structural output. And from this output, we have the grade and the feedback that we add to the state, and we return the state here. Now we need a specific thing that I will add later, which will help us route the end result to the script writer again or to a final result. But let me show you how to first build your graph. You'll see that it's pretty similar to how we did it with Haystack, or how we did the RAGs with Haystack. You first create this builder here and you add nodes to it. I think we did something similar with Haystack, right? If you recall. We add the nodes, the search, the write script, and the evaluator, and now we had the relationship between these nodes. Okay. We start at the research called the write script called the evaluator. Now we need something pretty specific. We need the loop back thing. So if the evaluator said this is not good enough, we need to go back to the writer again and say write this again with these feedbacks. And for that, we need this builder. We need a conditional edge, and this conditional edge needs a specific function. This specific function will get the response from the states and be able to say, oh, that's good, you can go to the end node, or no, let's go back to writer and he will be writing some other thing. So this is our function. Simple. You get what is in the state. If it is approved, you return approved. If it is not approved, and you return it improvement. And if you go back here, when it's approved, you go to end. You need improvement, you go to call LLM call write script again. Okay. And with that, what we need is just to compile our graph and we are ready to use it. Okay. And to use it, we need an initial state to our agent. We define the structure of the agent somewhere here. So we need an initial state to it. It can be just empty screen or whatever you want. And in our case, we have the topic secret of homemade pizza. We can just replace it with the topic that we have here to have some comparability. I think I wrote it the wrong way here online. Okay. So, and the grade is basically just need improvement for the moment. It's just a placeholder. And then now we can run our graph. And to run our graph, we just need to call this invoke function. And we pass it the initial state. As you can see right now, almost we have this invoke everywhere in LangChain. So in LangChain here. So now we can print all our results with all the states, because at the end of the loops, we'll have all these states being given a specific value, right? Because we are updating them everywhere. We're updating them here, updating them here. So at the end, we just print off all our state, our internal state like this. You have the final state of topic, the research, the script, the grade, the evaluation feedback. And then here, with that said, we can actually run this and see what we get. Python LangGraph test. Okay, so great. If I have this, like you can see that this seems far more elaborated than what we got before. This is what we got from CrewAI. We didn't have this loop. We didn't have this. Maybe it's because I wrote on learn instead of online, but we didn't have this loop. And we stopped here at this include. It was pretty short, not that good with the sequential process. But now that we have a loop and we have an improvement from one node to another, you can see that the script seems far more better, right? It's longer, it's feel more natural, and yeah, and we have the final grade here, approve. It's well structured, provide value, and really good feedback. So here, this is how we built this script writer and script evaluator loop into a lang chain using LangGraph. And here, and as I mentioned, I'll be putting the link to other to the whole article showing you how to build other type of workflows with LangGraph in the description. So thank you for watching. In the next video, we'll talk about AutoGen and how they changed, we have different versions of AutoGen, and what you can quickly build with AutoGen 0.4, the latest version. Hello everyone, welcome back to our AI engineering crash course. In this video, we'll talk about AutoGen. But before that, we went through different topics already, like APIs, Retrieval Generation, prompting, and in this module, we went through a simple basic introduction to AI agents. We talk about CrewAI, we talk about LangGraph, and in this part of the video, we'll talk about AutoGen. But actually, it's AutoGen. As you can see from their website here, AutoGen is a framework from Microsoft. So you can see Microsoft directly here in the link. Made to be a simple way of building agentic AI. And the good thing about this is they are providing you a UI to build agents as well. So you don't have to do it only via code, which is pretty good, right? And it's quite popular. I think it is the most star, almost 40,000 star. If I look at LangGraph, for example, on GitHub, you'll see that we have only 9,000 here. So it's one of the most popular AI agent framework, but due to some kind of controversy, you can see everywhere some warnings saying, hey, this is the official project. We are not affiliated to this and this because something happened in between the transition from version 0.2 to version 0.4. And now we have AutoGen 2.0. We have AutoGen 0. We have AutoGen 0.2, AutoGen 0.4, and we have AG2. I think it's a fork from the original creator of AutoGen, and this version is also quite similar to the version 0.2. Okay, it's kind of the same process, the same functions, the same architecture in general. So, and also one thing here is that you will see maybe we have the same core from 0.2 to 0.4. Microsoft said, or the team at AutoGen said, they will be maintaining the version 0.2. Not quite sure it will last along, like they will do it for years, but for this video, we'll be using 0.4, and I'll be showing you how to build simple things. It's actually kind of the same API as 0.2, but we have much more tools and simple way to do things on top of this. Okay, so what I can first say about AutoGen is that it is one of the easiest way to build orchestration-based AI agents. So you can just create a chat group. Funny enough, a chat group where AI agents can talk and give you a result. You have human in the loop. You have tools. You have code execution directly. You have you can actually install and use a Chrome Playwright instance and just scroll the internet and work with it. So I think the version 0.4 is kind of pretty complete. You also have the Agent Studio, as you can see it here. You install it and you can run it on your browser and create agents visually, which is quite interesting as well. So I would say it's more complete, but it's pretty new. So that's the reason, maybe the reason why it's not that popular for the moment. But yeah, let me just show you how you can build a simple AI agents using AutoGen. As usual, we need to create a file here, AutoGen underscore test apply. And first thing first, we need to install our modules, right? And our modules are actually two different modules. We need to install this one. Let me clear the chat first so you can see. You need to install AutoGen with OpenAI, okay? And then you need to install AutoGen chat. You can see all this in the documentation as well. So now we already have the .env and everything in .env. So we do the same thing as usual. We import all the necessary functions. So this is for us to be able to execute asynchronous functions, because we have some asynchronous functions in the process of building this agent with AutoGen. We have AutoGen's modules here. The Robin group chat just means we give everyone have his turn. You talk and then you pass to the next one, and then just do a round like that. We have to take termination. Before, you had to manually check if the AI said something, but in this case here, you have this way to just say, okay, when this is said, just stop the chat. Yeah, we have the OpenAI client, and then the .m. So it first load our variables, and let's simulate some search tools. Okay, I don't want to build a complete search tool here. We'll just say, okay, we'll simulate this as a search tool. We don't have, or I didn't see a way for the moment to directly connect tools as LangGraph help to do, or as CrewAI help you to do. Right now, you need to write this tool yourself. It's kind of taking time. You need to integrate the API manually. So I just simulate it this way. You can replace it with your custom tool, write the implementation for it. It can be to play a song somewhere or to get the weather somewhere. But this is the way you do it. Okay, so now let's define our main function. And in this main function, we will create first our model. Okay, we'll not create our model, but instantiate our model. Now we need our agents, and the simple way to do this is just to create some instance of agents. This is our researcher agents. We have the description, we have the system message, we have the tools that the agent will be using, and we have the model client, okay, which is our model. Now we need our writer assistant, okay, and we'll just let them talk. Okay, we have our critic assistants, so they will be talking. The first will be researching, the second will be writing, the third will be giving feedbacks, and then start over again. And we have the termination text here to just say, I think we say it here. If you say approve, we stop the whole process. Okay, we stop the whole chat process. So when the critic will say approved, you get out of your chat group, of your chat discussion. Okay, so here we have the group chat, which will be our orchestration layer, if I can say it like that. We pass the tools, we say, determination condition. And this is quite important because they can just talk for the whole day. You need to specify the max number of turns that they can have in this round robin group chat. Okay, they can talk maximum 5 times each. Okay, and then after that they automatically stop the process. And now what we need to do is to give that an initial task. This is the initial task, how to start a successful virtual tool. Like this one, let's give the same as we had here. How to write better content online. AutoGen test. Here, how to write better content online. Okay. And then we can directly run and work with our chat like this. Okay, I think I just need some other parameters like outputs true false. This will print our statistic to say, okay, this happened, we had this number of tokens, and this will be closing our print. Okay, we don't even need to print this. So now we need to call our function, and the simple way to call it is an asynchronous function. That's the reason why we have this. We can just do async io.run main. Okay, so let me explain this again. We have here, we're just loading it. We have the tool here, and as you can see, we have just the agents that we are defining, as we will do with CrewAI, for example. And then here we have some kind of orchestration part where we'll say, okay, here, 3 of you, like these 3 people, you'll be talking this specific way using this programming group chat, and you have maximum 5 turn, and this is when you stop. Okay, and we create a task and we pass it to our group chat. They start talking in this group chat, and we get the response out. Okay, so now normally we don't need to print this, but now we can just say Python I think we need to first install some packages. We did that already. Yes, okay. Now we do Python AutoGen test. Taking some time. You will see that some things are happening here. So try to call the function, and the function just said, oh, yeah, get this back, okay? And then here we have a planner. You know, this the researcher and the writer just give like these bullet points that we'll be working with. Now let's move on drafting the script. As you can see here, we have the writer here that's doing many things internally, okay? So the writer is alone doing multiple things, multiple calls. The writer graphed a plan and wrote something based on this plan, and the I think the end critique just said, yo, this is good, just stop, okay, and we got the stop word, and then yeah, we moved out of our of our process. So here we get the result, the whole result, and we have here our end script. And as you can see, this looks better also than CrewAI because of the process that's being used in general. And as you can see here, we use different kind of workflow to build these three things. The CrewAI part was just a sequential workflow. The LangGraph was a reviewer and generator, and this one is simply some kind of, how can I say it? Some kind of group chat where you have a team of AI talking and giving you a response at the end. Yeah, so I hope you had a good introduction to AutoGen. You can go to their documentation and have a bit more understanding of what they're doing. I'm not sure the 0.2 will be maintained for a long time. Not sure the 0.4 will be what it is today. But yeah, in general, this is how you build simple AI agents using AutoGen. Yeah, so thank you for watching, and see you in the next video. Hello and welcome to our AI engineering crash course. In this video, we'll just talk about AI agents in general, and I will give you a conclusion of the global AI agents module. Okay, so before this video, we talked about AI engineering in general, prompting, different APIs and different hosting methods for LLMs. We also talk about retrieval augmented generation. So this is the fifth module of our AI engineering crash course. If you haven't watched this whole series, I'll put the link to the playlist in the description. And yeah, in this fifth module, we went through AI agents in general. We talked about CrewAI, LangGraph, and AutoGen, but we didn't talk about Swarm. Why? OpenAI Swarm is a new framework built by OpenAI. At this date, it's still in beta, and it's not that special as a framework. So it's special in terms of maybe how it works, but it's not completely different in terms of structure or architecture. And also AutoGen 0.2 already integrate this swarm mechanism, so you can build the same logic with AutoGen without having to use the OpenAI Swarm framework. So it's just unstable, and it doesn't make sense to put it in this course here. Apart from that, I wanted to just give you a global overview about AI agents, because so far we saw how agents can be interesting, how you can build them, what are AI agents, and the different frameworks that simplify the process for you. But now building AI agents projects can be quite challenging, especially when you want to go with this project in production. Having a stable AI agency is really hard. You may have some proof of concept that are really good, but having a stable AI agency is really, really hard at the moment. So maybe in the future it will be easier. Using these frameworks is good, but you need to be monitoring your cost and making sure that you don't have infinite loops in there, AI agents talking for complete days and burning tokens. And you also need to make sure that security is it's considered, because when you start adding tools to your workflow, you may end up having file manipulation on your operating system, and it may delete important files. You may end up having AI being able to execute specific code on your computer that may harm either your computer or your whole network. So you need to be careful about that and always run an AI agent that execute code or make direct call in some kind of sample environment until you're sure that the call will always be contained. Okay. So, and apart from that, I think it's one of the most exciting things about AI right now, and maybe in the future as well. So you'll be able to automate whole process or whole jobs or whole department with AI agents in the future, I think. But so learning it right now is quite important. I will be putting in a description a lot of resources. So if you have any question, don't forget to put them in the comment section below. Yeah, if you like the whole series so far, just drop a like to the video and don't forget to subscribe. And also, I forgot to mention that concerning the project, we will have a series of projects on the channel, and this project will be related to our AI engineering crash course. So the concept that you will be learning now, we'll be applying it on the channel with a really long series of product that we'll be building using this AI agent. So it will be a real product. So it will take time to build. That's the reason why I didn't put project directly into the course, because it will make the course really long. So just to say that on the channel, we will be building extremely long videos, going through the process of building real production ready AI apps. And also we did some sample small video with LangGraph already, building an AI sales automation platform. You can find the video on the channel. And here we'll be doing much more advanced videos. So don't forget to subscribe to learn how to build effective AI applications. So thank you for watching and see you in the next one. Hello everyone, welcome back to the module 6 of our AI engineering crash course. In this module, we'll talk about open source tools, libraries, and models, and we'll start by presenting Hugging Face. So before that, we went through a simple presentation of AI and AI engineering. We talked about prompting. We talked about APIs, or of the main providers API in hosting infrastructure. We talked about retrieval generation, and we went through AI agents as well to give you all the tools that you need to become a good AI engineer. In this part of the course, we'll talk about Hugging Face in general. I'll talk about open source models. We'll talk about how to deploy these models, how to fine-tune these models, and then I'll briefly give you the tools and the general knowledge that you need to navigate the open source landscape of LLMs. So let's get started. So what is Hugging Face? We cannot talk about open source AI in general without introducing Hugging Face. Hugging Face is like GitHub for AI models. It is actually the hub where you can find almost anything you need to build a model on your own at a really, really low price. Okay. So maybe recently you saw the news about DeepSeek that trained a model at $6 million, right? You as a small company, you don't have $6 million to train an AI model. It's just too expensive. But you have a few hundred or thousand to be able to change the perspective of this model to suit your use case, right? And Hugging Face provides everything you need to do that. It's actually a hub where you can find models, like open source models. You can see DeepSeek here, DeepSeek image generation tool here, the version of DeepSeek that you can run on your computer, and many other models. You can maybe find audio text to text, image to text models, object detection models. So you don't only have LLMs here, you have much more. You have so many models to do so many different things. Recently, they provided something pretty interesting for you to test these models directly online. So if you go to the space up there, you can actually search anything you want here in this like really directory of AI models. It's called AI app directory. So you can do so many things. It can be using Midjourney to generate images, chatting with DeepSeek. So you can actually explore these models directly on Hugging Face before going and using them on your own computer. Okay, so you can actually switch. You have Quencoder, surely Code Llama as well. So you can actually filter out by use cases, image generation, and other. So Hugging Face in general gives you all the tools that you need to build, fine tune, host, share AI models. Okay, so let's first start by the first thing, which is building AI models. If you come to the documentation here, you'll see that you have so many libraries from Hugging Face, JavaScript, Python, and if you come to this transformer library here, you'll see that this transformer is actually one of the most popular when you want to work on pre-trained models. So this transformer can help you load models, run them, fine-tune these models, train models, and many, many more. So you can see run inference with pipelines. It's pretty easy. 3 lines of code, and you have a model running. Here, for example, you import a module, you choose the task, like automatic speech recognition that you can find from the list of tasks under, let me go back to Hugging Face. So if you come to the models here, models, you will see the list of tasks here. Okay, you can just choose one of these tasks and pass it to the pipeline. And you can also specify the model that you want to use. This model can be, let's say you want object detection, and you choose one of these models. You can come here and copy it, and you'll see how to use this model with pipeline. Normally, when you click on use the model, sometimes it gives you the code. But as you saw it here, with 3 lines of code, you can run almost any model on. Okay, so they give you this simple, really simple way, as you can see here, pipeline with Whisper. I think we talked about Whisper from OpenAI to be able to transcribe audio to text. And here you can pass an audio and get the text directly for free, directly on your computer. Nothing you need to do. 3 lines of code. So it's pretty easy for you. You have to fine tune the pre-trained models. You have so many things that you can do with your library. So you can go through it, explore, see what you can do deeply with Hugging Face. But what I can say is that globally, Hugging Face gives you the tool, complete tool to do training, fine tuning, inference, and many other things. Okay, so with that said, let's go back to the second part of Hugging Face, which is hosting models. You yourself, you can actually create a model and host it here. You can maybe take DeepSeek, fine tune it to a specific use case, let's say coding, and then post it and other people can use it. So it's like basically GitHub for AI models. Same, you can just find what other people did. You can see that they have like 1.5 million models, and you can filter them by amount of download, and you can see that DeepSeek was downloaded 3 million times already. Yeah, so you have all these models here that you can use for your application. So how do you use this model actually? You come to DeepSeek. You have first the simple way of using DeepSeek, which is integrating it or using it with the transformer library, right? If you come here and use this model, you click on transformers, and you'll see that you have this 3 lines of code that will help you use DeepSeek locally. Okay, so you have the same thing here, message, and you pass the model name for text generation, and then you have the messages that will be extracted from the model and give to you. So you don't have a lot to do here to integrate these libraries. Same. Now, if you want to use it without coding, okay, how do you do that? Come to this. Let's say we want to use DeepSeek without coding. You just type DeepSeek. You will see all the models with DeepSeek. You search the one with GGUF at the end, like this. Okay. This is a version that has been transformed to be able to run on small devices. So if you click here, you'll see that you have more providers here, and you can see how to use these providers. It's not really the object of this video, but it's pretty easy. You can install them as you install any application on your computer and directly click on one of these icons and it opens the app, so you can directly work with this model or try using them. Okay, as long as your computer can support the specified model. So that's quite interesting, what you can do with transformers here. So you can use it directly in the code if you want to, or you can use the GGUF version to run on your computer without any coding knowledge using Llama CPP, Llama Studio, or Llama VLLM, and other tools. Yes. So with that said, we went through the model part. And also, if you go to the model again and you go to DeepSeek, if you come here, you see here that you have an organization GitHub, like the DeepSeek company can have a page, and you will see all the modules that they have published here. For example, this Yan, they published a Yan model recently, if I'm not wrong. Let me search for it. No, and click. Okay, no. Okay, this Janus Pro has been published by Hugging Face by DeepSeek. So you can try it directly here. If you click here, you will see that it's running something, and you can upload an image, describe something, and then get the response from the multimodal understanding. You can also pass here, give a prompt, and get a generated image directly on Hugging Face without nothing outside of Hugging Face. So with that said, you also, I think we went through the space to show you all the apps that you can do, that you can directly use online. So, but what you can do also with Hugging Face is actually hosting models, like hosting them somewhere else. So let's say we want to use, I don't know, DeepSeek or Llama. We use DeepSeek a lot here. Let's say Llama, and you look for Llama 3.1b, 8b instruct here, for example, and you want to deploy this model. You have a small button here called deploy, and this will give you all the providers where you can just with one click deploy it there. So if you come to influence providers, you can see that you have Firework. We talked about Firework in this video. And with Firework, you have an OpenAI like API that you can directly use. So you can directly host this model using Firework. And also you can choose other providers here like Azure ML, NVIDIA, DigitalOcean, GPU, and many other providers here. So deploying also is easy with Hugging Face. And as you can see somewhere here, as you can see somewhere here, you can also deploy them in spaces, in Hugging Face spaces, and be able to run them and work with them as well. So you can just click on create a new space. You will deploy this model online so you can work with it. Okay. So yeah, as I mentioned here, you have many possibility of using the model, fine-tuning the model, deploying the model, posting the model online, and whatever you want to do with the model, you can do it with Hugging Face. So Hugging Face enable a lot of other libraries to exist, or a lot of other companies to exist. These companies can be hosting platforms, or just in general training and fine-tuning platforms. So in the next video, we'll talk about this specifically, and how you can use one of the Hugging Face model in one of these provider easily, and have like a simple URL that you can directly integrate in your application. And I will also introduce a bit more the fine-tuning process for this app using one of these providers or the tools that you have online. Okay, so thank you for watching, and see you in the next one. Hello everyone, welcome back to the second part of the module 6 of our AI engineering crash course. Today we'll talk about fine-tuning and hosting open source models. So in the last video, we just gave a broad introduction of Hugging Face, the tool and libraries that you have with Hugging Face, and the models that you can find on Hugging Face. So now I'll talk about how to fine-tune these models and host them with a specific provider. Okay, get started. So what does fine-tuning actually means? So let's say you have a model, like you have nothing at the beginning. You have a deep learning algorithm like this. You feed a lot of data to the deep learning algorithm, just random data, right? A lot of data. And what you get back is a model. This model is good at everything that we've given in the data set, okay? So let's say your model is actually everything over the internet. So the end model that's go from this model, from this training to this, is called a pre-trained model. So this pre-trained model can be used, but in general, it's really bad at specific tasks, but really good at generic tasks. Okay. It's like GPT-3, not ChatGPT, but GPT 3.5 or GPT-2 or just simple completion models. So they are trained with on a lot of text, and they know how to complete text. So now when you need a specific use case, or you want this model to be good at one thing, let's say code generation, for example, you now need to take this base, feed it a lot of code. Okay, let's say you have codes here. You pass the code to the model. To this pre-trained model. Let's put some different color here. And the result will be a specific model that's extremely good at coding. Okay. So let's say this is the red model, and this red model is really good at coding. Okay, so the process of fine-tuning actually helps you make one of the generic model really good at what you have to perform as a task. Let's say you are in a company and your main task in this company is actually building a marketing platform or marketing tool, and you want to use an AI to be able to out to do automatic outreach and many other things. If you try to use normal, simple pre-trained models, you will have generic text, generate emails, everything will be really bad. And if you want to train or to make this model generate emails exactly as you do internally, you need to collect a lot of data, a lot of emails in a specific format. I will come to that a bit later. Train the model with it, and then we'll get a model that can actually mimic your tone or mimic your way of writing emails. Okay. But what I need to mention here is that feeding data to the model doesn't make it accurate. Not at all. It makes it good at mimicking the way you do things, but not understanding the knowledge from your data set and giving it back. So to have a model that do not hallucinate, you still need retrieval augmented generation, and you can find a video about it in the playlist in the description below. So here with the coding model, now you can integrate it into any app. It's actually same. It's actually the same model, just that you have two ways of actually training this model to get this. The first thing is to just get the parameter, the end weight of this model, and get it as a starting point to train your end model. The second is to freeze some layers of the big model and then train the remaining layers. So these are just generate concept. You can find a bit more information about this on Hugging Face, and I will put some resource in the description as well. But in general, you create a specific kind of dataset with a specific format that's adapted to the pre-trained model. You feed it to the pre-trained model, and you get a specific model at the end, right? Now let's do this practically. I will say this is one of the best notebook to show you how to do that. I think the company Breath.dev have been bought by NVIDIA, but the company were actually just giving you GPU to train and work with notebooks and maybe fine tune your models and everything around it. So now when you type Breath.dev, it will get you back to NVIDIA, and you can actually rent GPU for a specific amount of time and run your Jupyter notebook on it to fine tune specific models or things like that. Okay. So this is made for Mistral. And yeah, it's still valid for many other LLM out there because they basically have the same structure most of the time. So here, the first thing is to have the data in the specific format. You can have this fine-tuning part done by, hosting platform without having to go through all the code that you will see here. But if you want to, you can still go through the code, install the packages, load the data set, instantiate the accelerator. This is not really important unless you want to use weight and bias. This is just for using it later for inference or for testing. Loading the Mistral model here, and then here loading our tokenizer. This tokenizer also comes from Hugging Face. I think I talk about token in the introduction of the course, so you can go back there and learn a bit more about it. Here you just need to plot. It's just simple to plot the distribution of your data, of the inputs. Here generate and tokenize prompt. So you have the tokenizer here. You get the tokenizer, and you
Generate and tokenize prompt. Okay, this is to generate and tokenize the prompt. So you can go through this. I will put it in the description, and I will show you where you are doing the fine tuning and where you are actually loading QLoRa and parameters and doing the fine tuning. Okay, you can see it here. LoRa, you have this error here. That's some parameter from the QLoRa paper. You can also go in the paper and understand a bit more what happens here. But to be honest, I think from the paper they said it did not influence the result that much to have a really small or really large value here. So yes, this will help your computer support the fine tuning. Okay, so this will make sure that the big model is broken down into some kind of structure that your small computer can use, or some other computer can easily use to work with to fine tune your initial model. So you just pass the model and the configuration for LoRa, and then you have the model here with the pre-trained. You can print the trainable parameters, and you will see that some layers are actually frozen and some other layers are trainable. Okay, and then after that you can just run the training. Prepare model, and then you'll have here train coming from Hugging Face as well. Most of these parameters are actually from Hugging Face. Is from some other trainer specifying other parameters that you need for fine tuning, and then the training part. This will fine tune the model for you, and then you can save the model. You can save it in a specific checkpoint and use it later for inference. Okay, so you have some tests at the end. I'll put this in the description, but I will also show you the easy way to do this. Okay, the easiest way to do this is to go to a model, like to a platform like maybe Replicate. If you want a specific kind of model, you go to Replicate. Okay, Replicate like this. So, okay, let's click on explore here. Most of the time you have visual models, simple model, just any kind of model here. If you look maybe for, let's say, stability or stable diffusion, you'll find it here, and you can actually run it with this API and also fine tune it on the platform. Same for platforms like Fireworks or Together. I think Together gives you also a simple way of fine-tuning models and hosting them. You can actually come down there and see the pricing. Normally you'll see the pricing somewhere here. Where is it again? Yeah, somehow while working with this, you will see the pricing, and you can actually compare the pricing that you get from here. You have it here running 0.034 for stability. With Together, it's the same thing. When you create an account, I think I show you how to do that in one of the videos. You can actually go to the documentation and look for, where is it again? Search for fine tuning. And you will see how easy it is to do fine tuning here. So you prepare your dataset in this specific format, not the format that I showed before, still in JSON-L, but the format is this one now. Okay. And then you upload the file, same thing you will do with OpenAI, and then you run the fine-tuning job. Okay. And then yeah, it's fine-tune the model for you directly, and you can use the fine-tune model later. So if you don't want to go through all this training and all these phases here, you can just directly fine-tune it on a platform like Together. Talking about open source models, the models of course, and host it also on Together. I think we went through it as well. I showed you how to use this in your app directly. So I'll put the link in the description as well, so you can go through it again. But yeah, you have this platform where you can actually go from a pre-trained model to a fine-tuned model in a few seconds, or with just on some sample code. And at the end, if you want to run this notebook, you can rent a space on NVIDIA and run your notebook there, upload your data set, and also make sure to put checkpoints and download these checkpoints, because when I was using breath.dev, sometimes it just delayed your data. So I hope it's changing now that NVIDIA is managing the platform. But in general, yeah, so that's how you steer an open source model to do things that you want to do. But same with OpenAI. So if you want ChatGPT to do to be extremely good at your task, you can either use model distillation that you can also do here, which means extracting data from large language models like O3, like a bigger model like O3, and actually create this kind of data set with it, and then fine tune the small model with that as well. Yeah, so with that said, I hope the introduction to fine tuning and hosting models were actually good enough for you. If you really need more details, go to the Together, Firework, Open Router, Replicate section of this course, and you will understand a bit more about these platforms and how you can use them to host your model and how you can run them into your Python code. So thank you for watching, and see you in the next part, in the next module, where we'll be talking about image generation models. Hello everyone, welcome back to module 7 of our AI engineering crash course. In this module, we'll talk about image generation and image generation APIs. So this is a really short module, just to give you a simple introduction of the topic. So we cannot really do an AI engineering course without talking about creative AI. But before this, we went through 6 different modules, which are introduction to the whole course, prompting, APIs, retrieval augmented generations, AI agents, open source platforms, how to use and fine tune and host open source models. And in this video here, we'll just be going through simply how to use DALL-E 3 API. We already worked with GPT-4 with Vision in the last video. I explained also DALL-E, but I will just be showing you simply how to use DALL-E to generate a normal image. And I will talk about stability and some other new image generation models that you can directly use into your application. So let's get started. So if you go to the OpenAI website, you'll see that you have here API platform, okay? And if you come to start building here, you'll have somewhere, if you go to models, down there, you should have DALL-E. Okay, you should have DALL-E here. So that is actually available either directly via ChatGPT or as an API. So if you click on DALL-E 3, you will see the presentation of DALL-E 3 here with some nice images that DALL-E were able to generate. Yeah, and also if you come to the image API here, you'll see that it's really extremely simple to use the model. You just have to follow this simple instruction. It's actually the same thing that we did in the API overview. Instead of client.generate, just, instead of the path to actually work with text, you just replace the text with images. So let me show you how that can work in the code directly. So let me show you the code. So we had agents here. So let's go back to OpenAI here, and we create a file called DALL-E tested.py, and we paste it here. And as usual, we have the .m, so we need to load our m variable. So we load it like this. So we first need to import it like this here, and then load .env. Okay, so if we run this file, it's just, I think this is from the last module. We can clear this out. Come here, new terminal, go to OpenAI again, and now we can just simply run DALL-E test, and nobody will call OpenAI. We need to activate our source VM bin activate. Now, if we run this, it will take some time, and a white, oh, wait a minute. So we have here authentication error, invalid API key. So let me just grab one API key from the agents here. I think we have an OpenAI API key here that's actually valid. So I think I actually deleted this API key already. So I can just replace this with the new one, and it should be fine. Okay, so we have the generated image here that you can directly download using Python or directly view in your browser if you click copy. And I come here and visit it. You will see our image here. You can actually be fancy with the prompt, ask for specific things, or maybe let the user choose the prompt, the quality and the size. So you're free here. You can actually switch from DALL-E 3 to DALL-E 2 if you want to. Yeah, but in general, this is how you can use the model to do specific things.
Okay, so now, as you can see from this API here, you have also the possibility to edit images, but only for DALL-E 2. So you can pass an image here, like sunlight this, and pass a mask to the image, and you'll be able to describe something that will replace the mask of the image, okay, on the image. So this is the image, this is the mask, and this sunlight indoor launch area of the pool containing a flamingo. You will see the flamingo being replacing the mask, and you will see the same process as what you actually do in ChatGPT when you start highlighting a specific part for update. This is actually the same process, and same for variations or like multiple variations of the same images of the same image. DALL-E 2 only for the moment, and yeah, many other things that you can do with the API. So with that said, for the moment, I think Midjourney is still better than DALL-E. Many other image generation models are still better than DALL-E, and I personally think that open source model actually match the level of DALL-E. So if you go to Hugging Face, I think in the last module we talked about Hugging Face, and maybe we can try Janus from DeepSeek here. This model here is actually an AI generation model. As you can see in terms of output, that it's quite good. Okay, so you can use it. It's a 7B model, so you can run it easily everywhere. So you click on use on your computer, you can use it as a transformer. You do it like this, simply. But you can also fine tune it using one of these endpoints. So simple, easy. And you can also run it from a space. So you can click here, space DeepSeek AI Janus. You can come to this and actually pass the same prompt that we had from DALL-E here, which is really a basic prompt, like wait again, a white Siamese cat. This. Hopefully I can do that. Okay, look at this output and look at DALL-E output. This is open source. You can directly use it. You can download it. You don't have to pay. Simple license. And look at this output from DALL-E. So I personally think that open source models are far more better than closed source models like DALL-E or models from Google. So if you really want to use this kind of model into your app, I will just suggest you to use one of the open source model. And you can also easily, I think you can have this model in replicate. You go to replicate. You go to explore and you search here for this. Normally we should have here, okay? So you can just click here, click run with the API, and yeah, you're good to go. You are capable of using the model directly, and I see maybe you have the cost here for running this approximately to run on replicate or this amount of run for $1. And compared to the DALL-E pricing, where is it again? I think you can see somewhere here. Yes, 0.04 per image or 0.08 per image. And if you come here, you see 0.013, which seems to be a bit cheaper than using DALL-E directly, and the image is better in terms of quality than what you get from OpenAI directly. So I'm more realistic, if I can say it that way. And you don't just have you have also stability. We didn't have great models this last day. Stability with a stable diffusion model. You can also try it out. Quite good for image generation. You can directly use their platform. If you go to stability.ai, you can have an API directly on your platform without having to host it yourself. So if you come here, you just click on get started with API and you get an API key and you can work with it directly. Yeah, but in general, yeah, so you have these options to work with either open source model, closed source model as DALI, host your own model or fine-tune your own model for your own use case. So yeah, that's generally what I can say about image generation. You can also somewhere here, I think we talked about it already. If you go to vision here, you can pass images to ChatGPT or LLM for understanding, for image understanding, or just chatting with image or something like that. Yeah, so this is the vision part of the model. We already talked about it. But yeah, in general, I think this is a simple overview of this multiple way of actually using this open source model or this visual vision model, this image generation model into your app without having to spend a lot of money or yeah. So you can just run it with API. I think also Together should have it together or any other provider. So if you come to DeepSecure, normally if you can go to Yan 7. Unfortunately, we just have, okay, you can also use one of these provider to deploy it and use it like Amazon or Azure. Yes, so I hope this gave you enough information about image generation process. Thank you for watching, and in the next video, I'll just give you a brief final point about respecting the law when you work with LLM. So thank you for watching, and see you in the next video.